Hey guys, my name's Ethan and welcome to day one of our Robot in 3 Days. Here we have Team 26949, the Royal Society of Robots, with us as our guest team. We are going to put together a robot that's designed to play this year's challenge, FTC DECODE, in 15 hours of live stream spread over 3 days. So we're starting at 4 Central today. We'll be back here again at 4 Central on Monday and Tuesday, and we'll stream until 9 p.m. Central Time each of those days. I'm Ethan. I work here at GoBuilda as a mechanical engineer. Will you guys go down the line and talk about, say your name and then what you do on your team?
Okay. My name is Gage. I am the team captain, and I do programming and some of the driving.
I'm Sam. I do CAD. I do most of our CAD on the team. I'm also a secondary driver.
My name is Chris. I just started, and it's my first year doing anything like this.
That's awesome. One of the reasons that you guys ended up floating to the top of my list for teams to have as a guest on our Robot in 3 Days this year is that you were a rookie team last year and you built a very similar robot to our Robot in 3 Days to start out. You, of course, modified it a ton and made it a lot better. Took it to a bunch of premier events and off-season events after you competed in Oklahoma. Talk a little bit about what your season was like last year and how the Robot in 3 Days influenced your season.
So, starting off as a rookie team last year, we didn't really know where to start. We also started late. We started in October, and watching the Robot in 3 Days was really impactful on how the season started. Like, our robot at the end of our season had a wrist. Not exactly the same, but similar and inspired by the Robot in 3 Days build.
I think that, like, my favorite part of it, I saw you guys compete in Oklahoma because I volunteer there. I'm a ref a lot. And my favorite part is I would always forget that it was, like, based on or inspired by the Robot in 3 Days. I'd look at it and I'm like, that is a cool robot that they made. And it just, like, it would always leave my mind that this was based on the same thing. And then I'd stop and be like, okay, I can see the shoulder. Like, that's the same. I guess I can see the robot architecture, but I like that you guys changed so much of it and took it as a framework, as an idea, and then built on it every single time.
Yeah.
What was the first thing you modified and changed from the Robot in 3 Days when you guys built it?
Well, like, when we first got it, we actually never fully assembled it how it was as, like, from the kit, because we knew we wanted to make it better.
Yeah.
I mean, the first thing, of course, we assembled it with Mechanism drive.
Yep.
And we also assembled it with, like, a Viper slide on the arm, like the Robot in 3 Days from last season. And, like, we were able to incorporate some elements from that.
Yep.
But then, like, after that, like, we also were able to incorporate some new stuff. Like, we had seen how other teams were working really good with strategy, scoring specimens. And so we had, like, added a slide on the side that could score specimens, and that really helped us in early competitions.
That's awesome. I think that the thing I'm excited about today is to be able to, or this week, is to kind of do a similar thing to the starter bot. So this year, and like last year, we have a starter bot, which has built a lot of our starter kit. It's meant to be a really basic robot that can get you up and running, and it can perform the tasks for the game, but it's kind of limited. I want to take that and build on it and find the ways that we can improve it. What are the small things that are pretty quick to do and create a big return, and show off some of the ways that a team could take the framework that we show and build on it and make it awesome. So I think one of the things that we'll do a lot this week is prototype with launchers. The starter bot can only score from right up next to the game element. It's like you have to basically be touching the goal to end up shooting into the goal. Where, like, I think we're going to play a lot with, can we shoot from at least further in that same close launch zone, but maybe we can start shooting from the far launch zone. I think one of the other places that we could have improvement on this robot is for it to have a ground intake, to be able to pick up those objects right from the ground instead of having to have the human player load it. Are there any parts of this robot that stand out as, like, ways we could improve it? Things that we could do better in 3 days as opposed to right from following that guide?
Probably one thing that would be amazing to start out with is probably just changing the two-wheel basically tank drive
Mm-hmm.
and change it to mechanism so we
Yep.
could drive faster and more efficiently.
Yep, I think that makes a lot of sense. That's going to be a good upgrade for this robot. Yeah, that makes sense. I think a pretty good first thing for us to do is to get this robot over onto the field and drive it around and get kind of a sense for how it works and how we can maybe make it better, kind of understand more of the limitations more viscerally. So I say let's grab it, let's head over to the field and see what we can learn.
Yeah.
Sweet, okay. I will grab, this has got some charge in it. We can leave this battery here. I'll give you this driver station and I can grab the robot and we'll head that way. All right, so this is our field for DECODE. What were your first impressions of this game? Was there anything that stood out to you as like, oh, that's really cool, or that's going to be your big challenge? If you guys will also kind of roll over to the driver's box here. Were there any like specific things that have stood out to you in the last couple days?
Well, the first impression, I guess, with any launching game is launching can be kind of difficult.
Yeah.
Although, just being able to launch so close and having like a backdrop on the goal,
Yeah.
that definitely makes it where it opens the window, like the door for like teams to have that not to be quite as difficult
Yeah.
to make a closer launcher, but then also having more advanced launchers for farther distances.
Yeah, I'm gonna embarrass myself, but like, if you hit the backdrop, it's probably gonna stay in. Like, it is pretty easy. You have a pretty big target, really.
Yeah.
I like that there's a ramp in here that will feed it in and funnel it into the ramp. I think the thing that is the most interesting to me so far is the strategy around the pattern and the ramp, and like how you're really maximizing points that you score if you're scoring specific colors into the ramp in a specific order, and you're only scoring up to 9 at a time. I think I'm super excited about this because I see some aspects of like the power play strategy, which is a little bit before your guys' time in FTC, but where a different element might be worth a different number of points depending on all of the factors that go into that. I could definitely see teams who are scoring like 12 elements in a game maybe saying we should shoot 3 right off the bat and then run the lever, get rid of those, and then shoot our next 9 that are specific to the pattern that we're building. I think that's going to be really cool. I think we would be pretty hard pressed to talk about scoring 9 elements with this robot.
Yeah.
But I'm interested to see where our robot in 3 days ends up, because like, it's hard to say. We haven't had a shooting game like this in FTC in a long time. The last one, the most similar game to this that we've seen in FTC is Velocity Vortex, I think. I actually competed in Velocity Vortex, and when you're at that level, the best teams, we're talking about scoring maybe 20 game elements in a match. I think that's going to be low this year. A lot of that is because Velocity Vortex had a maximum of 5 balls per alliance, so there weren't very many. And so a lot of the times those elements were in the air, and robots have gotten a lot better. The robots that people build today are a lot better than the robots people were building in 2016. So I think that's going to be really interesting to see just like how many balls are people talking about scoring this year. If you want to drive this robot around a little bit, there's that controller there. That teleop mode should be already queued up. The control matches like how I would control this robot as a mechanism. So it's a first-person drive. It's just you don't have strafe on the left stick. And then the right bumper shoots. And it's the robot scores in the other way.
This way?
Yes, you got it. It's kind of like the side of this robot that looks forward is actually the back. Okay. And then you can drive it over to that alliance zone, and maybe we'll load 3 more balls in there. If you would, Chris, there are the balls to the right there.
Right.
If you'll just load those in. And if you want to turn off the flywheel, it's the button that would be B on an Xbox. It's the
Circle.
right button.
Right. Okay.
So which one turns it on?
The bumper does automatically.
I noticed that it's kind of specific where you
It is kind of, yeah.
are.
I think that'll be really an interesting challenge to like improve about this robot is like maybe we score from further away. I think that's going to be really cool. And yeah, like the skid steer is, I think a lot of it is just like very few people have actually practiced driving tank drives anymore. It's just not the standard in FTC. But I think the Mechanims are going to help a lot.
You want to
So this is an interesting robot because so much of the design is based on the ball having a lot of backspin. The reason that it actually has that forward trajectory is the backspin on the ball, as opposed to the ramp actually having an arc to it. A lot of that was just because the robot, for a starter bot, you have to be able to assemble it from assembly instructions, and so all the holes have to line up. Yeah. And there is not a great way to make like a 10-degree angle with GoBuilda parts, at least parts that were in the starter kit. So sometimes it does end up going right up.
Yeah.
Also, I noticed that it's a little, it probably won't be a problem with Mechanim, but I noticed that the weight distribution is really towards the back.
It is. There's definitely a weight distribution change there. And I think a lot of that is with a skid steer, because you only have 2 powered wheels. You kind of want a relatively equal amount of weight on each of them, or your robot will drive weird.
Yeah.
So there's a lot of weight over the driven wheels, and that makes it kind of tippy, and it also makes it kind of weird to drive. Will you hit the lever with the front part of this robot with this polycarb plate? It's kind of like, I'm so used to driving Mechanim robots there, and they're a lot easier to do this kind of thing. One of the things that really impressed me about this field is that you can hit the lever and drive away, and the balls will kind of keep the lever open, which is kind of cool.
Yeah, that's interesting.
There is a little bit of a risk though, because I've noticed that it occasionally comes down. Like,
yeah, I can totally see that.
If you like base your strategy on it, and then you come back and there's like 2 left in there, and you're like trying to get your motifs, that can mess the whole thing up.
Absolutely.
I think that a big part that might be hard this season is probably the randomization.
Yeah.
Because don't you preload and then it randomizes?
Yeah.
So the only way to know will be to use like a camera for the April tag.
Or I think you could decide not to preload, and then you could leave them there, and you could go, because these are set up in the pattern. There's one set of balls for each of these patterns. So like if your robot's pretty good at path planning and localization, you could say, read this and then go get the 3 that are correct for the pattern and then go shoot them. But like that's kind of a lot of driving, especially like if you're a robot that shoots from the far zone. I could totally see it be you needing an April tag, like a vision target to repeatedly hit the goal from way back there.
Yeah.
Like there's not a lot of error that's tolerated when you're shooting from the far goal. So I want to start talking about how we should improve this robot. So the first one I think we talked about is Mechanim wheels.
Mm-hmm. And with 4 robots on this field, and
that's gonna be crazy.
Basically 1 scoring zone.
Yeah.
I mean, there is one over there, but basically this is pretty much the only scoring zone that will be
it's gonna
used.
It's gonna be wild, because really, and especially if you're using this zone, you're kind of incentivized to go to the same place as the other alliance. Like if you're running a cycle from your human player station or from your secret tunnel, you want to kind of park right here, because this is the shortest cycle for you to actually drive, and so is the other alliance. So like, there's going to be some robot contacts.
And with all those robots driving around, all the preload, all the ones on the ground going to be knocked around.
Oh, man.
Yeah, it's just going to be bouncing all
They're going to
around.
be
Definitely going to be a need for a ground intake.
Yeah, I think that's absolutely true.
Yeah. Now, this
as
field,
well as human player loading.
Yeah, this field is kind of, compared to last season, it's a lot more open. So we may be wanting like higher RPM motors on the drivetrain, just because we have more long sprints.
There's going to be some. I'm really interested to see, like, I think a big consideration, maybe more for teams, but we need to think about it a lot too, is which of these zones we want to shoot from, because that's really going to change your cycles. Like, I don't know. I'm really excited to see where most of the balls end up on the field through the match, and to see which of these zones would be faster. I'm pretty sure that scoring from this launch zone is going to be faster a lot of the time, but it's harder. And especially, I don't think we're going to get into like April tags and automatically aiming in this robot in 3 days, but I think that'll be a very popular thing to do this year. I could see us saying like we are going to prioritize the close zone, even though the far zone might be a lot faster for a lot of cycles. I would bet at the high level of FTC, we're going to see robots that can shoot from anywhere. Like, at least most of the field. They could probably shoot from back there or up here without any issue. I think there are definitely a lot more questions when you're talking really competitive FTC. I could see stuff like a turret being really helpful this year, specifically to counter defense. Because you'll have a robot come up and just bash your robot while you're shooting. If you can turret to keep pointed at the goal, you might get a couple more shots in when you otherwise wouldn't.
Yeah. Also, the motifs.
Motifs are going to be so interesting.
Probably the best play would be like just doing it in auto.
Yeah.
And then letting them out.
Yep.
And then just kind of just randomly shooting to get points.
Yeah.
And then letting them out, and then like then at the very end, get your full motif.
I think it's going to depend a lot on how many balls you specifically will score. Like if you are saying, I think you're going to say like, hey, in practice we're scoring, 18 in total, so we're going to count on scoring 16 or like 15, and then you're saying, okay, let's shoot 6, let those 6 out, and then shoot 9. But there's a risk there. Every time in Teleop where you go and open the gate, when you might have already completed a motif, it's you might not get it all back. It's really interesting.
Yeah.
So the motifs are just to make sure everybody's on the same page. The motifs are the specific order that you shoot the balls. It'll match the randomization. So like this one that we have right now on the obelisk is purple, green, purple. So in order that should go purple, green, purple, purple, green, purple, purple, green, purple. And every one of those that is wrong, every one of those is correct is 2 points. So it's a pretty sizable benefit. There's also a ranking points advantage. So this year in FTC, we have additional ranking points you could earn. Previously, it was only 2 ranking points if you win, 1 if you tie, 0 if you lose. Now it's in addition to those, you can earn 1 for your movement, 1 for your cipher, the equivalent, the pattern, and then there's 1 more for something else that I can't think of right now. There's 3 different ranking points you can earn, which is like kind of a big deal.
Isn't it parking?
There's 1 for parking, there's 1 for motifs, and then there's the last one that I can't think of. Somebody in the chat will have it. But it's interesting because you can earn more ranking points from ranking points than you could from winning that match. It's a big swing. I think that it's easy to gloss over how much that's going to impact rankings this year. It's not really related to Robot in 3 days, but like I'm excited about that change. That's going to be really interesting in how consistently events rank teams. Okay, so we've talked about different zones we can shoot from. We want a mechanical wheels, we want a ground intake, and we want a shooter. I think it's going to be really interesting to look at how hard it's going to be to consistently hit from back there. That's going to be kind of an interesting piece of this puzzle. If it's easy to shoot from the far launch zone and maybe also have a button that can shoot from the close launch zone, I don't think the difference in motor RPM is going to be all that huge. That would be really cool. I think it would be worth it evaluating how hard is it to make a shot from the far goal from the far launch zone as opposed to the close launch zone. I think talking about motifs is also interesting because there's definitely an advantage to be able to decide what ball to shoot. Like how you as a team prioritize shooting from different places on the field versus shooting the correct color is going to be really interesting. It's probably pretty reasonable to say that a lot of teams can just intake the balls in the right order. Like I think that's going to be pretty popular this year, but obviously like I think you could say that the best robots will probably be able to index those in some way and decide which one to fire. That would be a really cool thing to have in the robot in 3 days, but it's kind of a big goal. I think the big challenge with being able to dynamically pick which color to shoot is just fitting it all in 18 inches. Like fitting a launcher and 3 balls that can each just like dynamically load in the launcher would be hard. at least without multiple launchers, which might be a good solution.
Also, the no extension past the 18.
Yeah, that's a big change.
Yeah.
So you can, and we haven't talked about endgame at all.
Yeah.
One of those big changes is that you can't extend past 18 X and Y at all, which is going to create some different shaped robots and some different robots generally.
Yeah.
Yeah.
I think that that one of the big challenges this season is really just the size of the scoring elements, because they don't look that big when you look at one, but when you think about, they're 5 inches each. So when you think about fitting 3 in an 18-inch robot, handling those and feeding those into a launcher, it's like, I feel like size is the real challenge this season.
It absolutely
We're going to
is.
need a lot of space just for 3 balls in there, because they are huge.
It's a lot. It's a lot of the volume of your robot. This is very much pulling from I'm going to say classic FTC, 2000, and this is the way we would have solved this when I competed, is that you have a magazine like this, and then you have an intake that just pulls the elements up and into the magazine. Especially when you're talking about in that era we held a lot of 5 elements at a time. It's like you have kind of an intake wall and you run into it and it would pull it all the way up and scoop it in. But we just can't do that. We don't have the space. So I think one of the big changes from this robot architecture is going to be, we can have a ground intake, and I think a ground intake is going to be pretty easy, but where do you put them before you feed them into the launcher, assuming that the launcher kind of looks like this?
Yeah.
One of the big things that we can do in the robot architecture is that we can put the launcher, we can almost rotate it 90 degrees. Right now we're shooting pretty much vertically. We can shoot a lot closer to horizontally when we're talking about shooting from here or from there. I think that's going to help.
What if the play is to just have a robot that can do, they can only hold 1 ball, but it can do so, it can move and fire really fast, and then it doesn't matter what colors in what order.
Yeah. You'd be able to just go and grab the one that's right. I think a classic thing in FTC is that it's almost always generally the fastest robots are the ones that drive the least. I think that we're going to have the most effective robot if we drive the least, but I could see us saying hey, look, we have 3 days. Maybe that's the best robot we can build in 3 days.
Yeah.
I think that I think that if our goal is to build the most competitive robot in 3 days, we might do that. But for what we're doing here, which I think is more maybe showing people, I do want to try to fit 3 in this robot.
Yeah.
I think that's going to be good for the demo and the exploration of the concepts.
Another big concern with launching less than 3 is that I feel like there's going to be a lot of teams when they're getting the motifs that one team grabs 3, launches 3, the other team comes, launches their 3. If one team launches 2 and then that team launches 3 in the motif, that entire motif is offset and it doesn't count.
Yeah, absolutely. You have to be aware of that. Driver coaches are kind of passive a lot of time in FTC. There's going to be a game for them, because you're going to have to be able to remember, hey, what is the order, what is the pattern that I'm building, and hey, did my alliance partner miss one? Because that changes a ton. That also puts a big incentive on being able to pick which of the 3 balls you have to shoot. You could probably boil that down to shooting 1 of 2. I don't know. I could go back and forth on that, because you could very easily have 2 purples that are there. Most of the balls in the field are purple. But you could probably, as a driver, actively make sure you intake at least 1 green one and 1 purple one before you intake another purple. So I think one thing that would help us, because right now we have so many ideas. There are so many ways to build this robot. I think it would be cool to start. I think we either should say, let's boil this down to how can we prototype a couple of these mechanisms, or should we could focus on what kind of shooter we can make. In my mind, there are 2 kinds of shooters we can look at. We can either make one that shoots 1 at a time, or we can make one that shoots more than 1 at a time. Not shoots more than 1 at a time, but could hypothetically. You have 2 balls that are queued up side by side that could either one could fire. How does either of those options hit you guys? Which one is more appealing to you?
I'm thinking more than 1.
I think more than 1 also, because if the maximum you can hold is 3, then you could have a shoot for purples and a shoot for a green.
Yep.
And then you could always choose.
You could create your pattern.
Yeah.
Yeah. I think that's pretty fascinating.
And then that completely
Yeah.
it completely eliminates the need to scan the isn't that called an obelisk?
Well,
This is the obelisk. You'd still want to shoot them in the right order for the obelisk, but it makes it easier. It has legs and autonomous and everything like that. But I think that it's interesting that like there was a robot that did that in the game animation. There was a robot that had 3 catapults, and it just decided which one to fire. I think that is a pretty good solution to this problem.
Yeah.
You could have one intake that could go and feed it. That makes kind of, I think 2 wide is a cool middle ground here because it doesn't make your robot so wide.
I think, to me, this looks like maybe you could just basically duplicate the shooter in the middle and just push it to the side and have another one. The flywheels would probably be powered by the same motor.
It's interesting to think that through too. Yeah.
Yeah, because you wouldn't, I guess, if you actually wanted to fire more than one ball at the same time, that would affect whether you shoot it. If they're powered off the same motor, that would probably affect the distance.
Yeah.
But if you don't, and it's just so that you have 2 shoots, you could just have basically a long flywheel or a double flywheel, and then you just need 1 motor for the whole thing.
Yep. And we have plenty of motors this year. Like there are 3 motors on this robot. You could say, hey, there will be 5 when you add Mechanim wheels. But you still have 3 more motors. One of those can be an intake, and then you could have 3 motors on a shooter. You could. I don't know that we should, but you could. I think it's interesting to think through. I haven't quite wrapped my brain around how you would decide between having 2 individually powered flywheel shooters or 1 with 2 motors. With playing with this robot, when you rapid fire them, the balls hit each other a lot. Like even just with a single flywheel, it's kind of easy to get the second ball to hit the first one and for them to collide and go in not optimal directions. So I could see wanting to have a break in between those shots anyway, and so maybe 1 flywheel, 1 with 2 motors that drive it, and then it's twice as wide would be beneficial because I was going to say because you could spin that up faster because you have 2 motors, but I'm not sure that's true. You probably have the same amount of mass on each flywheel. It probably does not dramatically increase or decrease your spin up time. That's interesting. That's in the weeds. I think we can probably say we can solve that part of that problem later. So breaking that challenge down into its elements, we have an intake and we have a shooter. I think the thing about the shooter that we have to figure out is if it's a far or a close. So I think a pretty good first stab at this might be, let's make a shooter that can, and see how hard it is to make one that can fire from the far zone. Or one that can shoot from either place. So I think it makes sense to build a drivetrain and then start constructing a launcher on that. And then we can maybe make it a single launcher for right now, see how easy it is to shoot that full distance, and then we can make it double wide. I think that's going to feel like a pretty good breakdown for today, where we can get a lot of prototyping, we can get a better understanding of the challenge, and then tomorrow we can make some better decisions because we'll be a lot more informed. Okay, I like that a lot. And then the intake, I think the intake's going to be pretty easy. I mean, we will have a roller, I bet. A roller of compliant wheels is the classic way to solve this problem. But there's lots of ways to intake balls. They're pretty easy.
I think instead, I think that boot wheels probably shouldn't be used because since it's like that, it'll probably go into the holes and then
I could totally see that.
Jam it.
Yeah,
so Deco wheels might be.
I could see that for sure. The other thing I think I tend to see in wheels that aren't, when it's not a wheel, it's like an intake star or a boot wheel, you can kind of bat the element away. If you don't grab it and pull it in immediately, it's kind of nice to have that 100% contact. I think that a wheel is going to be the better intake system. I bet a roller is going to work really well. It's really like the challenge in an intake is almost never actually getting a thing that grabs the balls. It's almost always then that has to get into the robot in a way that's consistent and productive and works every time and is fast. Okay, I think let's start to prototype a shooter. I think that's going to be our best use of time right now, and then we can start to make some better decisions So make a robot, make a drivetrain, and then see how launching goes. I like it. Okay. I definitely think the easiest way to do this is to kind of turn this 90 degrees.
Yeah.
So we'd have, which is a more classically, it's more classic looking shooter anyway. You have a wheel, you have the ball that's here, and then a track that goes up and ends up here.
Yeah.
So the ball goes around and shoots that way. We're going to be a much shallower angle, so it's going to be a lot closer to parallel.
Instead
with
of
the hand.
relying on backspin.
Exactly. I think this is going to be where we can adjust this position with maybe some beams that go, like some beams that go to this crossbar. We can adjust the length of those beams and be able to control that. I know from prototyping this robot, a really important part of it is that this backing material doesn't flex. Like when this backing material isn't very constrained, the ball can kind of go in a bunch of different directions. Like it can go, and if the ball itself can deflect your backing material, it's tough to get a consistent shooter.
Yeah, I noticed all the standoffs.
There's a bunch of steel. Those are shafts that we're using as standoffs in this kit, and they're just to try to constrain the back. And that's why it's such a weird shape. It's not very close to an arc, but it is much more consistent in shape as the ball moves through it. And that's the critical piece for consistency. Even this shooter is not as consistent as I would like it to be. Ideally, it would be better than this. And I think that's just because the back there can flex. So I think we might look at like double layering that, or maybe we just add more supports through. The struggle with this robot is that you run out of channel. Like this is almost every single piece of channel we have in the starter bot. So it was hard to add more supports, where we can add more supports with some more parts. Okay, I like it. I think we should probably make our way back over to the table at some point in a minute or so. Yeah, I like this a lot. So let's start on a drivetrain. I think we can probably split this up a little bit and have 2 people look at a drivetrain and 2 people work on a launcher mechanism, just kind of getting the basics of that assembled and everything like that. So let's head over that way. I guess we can turn off the robot. We can probably turn off that driver's station too. You can just hold.
So there's a button.
Yeah, there's a button on the bottom there.
There we go.
Right there.
We also can catch up on the chat. That's always the thing we miss over here. See if we have any questions. Okay. Sweet. I appreciate all of you guys in the chat. We've got a bunch of things.
I see Baron.
Oh yeah.
I know on Discord Baron works on. Someone named Baron works on Pedro pathing.
Okay. It very well could be. That makes sense. I want to work there. Okay. Awesome. Lots of love for Royal Society. I appreciate that you guys are in the chat as well. That helps. Okay. Working hard on catting and now hardly working because of the stream. I appreciate it. It's nice to have you guys here.
Oh yeah.
If you have questions, like we really want to be able to work with the chat and answer questions we can. If there's something you're like, man, I really hope that somebody can prototype this, we might be able to prototype it. That would be really cool. Okay. Awesome. Okay, let's start on this drivetrain. One of the things that we almost always do in Robot in 3 Days is put the motors vertically. I think I can show this robot. Let me double check. Yeah, I have last year's Robot in 3 Days here, and it's got that kind of classic go build a Robot in 3 Days drivetrain, which is 2 vertical motors for this strafer and 2 horizontal motors. One of the things I almost always do when we're building a chassis for building a robot this quick is that we leave the motors off until the end. This means you can mount stuff on this channel really easy, and you can the motors can go in either orientation, so we'll just throw those on after we have decided where to go. Okay. So we can start on that. I think it's kind of tough to decide the actual overall dimensions for sure right now, but we can take a pretty decent guess. Like we can probably start with a 17 hole long, and we can probably say let's just make it the whole 10 holes wide. Let's make it the full regular strafer size, put the wheels where they normally go, and then as we get the rest of the robot put together, we can kind of shrink and make that larger. So the first step of that is going to be some channel. So if you want to grab a couple pieces of 17 hole channel and a couple pieces of 10 hole channel.
10 you said?
17s and 10s, yeah.
Okay. Here's 2 of each. Like that, right?
Yeah, exactly.
And then the
And then I think we will just need some quad blocks will be next. And then the actual motion components. So quad blocks are over here. They should be, yeah, you got them. So we need 4 of those right now. Okay.
great.
Perfect. And then the first part of this process is that we put the quad blocks in the ends of these shorter pieces of channel using 10 mil screws. So these can go in the end, and then you can just use 4 screws, 1 in each of those corners. So I'll let you at this first one. Here's a couple of 3mm drivers.
Yeah.
You wanna?
Yeah.
Using a 3.75 inch wheel, what RPM would you recommend for the launcher? It actually depends a lot more than I would have imagined. From prototyping the starter bot, we at some point moved from 1 wheel to 2 wheels, and that changed our target RPM by like, it was a lot. We're at 1100
lift up a
ticks
bit.
per
It does,
second.
it does.
So 1100
No, it's just straight up too low.
times divided by 28 should be rotations per second.
And here's another one.
It's 1 to 1, so there's no gear ratio. Times 60. We're at 2,350 on a 70 or on a 96mm wheel. So 2,300 RPM.
Wow.
But like, I think we were at like 2,800 RPM with 1 wheel. So it depends a lot on the inertia that you have in your wheel. That's because you're putting energy into the ball to launch it. So we have spun up this wheel, and this wheel is storing kinetic energy, and then we are trying to accelerate a ball to a specific velocity for it to fly the amount of distance that we need. So when the ball first encounters the wheel, it starts transferring its kinetic energy into the ball, and depending on how much inertia it has, the wheel will stay at a higher RPM if it has more inertia. So with more inertia on your flywheel, you tend to need a slower overall speed because the average speed through the contact of the ball will actually be higher. So it's a long way to say it depends. It depends kind of a lot on the trajectory. One of the things that helps us a lot in designing systems like this is that we are really advantaged by spinning this motor slower than its maximum velocity. It's really easy to say, my shooter should work when I have applied full power to the motor and just let it spin up and go. But we have a lot of advantage in getting that wheel to spin up quickly if we actually use our encoder and we have a target RPM, and that target RPM is like half or less than half the free speed of the motor. Then our motor can apply a lot more power to get it to spin up faster. So in this case, we have a 6,000 RPM where our target velocity is 2,400. I would say if you're using a wheel of about the size that you're talking about, 3 3/4, you're probably going to be really set with a 6,000 RPM. But it's math and experimentation. I will say like those key points are big. Ideally, you should not run your wheel. You should not count on using more than more than half of your free speed of your motor. For most motors, free speeds is 3,000 RPM. Most motor free speeds is 6,000. You shouldn't count on more than 3,000 RPM out of your motor. So that means if you need your wheel to spin faster than that, you might actually gear it up. And if you need your wheel to spin a lot slower than that, you might gear it down.
So the doesn't it go on like this?
Yes.
And this is like here?
That one can be about wherever. It's by default, it's the middle hole. So it's this one
Oh,
right
really?
here. Yep. That's the default. And then the default position for this is 1 hole inset. And that's because of the hub shaft for the wheel. So that's a good point.
That makes
If we want to put
sense.
that wheel there, we actually need the bearing there installed first. And then we use 8mm screws to go into the quad blocks. And that's because if you use a longer screw, it can collide with the screws that go in from the sides. So the first thing we would need is 2 6mm bearings. and those will go inside the quad block, or inside the channels here. They go in like this, and then the quad block kind of constrains it in there.
Yeah.
So that can get screwed in on that side, and that can get screwed in on that side.
Yeah, I remember early on
Yep.
forgetting to do that and then having to take your whole drivetrain apart
Exactly.
to put your bearings in.
Yep. All right.
And like when you tighten and screws, basically, if you're going into a quad like this, or basically any time, you don't tighten screws right next to each other first. You kind of go around in a star pattern or like diagonal screws first.
Yeah, that's the way to do it. That's just so much nicer.
All right, it just makes it go together better. Like,
Chris, if you want to hop over here, we'll start looking at this shooter. So I have a 6,000 RPM motor, which is going to be a pretty good place to start on this. This is actually, normally in a motor like this, you have a gearbox, like a reduction. So this motor itself spins at 6,000 RPM, and normally you have a reduction, so your output velocity is a lot lower. In this case, this is just 1-to-1. There's actually a little plate in here that locks the output to the input. So this will be about the right speed for our motor, at least to start.
Okay.
And we might evaluate that gear ratio later on. Then the next thing we need are some wheels and hub, and then we can kind of start looking at the layout here. So let's see if I've got any of those wheels left. I know I have them on another robot. I think I might just go and grab them from that robot quick.
Okay.
Let's see. I'm trying to think of what the best way to frame this out would be to start our prototyping. I feel like it would make some sense to put it on kind of a longer U channel like this.
There's probably
We can put our wheel here, and then we can have the ball go under the wheel and then through an arc that we could create up here. So I think this is a pretty
We could
decent
probably
place to start.
attach
Let's
that,
start with
and
just
then
screwing
we
this
should
in.
attach that to
Okay.
that. So then we can just have two halves to put
Yep,
together.
and I would use the 10mm screws on this, just because we have that length
That,
available.
that.
And you'll grab the red handled screwdriver
Yeah.
there. And then you should have the 4 threads here that you can just go ahead and I like to get all 4 of those started, and then you can tighten them down. You got it.
So Joseph asked a pretty good question. Do you think it'd be better to have mechanism or go with a 2-motor tank drive? And I think for this game, since it's shooting and there's 2 launch zones, but one will most definitely be more used. And since that's the case, there's going to be a lot of robots trying to avoid each other and drive around to score. And I think that because you need more mobility and maneuverability and just speed in general, probably mechanism. I think mechanism, with its ability to, with its obvious ability to strafe, I think that might be better because the, like I said, the mobility is just so much more than a tank drive.
it can also depend on your team's budget, because for mechanism you'll need 2 more motors and mechanism wheels, which aren't extremely cheap. Although it is what you see most teams generally go with in FTC these days.
There's a lot of advantages to mechanisms. They solve so many problems so well for the scale of FTC. That being said, this is a game that's friendlier to a tank drive than we have seen recently.
Right.
Like that?
Yeah.
For some reason,
Yeah,
it looked
parking
off.
in the base zone, in
think we're
that
just
square
gonna
and end game is one of the
Yeah.
biggest
Maybe we
advantages.
should
It's
just
kind of
do
hard
this
with the
'cause
skid
it's-
steer.
The bearings in there.
Okay, so here are our 2 wheels. I just went ahead and borrowed these from another starter bot we had. So we can mount these wheels here, and then we just need some structure that will constrain like a piece of bent polycarb that can create that angle for us.
Okay.
So the best way to do that is probably going to be make this a parallel like kind of box situation,
Yeah.
and then we need to have a mount that's down below the wheel to catch the start of the ball. So let's mount the motor, because that'll be a good first way to start looking at this. Let's mount the wheel on the motor, and then we can start looking at how long those pieces of channel should all be. So this
be easier to get this one in if we turn
should
this
work
first.
pretty well. The screws should be about the right length. Yeah. And we'll go ahead and use this pattern spacer just because it makes it easier to add a second wheel if we want to.
Okay.
I'm using a 2.5 instead of a 3.
There you go.
There's not that many.
So that's all started,
This
and
might
then
be
these are the
only
2 more
three.
screws for you.
Thank you.
Yeah. So that's a hub. That hub has the right bore for the shaft that's on the motor. It's very possible that, like, in designing of a wheel, you could put the hex bore right in the wheel. We like having the round bore with the hub pattern because it lets you add like a bearing if you want this to just free spin.
Yeah.
Or if you have a different size or style shaft than we have here, it lets you use that. Okay. And then I think we're going to want probably about a 5-hole channel that goes down to support the ball underneath it. It might actually be a lot more than 5. I could see that. That's awesome.
Do you want to
Thank you.
work on?
Here.
More T-handles.
Oh, can't wait to start taping the field.
Yeah.
Funny.
Uh,
It looks to me like
There we go.
there's a lot
sweet.
more.
And then we can go ahead.
There's a
you go.
lot more this year than last year. Tape, a lot.
They said that I actually saw in the manual that when setting up the field, when those big long lines of tape, you can cut it on the tile
Yeah.
seams, so
Really?
that you can leave the tape on the tiles in between setting it up and putting it back.
That's really cool.
That's handy for sure. Okay, so this gets us a pretty decent idea of that dimension.
Yeah.
I want to see how long this piece of channel has to be. That looks like it's going to be pretty good. We can always like mount that polycarb in set. I think we could be 1 hole shorter. I think that's going to be about perfect.
How long is that? 7?
Yes. So we could have a 6-hole. And then we need some dual blocks, which is kind of the equivalent of the quad block, but for a low side channel. And we can do the same thing. We'll screw in from the sides and then into the ends.
Also, there's only 2 3 millimeter. Oh, they're all over there.
Yes, we found some more. So this, you actually can decide which sets of screws to screw in on this side. I like the face because it constrains this just a little better.
Okay.
So I'll let you go ahead and torque those 2 down, and then we can mount that to the bottom there.
Hello, Doorman. TDVS 1999.
I think that one of my favorite things about live streaming is being so wrong about names in chat. Like, some of the times it'll be somebody's actual name, and I'll be like, oh man, I very well butchered that. And then the other time I'm like, oh man, that was like something fully different, and I had no idea. It's fun, because you never feel that way until you are in the moment and have to say a chat name out loud.
Yeah. Okay. Chassis.
And then we can
Yeah.
screw
Outline
in
done.
to the end of that with these 8mm length
okay.
screws.
Now
How?
we need the
Just like that.
Oh,
Yep.
yeah.
The hub
Okay.
shaft.
And that creates,
Yeah.
because this
Hub shafts
machine
and
part has
bearings.
those threads in the other direction.
So I guess we need
Kinda
4
tough
hub
to get this
shafts,
started.
2 6mm ID bearings, and 4 8mm ID bearings.
Yes.
So then you can get each of
Um,
these started. What are you looking for? I suppose you need bearings. You also probably need hub shafts.
Yeah, I
I don't
think-
know that we have hub shafts up here. If we do, it would be in one of these bins over here.
Are they just called hub shafts?
Yes. Yeah.
Is that it?
It is. There is a version 1 and a version 2. The version 2 is what we need, and it has the end has the
And this is the version
double
1.
D shaft. Yep. We went to that style for the version 2, where it's made of 2 pieces because it reduces the
Those
amount of
ones are the
material we need to
reverse.
cut
Yeah, I'm
that
just
part
taking them
out
out. To like eliminate the possibility of grabbing. That one doesn't have a shaft. Okay, yeah, that was
There's only one of the correct ones in there.
Okay. Can you find us 3 hub shafts and then awesome, incredible, and then I need one more 6mm ID bearing. Thanks. Oh, I need one more hub shaft as well.
Half the time is just looking for parts. That's very true.
That's true.
Yeah.
It's true. Okay. So this gets us over here. We're kind of looking at some spacing. We're going to need a longer shaft than this, of course, to actually interact with the ball. But I think that spacing is starting to look right.
Yeah.
The next thing I think we will want to do is duplicate this so that we can then add the ramp and everything like
bearings.
that.
Okay.
Which bearings are they?
They are those two drawers that I pulled out there. We only have one more 6mm, so we need... John's working on getting us more 6mm
I dropped
bearings,
that.
so we need 4 8mm bearings.
How long is the long one?
Here's 4.
That is... I don't remember.
1, 2, 3, 4, 5, 6.
Well, we can start putting the
13.
ones that already have the
13 and 6,
So
right?
this is a 6mm right here.
Yeah.
Where does that go?
It's going to go.
Am I in?
And then
I think that these
dual
go
block.
one hole back. Yeah.
Okay. Hi, Brianna.
Here you go.
Thank
The dual blocks have kind of a trick to them
Okay.
because of because of all the wall sizes. There's
Yeah.
a right orientation
Okay,
and a wrong
And
orientation.
it's just
Oh,
only
I
comes
see.
to
The
one
bigger
of these-
cut in
one of
should
these
go
chassis.
toward the
Where do
channel wall.
eight
So it
ones
should go like that.
Okay.
The 8 ones go on the outside.
They do.
Yeah.
And then, you should
Yeah, I
have
do.
On the face, right?
I like through the face, yep.
Right here.
And it doesn't matter as much which screws you use
Yeah.
on into the face, or into this face. Into the end need to be 8mm,
Longer.
or they'll collide.
Okay.
And then the next thing we'll want to figure out is to the right crossbars. I honestly kind of want to flip around how this motor is mounted.
Mm-hmm.
I don't know. I think that there's ups and downs either way. It's going to be easier to create.
Doesn't it need a gear on it?
Let's do it this way. Like
Yeah,
What would be
that-
the difference if we
That's
flipped it?
something that.
there's not a lot of difference. It's just kind of if the other. We want them to match, so we can do it this way, or we could do it
I
this way,
actually know
Okay,
what
I see,
gear
I
it
see.
and it
is.
doesn't really matter. I think this is
Just be
slick.
careful here because some of these are like old versions. So
That's
looking
true.
for parts.
I think it's these, right?
You got it. Yep.
I feel like we probably want to put the gears on before we put the shafts on.
You got it. Correct.
And this
Are there
goes
4
right
up
in
there?
the middle.
Yes, there are.
And that goes in the middle hole.
Did the gears go to the
1,
inside or
2,
the outside?
It technically doesn't matter,
No.
but the outside is my preference.
Yeah.
Like that?
It doesn't matter, right?
Like that?
Oh, thanks.
Like that.
And I don't think we're attaching the motors yet, so it won't matter. So we only need 1 gear per one.
Correct.
This is a 14 long, not a 13.
Oh, good catch. Thank you. That would have been embarrassing.
That was weird for a second. I was like, where's the middle?
There's no middle. Perfect.
Okay, thank you.
Yeah.
Okay, I got my.
I'm glad you got that. I think I would have just put it together and been like, oh, darn. Okay.
So
I think assembling a strafer is kind of the fun tradition here on Robot in 3 Days. It's almost always the first thing we do. We're like, okay, we know what we're going to build. Let's go put together a strafer, and then we're going to take apart the strafer at least once through the process because we're going to want to change something about it.
yeah.
But it's so hard to make any of these decisions without the framework. Like, a very cost-effective way to build that framework is to put all this in CAD. But it is fun and it's fast to build it in real life.
Yeah.
Okay, those bearings.
What about the 6mm?
Yes.
We can do the back ones. They have bearings in them
Oh yeah.
while we're writing.
Okay, you got that.
And then these are like the moments where it's like we're all have our heads down assembling stuff and it's hard to figure out things to talk about. What are your guys' what are the things you're most excited about in this season? Not necessarily about the game, but like, is there a thing that you want to change? Is there like something that you are excited about doing this year that you haven't done in the past?
I'm
If
actually.
that's already tight.
Did I do
I'm
this
actually
wrong?
really
Did I get
excited.
too long of
so,
them?
so I learned how to
so.
Are
program.
you short ones on these?
Yes, the short
okay,
ones.
Okay.
Roadrunner last
At least
season.
I figured that out.
Yeah.
And I'm really excited to just basically forget everything I know and try and like work on a. I'm wording it really weird.
That's okay.
I'm really excited to see how Roadrunner interacts with the new field.
Yeah.
Yeah.
I know I'm really excited about, and this is, I'm going to promise this, but like, I don't know exactly when this is coming out. I really want to put together a video this year on using April tags, because they're going to be important this year. One of the things I meant to talk about over on this side is how much better April tags are this year. Like, we're used to the April tags that kind of just get taped to the outside of the field wall. And the way an April tag works is not incredibly intuitive. So it is kind of wild that you can take a single camera image of an image of a QR code looking thing, and then figure out where you are relative to that.
Yeah.
And the way you do that is by basically like untransforming the April tag from whatever shape it looks like in your camera into a square.
That one doesn't have
So if you're over to the right
gear.
and you look at a photo of an April tag, it'll be skewed in a very specific way, and exactly how it's skewed, at what angle, and in like what proportions are what tell you where you are relative to it. There's kind of only one angle that it works. So you can say, okay, I know how far away I am based on the size, and I can know where I am based on the skew. So if it is a piece of paper that's taped to the outside of a field, it's probably not going to be perfectly flat.
Yeah.
And if it's not perfectly flat, none of your measurements work, because you have assumed that it's perfectly flat. And now they are not only always in the right place because they're printed on the field, they're also always flat. So like, we should get a lot more accurate April tags now. And like, I would say use the obelisk to tell what randomization is, but use the game like the targets on the scoring objectives for localization. That's going to be really cool. So I'm excited about the intricacies there, because I think they're going to be really well used now. Okay, so we have this. The other thing I've been doing is I added some dual blocks to the ends.
Okay.
That'll let us put channels in between and make this kind of a superstructure. So there's one, and then I'll get you two
short
more.
screws for that?
They can be long screws into the side, and then short screws into
Okay,
the
I just gotta
front.
pay attention to where I put them.
Yep, that's one of like the things about building in Go Build It that's kind of like that's the hardest to always remember.
So we need one of those shafts and one bearing.
Okay, I think that it is here. Yes, here we are.
Thank you.
John and Josh are off-screen delivering parts.
I haven't opened one of these since the start of the season.
I like hub shafts. They're kind of an interesting, different way to solve the problem of where traditionally we would have a separate hub and a separate shaft. Putting it in one part is nice in a lot of ways. It can be a little bit cheaper. It can be a little more robust. We're taking away a point of failure. So it's the larger cutout that goes towards
that.
It's flipped 180.
Whoopsie.
Or do they like?
You got it.
There we go.
That's also not
normal,
incredibly intuitive.
They spin pretty well.
It'll work if you do it the other way. It will just mean that the rest of your build will be a little bit off pattern.
Oh.
So if you're expecting everything to line up, it won't quite.
Yeah, I think you might put that on first, and then that one goes on it.
And the reason they're different is one of these dimensions is what we would call an outside of channel dimension.
Yeah.
So channel, everything,
Well,
we
put it
tried
through-
to say
put
that
it on
everything in
after you
GoBuilda
go
is
through
8
that
millimeters,
area.
right?
Yeah.
We have an 8 millimeter pattern. Our channel is 48 millimeters wide. It's divisible by 8.
Yeah.
But you kind of also have another set of dimensions, which is the inside of channel stuff.
Yeah.
Inside of channel is 43 millimeter. So this is an inside of channel dimension on this side. It's 5.5 millimeters from the wall to the center, so that the outside of the channel to this hole is 8 millimeters.
Okay.
Oh.
And if you want to use
okay.
this outside of
Yeah, I
channel,
remember
you can
now.
put it in this orientation, and that
It's
means the
one
center
and
is
the
4
other.
millimeters.
Mm-hmm.
That's kind of like
Wait a second.
it's the thing that breaks it being this like super nice clean building system
Yeah.
is the fact that the channel wall, if the channel wall was 4 millimeters, it'd be awesome, but it would be really, really, really thick. 4
And
millimeter, it would be crazy. So there's the little bit of a compromise in the ideal perfect world pattern.
Yeah,
That means we have parts that are based on this 5.5 millimeter
I think
dimension.
it's just easier to put it through the screw. Put it on the screw and
And then we want this to be, I don't know, maybe 7 holes wide.
I think it goes the other way.
That's kind of overkill wide, but like that's fine.
You know?
I think 5 is too small, and I kind of want to have a center to this. Like, when you can, it's nice to build structures that have a defined center. It's
Yeah.
handy to use all channel holes that are odd lengths. Okay, so then let's go ahead and start assembling this into like a superstructure.
Okay.
So we can have
Okay,
one
now,
piece of low channel that
mechanisms?
goes here.
We don't.
Yep, and then
need
that
to
can
put
go
those
to
in.
the end,
We're
and then
gonna-
we'll have another
you know
piece
how
on
often
that
we
end.
take them on
Okay.
and
And then we
off.
could
We're
have
not
one
gonna
on the
need to-
bottom.
so
So
we
we
can
might
put
add
those
one
on
more
until
dual block.
later.
Oh, I forgot
Should
about that.
have right
There
there.
it is.
Yeah.
Sweet.
Okay,
Love
we
the
got it.
discs.
We got it pretty much done.
Okay. Okay. We can add wheels.
Yeah.
That seems pretty reasonable.
Or are we going to be taking wheels on and off?
I don't think so right now. I think the
Yeah.
first thing I want to try is testing. I think I want to keep this like as parallelized as we reasonably can.
Yeah.
So I think what we'll want to do is make this a chassis. Hopefully that'll happen not too long before we have this as a shooter, and then we can also start working on an intake. And all of that stuff will be like dependent on the height of the chassis. I think we'll have the wheels on for a little while.
Yeah. Yeah,
this
and
is-
it's not a big problem taking them off. Last season, just with the way chassis like this are built,
Yeah.
you end up taking them off like every time you make any modification.
Yep.
So
It feels like working on a car where I'm like, I was thinking about that the other day. Like, I don't know how many times I've taken the wheels on and off my car, but it's a lot. Like,
Yeah, and
It's just a thing you do all the time.
And our robot last season was it had the motors like this just in the channel.
Yep. Oh yeah, and you're dropping those motors out all the time.
Oh yeah.
It's like, oh hey, I have to get to that screw. Let's do it.
Okay, so we need it to be like that.
Yep. Yep.
And
That's
it's
correct.
X, so it's like this.
And then it'll be set in just
yeah.
yeah, that'll line up.
Maybe
nice.
we should.
Okay.
So these should be the
Come
8
around
millimeter
against
screws, the
that.
shorter screws in
yeah.
the ends.
Okay, and then
And
do we
for
need one
anyone
here?
who doesn't know,
And then
the
one on the top,
mechanism
right?
I
wheels,
think so. We might not
They-
put it on the top. We might just
they
put this
aren't
right on the channel.
same.
Okay.
The
Might right on the crossbar, but it might be easier to.
they look the
start.
same like this,
Okay.
but this one has the side that goes in deeper on this side, and this one goes deeper on this side. So with the wheels like that, putting them on like this, and then this would be this side because of the indents in the wheels.
Yep.
And when you look at it from the top, the angle of the rollers should make an X. Mm-hmm. And
Yeah.
then sort of like a square from the bottom.
If they don't, if they're wrong, your chassis will be able to. Your whole chassis will be able to pivot just by rotating the rollers. So it'll be really hard to control where your robot's going because it'll just be rotating like crazy the whole time.
Yeah.
Yeah, I think that you're on the right track by putting the wheels further. You're choosing the side of the wheel with the offset that puts them further from the channel wall. For the strafer, that's so we have clearance for the 4mm hardware underneath
Is
the
it-
wheel.
Is it tens?
So you're going through 4 and into 4, so an 8 would technically work.
Yeah.
We generally kind of like to put washers on those, so I think we would say, I mean, let's give you 9s and washers. Let's make it
Okay.
perfect. We have them.
Great.
We might as well, right?
I was surprised. I saw that you have 11 millimeter.
Yep. So 11s and 9s we use a lot. We use 11s more because they are the perfect length to go into the side of a quad block. They're the right, and then have it be flush on the inside. It's just kind of a nice thing.
I have a question.
Yeah.
I had to have done something wrong here because it was the short ones on the outside and
Yep.
the long ones on the inside. But
It should be the long ones or the short ones into the end here. And it's okay, it's okay if the side ones are short. They
Okay.
could be longer, but it doesn't really matter.
okay,
They're not gonna pull out.
I'll figure it out eventually.
It's okay. That's
Like
one of the least intuitive
hugging the
things.
robot.
And if those are 8s, they're really plenty. So I would say you can switch out those quick.
Okay.
Those can actually be 12mm long. Those can be a long screw. And it just gives you all of the thread that you'd want.
All right.
I think these should all be 8s. Yeah, I think these 2 are 10s. So those 2 can go in the side there. And then into the end here are 8mm.
Yeah,
It's starting to make sense.
Yeah.
This is a weirder thing about the building system and about dual blocks and quad blocks generally. Really, we could say just use 8mm screws everywhere and it would be fine.
Yeah.
But it is kind of nice when you have more thread available to use it into an aluminum part. It's not necessary, but it's nice. Then we can put this one here. Pedro Pathing says, love the desks. These are really fun. They are, a lot of the channel that we use in the desks are actually a pattern that is slightly older. It's like a pattern that we didn't end up going with as the final for the channel, but we had it and we had it produced. It just was like a little bit less optimal in some specific ways. So we said, hey, let's go ahead and make stuff out of it. So we have lights that are framed in channel all over. We have a bunch of tables. And like, okay, if this wouldn't be such an expensive table, this is a fantastic table. The structure is so light. You can bolt stuff to it. Like, it's really cool.
Okay.
I have a couple of these tables have like test rigs permanently bolted to them because it just works super nice.
Okay.
I had at one time I was coming back from an FTC event. I had one of these tables in the back of the truck, and there was a lady who was like, "Hey, is there any way I could just buy this table for my husband?" And I'm like, I have no idea how much I would charge for this table. I don't know how much all the parts cost. I guess probably not. It was fun, but if you could reasonably, they're sweet. Especially when they don't have the wood on. It's like you could pick it up and throw it. Okay. Trial and error. The team 12211 says, thanks for explaining everything as you go. Really helpful. Of course. This is why we do the robot in 3 days. It's fun. I think you've got it. It should thread in fairly easy. One thing you might do is loosen the other screw.
Yeah, I put that one in on the wrong side.
That's
You
okay.
put them in on the wrong side.
You can do it either way, and
Yeah.
they're both fine. So I bet now that that's loose enough, you can thread the other one in, and that'll hold everything together.
Okay. So then I put it in on the opposite side like this.
Yep. Yep, that's perfect.
Okay, I don't want to like break anything.
No, you're good.
Sometimes it feels like I'm about to snap something.
That's okay. Generally, if it's hard to thread something in, it might be because it's cross-threaded,
Yeah.
and you can pull it out and try to thread it in again. I'm not. Yeah, it looks like you
There we
got
go.
it. Perfect. Is the wheel on wrong? The chat thinks the wheel's on wrong. I think the wheel's on right.
Yeah.
Yeah, no, you got it right. It's sometimes hard with the top versus bottom of the robot, especially at this stage where it's kind of early. It's like not always clear in my brain which way is the top and which one's the bottom. It's easy to miss.
Yeah, and I think if you put them backwards, but it was based on the it was based on the like the like it was basically so the top the bottom looked like the top.
Mm-hmm.
It would work. You just have to reverse all your code, and this is just a standard that code is written.
Which screw's going into
The
those?
short ones.
Short ones, okay.
Yep. So 8s. Okay. Okay. I'm really interested to see how Swerve is this year. I think Swerve is pretty interesting. It definitely. This is a game that's really friendly to it. It's the classic with Swerve is that it's kind of hard to justify the time compared to making your mechanisms better. It's generally a pretty small advantage in the scope of FTC unless you're talking about a really high competitive end. But it's really tempting. Like when I was on an FTC team, we wanted to make Swerve, and we didn't even CAD our robots. And it's like, okay, maybe at some point the right answer is to say we should be mechanums even if it's 2% worse, because that means we can spend so much more time on the rest of the robot.
Yeah, our team, we've been wanting to try Swerve also, but it's just it has to. We've like decided that it definitely has to be kind of an off-season project, but then
Yeah.
you just don't have that much time on the off-season.
Especially when you go to 4 premiere events?
It was 2 premiere events and like 1 other invitation.
Okay, because you went to Run for the Robots, Michiana, and Cowtown.
Yeah.
That's fun.
Yes.
Which was your favorite?
For me, it was Cowtown.
Cowtown was fun.
And not because we won. That is.
You promised, right?
It's not because we won. It's because I just love the atmosphere. It was really laid back. it was just really a calm atmosphere. It wasn't like really rushed. I mean, competitions are rushed to some degree, but
I mean, yeah, part of it is kind of just the excitement of the competition, but it wasn't. It was exciting to a fun point, not exciting to a like stressed out beyond your limits point.
yeah.
Okay. I think we have two things that are kind of in flux. So right now, I think we need a coupler. That coupler can let us use just a longer shaft, and we can put 1 or 2 wheels right here in the center. And then this probably needs polycarb next to kind of get some idea for the shape. So I think that would be the other thing. Can we get like 2 sheets of polycarb grid plate? Thanks.
There is some on the table right there.
Oh, there is. That's cool. Okay, 1 sheet. So with this, we can probably just cut it in half. That's going to be plenty for 1 wheel. And because I already took a chunk out of this one, that'll be kind of nice. I've actually taken several cuts out of this one. 2, 3, 4, 6, 7, 8, 9, 10, 13. I think it's 13 and a half. Yeah, I think you cut down the center of the 14. I sure think so. Another great way to cut polycarb grid plate is a bandsaw. It definitely is doable with scissors. If you have nice scissors, that makes it easier. But you can make a really nice cut.
I think Sam brought some scissors that are pretty good.
These will work just fine.
Yeah.
You just aren't cutting through very much material at once, which makes it a lot easier.
Yeah, it's kind of. I guess it's kind of like cutting through, like chicken wire with a pair of snips as opposed to with like a grinder or something.
100%. You say that like this is a thing you've done a lot.
Yeah.
He actually, don't you have chickens?
Yeah.
Okay, there you go. Also, I feel like the most of the uses I hear about for chicken wire don't involve chickens, so I appreciate that as well. That's fun.
Yeah, chicken wire, hardware cloth, rabbit wire, that kind of stuff.
Have you made your chicken coop doors automated yet?
No.
You're in robotic. You have to, I think.
Thank you, Aunt Wanda.
Sweet. Thank you. Okay, and then we have a coupler. The easiest way to do this is going to be just direct drive this shaft. So we have a shorter shaft on the motor itself into a coupler into a longer shaft. I think this is going to be, what's 144, like 144 or 120 mil? 192 is going to work. Maybe 120. We don't need the perfect shaft length. I did the math wrong. Oh, this is a 7-hole. Okay, perfect. 192 is great. And then because this is a pretty long one, we want to make sure we have a bearing on the far side.
So I'm kind of lost. Can you explain what you're doing?
Right now we are putting, we're kind of just building a basic launcher that we can use for prototype. So we're going to just direct drive, I'm going to say 1 wheel for right now. On this shaft, we're going to build that polycarb to hopefully we'll probably have one piece as a ramp that we can feed in, and another piece that can go up and around as kind of a launcher.
How are we going to flex the polycarb again?
So the polycarb we can kind of flex by just mounting it in different places.
Okay.
So I bet we'll run a piece of structure up to grab this end of it. Right. This is one of the places that I could see a team really benefiting from CAD, because you can kind of lay a lot of the dimensions of this out, and that might help. Okay, so I need a collar on this to constrain this bearing.
What's a collar look like?
That is this piece. So when we're working with bearings, the big thing, the hard thing to do is to constrain them, to not let them move. So bearings can obviously rotate. That's the thing that they're hoping to do. They can, the inner race can roll very smoothly relative to the outer race. And then we don't want the bearing to slide on the shaft, and we want the shaft to slide on the bearings. With this, we can constrain the shaft really easily because we can tighten the pinch bolts in our coupler that's in this that's on the motor, and the motor shaft can't slide. But because our lengths don't line up perfect, we just need a collar which we can tighten on the shaft and clamp down, and that can hold the bearing in.
So I've never used collars before.
Yeah.
Are they pretty good? Like in terms of like strength?
Yes. They can, you can apply a lot of clamping force on a collar before it'll give out.
Yeah.
I think that we've used some set screw collars.
Oh, yeah.
But aren't the clamping ones? Aren't they like the set? Always the thing with set screws is your set screws, like they are just screws tightened up against hard metal. So if they just pop loose a little bit,
Yep.
and both of them happen to do it.
Yep. They're just not as consistent. One of the big things that we talk about in mechanical engineering is in ways that we can keep screws tight. You can do it in different ways. So one of the primary ways that we keep screws tight, I didn't put the wheel on, is using tension. Yeah. So this is a great example. We have a clamping coupler, and when we clamp down, we have some tension, and that does a pretty good job at keeping that screw in place. In different parts of mechanical engineering, we see different ways to call that out. One of the biggest things that you can do to keep a bolt there is to have something that has to stretch a little bit. So on the head bolts of a car, it'll actually be the bolt that elongates a little bit and keeps the threads engaged on the far side without it coming loose. In this piece, it's the aluminum that's stretching a little bit, but you can approach that problem in other ways, like using thread locker, which adds some component that dries around the threads and makes it so that you have to break that glue, that bond, in order to get it to come loose. But tension, like on a clamping collar or on a clamping hub, is really a good way, and those screws don't tend to come loose.
Yeah.
But set screws don't have that, really. Ideally, I think, in my opinion, you're going through your set screw is threaded into a steel component, and it's on a steel component, and it is steel. And so it takes a lot of torque to get any of that to stretch. So thread locker is really important because we want something that keeps that keeps the screw in place. It's really fun. There's a classic NASA paper on this, on keeping screws tight. It's the one that people reference a lot when they especially have vendetta against specific kinds of washers. They talk about, like, hey, this kind of thread retention method works. Like a lock nut works because you have to deform the plastic in order to screw everything in. That is a good thread locker, where like a split lock washer applies some tension but not very much.
Yeah.
Okay, so now we have a wheel. We have some clearance, which is great, from the ground. So we can look at how we would mount this. But first, I want to kind of start from the top and work our way down. So the first thing I want to do is try to constrain the end of this piece of polycarb.
Okay.
So I think we can hold the ball in contact. Oh, perfect. Okay, so it just has some compression here.
Yeah.
That's great. And then we want to grab the end up here. So one option is we can extend some channel vertically here and here, and then we can go across and catch the back of the polycarb, and then we can catch the end forward of that. I think that's going to be a pretty good option. So let's put 2 more pieces of channel. We're just throwing channel at this problem.
Yeah.
Let's put 2 more pieces of channel that extend up vertically here.
About how long?
Let's go 5 holes. I think that's
Okay.
going to give us some room. And it'll be easiest if we install them toward the middle, because then we have an open face.
So I have a question.
Yeah.
So is the I think it didn't call the hogback wheel?
Hogback, yep.
Are those the best for this, or would Rhino wheels or maybe even Gecko wheels be better?
So here's some dual blocks, and then this is another piece of channel. So I like hogbacks because they have very little. There's not a lot of rubber in the center that is not directly supported by plastic. The hogbacks are named after a ridge, like a set of mountains that all make a ridge that goes down the length of something. We named them that because they actually have some hard plastic that extends pretty close to the end of the rubber in the very center, and then they have excess rubber on the sides. So this means on this wheel you can compress it a little bit on the left and right side, but the center is really hard. And we can use a grippier rubber than normal because it doesn't have a whole lot of rubber to compress, and we still don't get a lot of compression. I think the other pretty reasonable option would be our 30A Rhino wheels. These are soft, and
So I've actually never seen those.
yeah, so they're nice because they're grippier.
Oh,
they are
whoa.
very soft, which means they get dirty
That's
easily.
crazy.
Too.
Oh.
And they also have a lot of rubber. The big thing, and I like both of these options pretty well. I think the hogbacks are my favorite because they're a little bit lighter.
Wow.
They are a more efficient flywheel in the way that I talk about that. So when we talk about a flywheel, traditionally we're talking about it as a method to store rotational inertia. It's to store energy. So that is defined as like the amount of mass on a ring that is a specific distance from the pivot point. So basically, the more mass you can get further away from the center, the more rotational inertia you have for the same weight. So these have not a lot. They have hard plastic, which is fairly light, and it's fairly thin out until you have a lot of rubber and hard plastic at the rim. So that means these are pretty light for the amount of rotational inertia they store. Compared to a Rhino wheel, which has more plastic and thicker plastic in the core, you need more weight in wheel to create the same rotational inertia as you would out of a hogback. But both of these options work pretty well. Geckos are another option that we've seen a lot of teams use for launchers. The big thing with these game elements is that they actually kind of have some deflection. And with a shooter, you kind of only want to deflect one thing. You either want to deflect the backdrop, the wheel, or your game element. And for these, we have a really good way. We can deflect the game element pretty easy. When we only need 1 or 2 mil of compression, like it doesn't take that much force. So I want to deflect the game element. I think that's our best option. It gets us a ton of grip, and I think that's going to be pretty consistent. Geckos will deflect, but the wheel will deflect, and that means the diameter changes, and I think it's generally a little bit worse.
And wouldn't also, since it's so soft, wouldn't also, with it spinning at such high RPM, wouldn't it do that thing called ballooning that, like those videos of RC cars lifted up off the ground, their wheels get to be about this big when they're just normal this big.
Yeah. And that, I think, what that I think does is it increases the difference in tangent velocity between a wheel that's spun up at the start of launching that ball and has put its energy into the ball at the end. I don't know I think there's a world that doesn't actually matter if you equalize the amount of inertia, but I think that we'll have a more consistent shooter with a harder wheel. I think I want a wheel that doesn't compress but is grippy, which is what we get out of the hogbacks. The hogbacks were designed kind of a little bit with shooters in mind. So I think while we're working on this, I think it would be sweet for you guys to take a crack at what an intake might look like. I think it would be great to just mount it to this chassis, and then we can start looking at like how do motors react when you have the ball. So if you guys want to grab another couple balls and make just like a roller intake that's the right height and has some compression, maybe with some Gecko wheels, I think that'll be a good option.
Yeah.
Where are these going to go?
Are we going to want to be
I
like
think they'll go vertically
popping
here.
it up?
Okay, so right there?
Yep. And I'd say let's flip them around so that instead of these,
On the outside.
Yep. And then we'll run a standoff down the length here.
Okay.
So that can form kind of the back. And yeah, I would say
Take
let's
advantage of the stool.
mount them inset from the edge.
Did I put the screws in wrong again?
Basically,
No, this is perfect.
You sure?
we're probably going to
Yes.
end up
Okay.
wanting to put it up into like a launcher or a magazine.
Yep.
All right, all right.
Oh, and then
What about
like
okay,
that.
so
I think
like-
that's going to be
hear me
good.
out.
And are those the short screws or the long
You
screws?
know
The short ones.
Short ones.
You could build a starter
Perfect.
bot from Into the Deep, had the Gecko wheels with the cut, but they were small Gecko wheels and not very wide.
Yeah, like those over
Yeah. What about that? That actually might work. No.
It'll be interesting to see whether
I still think boot wheels would like
whether a more
grab it.
cut wheel like that or even like surgical tubing wheels would compare this season to just the regular like Gecko wheels.
I think that the surgical tubing might even be too flimsy.
Yeah. Well, surgical tubing intakes, generally how they work is just that the surgical tubing is going so fast that it just kind of lifts it up and kind of hovers it into it.
Yeah.
I think the big thing, the reason that I like a solid wheel for a ball is I think it gives you a really good chance at getting good contact with the wheel with the ball right away instead of potentially batting it away. I've seen a lot of like when you have like boot wheels and surgical tubing for a ball, you can hit the very end of the surgical tubing, can kind of reach out further and it can push the ball away, as opposed to like where you have a wheel and the wheel is at kind of the right height. It can make good consistent contact and can pull it in right away. I think that's, in my experience, that's kind of my preferred way to grab balls. We can absolutely test both, though. That
Now-
would be pretty quick.
Do we want, because I could see us either taking 2 wheels like this and pulling it in this way, or we could have a bar of wheels up here that initially catches it, and then a bar back here. So basically this bar catches it, pushes it in between these, and then this bar, the second one, rolls it all the way in.
I think that's where I would probably land with it. I could see us
Yeah.
having some horizontal wheels out here to grab balls that are in the corners,
Yeah,
but I like the idea of vertical wheels that pull it in.
yeah.
I think that's probably our better bet. That's a pretty common way if you looking at like especially FRC robots of the past that have worked with these elements basically.
Yeah.
Steamworks and FRC 2017 used the same size ball, and you saw a lot. I think horizontal is going to be the way for intakes for this year.
That's such a cool name for a
Steamworks.
Yeah.
Yeah, it's good. Absolutely.
So I guess first we're going to need some like low side channels or something to lift it up. We're
I'm
also going to have
thinking-
to think about where we put a motor, or if we use a motor or a servo.
I'm thinking 3 or 4 hole. each
Yeah.
hole.
Yeah.
And I don't know, a servo may be enough. We don't want to have it spinning so fast that it just like yanks it through too fast.
That's true.
But we don't want it to be like so slow that it's like slowing down the performance of the robot.
I like motors because we have a lot of them.
Yeah.
Honestly, like we have plenty of motors. I think we might as well throw one at this.
So 3.
So that means that we actually I
think 3,
are probably
I
going
think 3.
We probably are.
Well, sorry. This should be. So these are 104. So they are. Go by 2. 52 from the center of this to the ground, and then we have 24 to the top. So the top of this channel is 76 millimeters off the ground. And then what size intake wheel do we want to use? I bet 48 mil is probably going to feel right.
Yeah.
I don't think I have any up on the wall, but that's the smallest boot wheel size there. I think that's going to feel right.
yeah.
Yeah.
Am I doing this
Or
right?
maybe the mid-size
put one-
gecko wheel.
I don't know that we'll put one
Also,
there, but I think that's
if we're using
the
a motor,
rest of that's right.
we're probably
Okay.
going to want to use a full channel on one side at least, so that you can put some bevel gears in there to have the motor facing back into the robot, so because we won't be able to have it sticking out the side.
So the ball is 127 mil in diameter. We'll add 48 for the wheel. So, or no, we will need to add 24 because we're trying to find where the shaft should be. So we had 24. We need 151 mil. So we have 151 minus 76, which is the height of this. We need to go up 75 mil. So we need to go up 3 holes, 72,
Yeah.
to have a little bit of compression at least.
So instead of 4s, we need 3s?
Technically, you need 2s if I'm thinking about this right. Because you need 3, you're right.
And what?
24, 48, 72. You need 3 holes. Yeah.
And I'm thinking that we can't just have the motor sticking out the side, so we're probably
Yeah.
going to want to have a full channel
Yeah.
on one side so it can have like bevel gears.
Absolutely. Good thinking there. Yes, that's right.
So
Like someone previously said, building is really just finding parts.
It's finding parts, especially if
Yeah.
you've never used the space before. It can be a little eclectic. So you're also going to need a quad block and a dual block, which I got here. Here we are.
Oh, thank you.
Yeah. Okay. And then on the shooter,
also, this is going to be like pretty close to the 18 inches.
Does it go
so
like this? It goes like this, right?
and then
Yeah. We're going to be pretty close to the end.
Will you grab another
of
ball
the
really quick?
18
Yep,
inches.
thank you.
So we probably don't want to make our wheels stick out any farther than the end of the robot.
Thank you.
So
Yep.
we'll want to space this so that the wheels are about like level with the front of the
We're
robot.
gonna need 8s, I would
Okay.
assume, right? Yeah.
To go on the sides?
Yes.
You can do 8s. You can also on dual blocks. You can go up to 12. So
Really?
12 is the best technically into the sides of the dual block.
Yeah.
If you have you have the 9s. Yeah, I'd grab 2 12s and make it awesome. So
And-
I say we should probably just start screwing this in.
Is
like-
it,
Okay.
is it 10s with the quad block?
11 technically, but 10s are great. Here is 4 of them.
Those are.
410s.
Thank you.
Yeah.
These are.
What screws would we use to screw those in?
This, so we have 2.5 millimeters here, 1.5 here, which is 3, 4, and then we have, we'll use lock nuts. Technically, we would need 9 mil screws. I guess we already have, but we'll use a washer, so we'll grab the 10 mil screws that we have there, and we'll grab some lock nuts.
So someone asked if we if they should do if we suggest an intake or the player loading it.
Jay, sorry about that.
Definitely.
Can you hand us the washers?
For just
Thank you.
like,
Yeah.
Thank you.
just as the whole thing, whether just to have an intake
Yeah,
or.
Where's this
So
gonna go?
based on all the robots driving
go.
around, definitely an intake.
Well, both is the best.
Yeah, both is the best. But like,
Because-
if you're gonna do one or the other, definitely an intake.
Because, well, both, if you can do both, then the human player can, because it'll be easier to, or to get your motif pattern in if you have a
flip
human
that
set it
around.
in instead of
That's
having
true.
having to
There we
drive
go.
onto balls in the right order and have
Yeah.
to chase them. So if those balls do end up in your human player zone because they got flushed out of the classifier ramp,
Didn't you say like partially away like this?
That would be really interesting. I could totally see some teams doing that, even if they have a ground intake, going and having their human player pick up 6, and then be able to reintroduce them in the right order.
yeah.
And then you'll definitely need a wrench. These are lock nuts. So lock nuts are a fantastic way to make sure your screw doesn't come loose.
Yeah.
They have a little piece of nylon that you actually have to thread into using the screw. And that piece of nylon deforms to match the shape of the screw thread.
We're probably going to want to base this on the
It just means they're
size
hard
of
to
the
thread
gecko
into,
wheels
yeah,
that
that
we're
makes
using.
sense.
Yeah. Right here?
I don't know. So the gecko
You don't
wheels,
have to get this super tight because it's going into plastic. You can kinda
we're
just
going to
tweak.
need to get
Yeah,
Whatever.
good point.
an echo wheel in a few minutes.
Oh, and they're just right over there.
Oh yeah.
We don't have any of that size here.
Oh yeah.
Go ahead and ask the two guys over there,
yeah.
John or
Can we go?
Josh. You
What?
need 48 mil geckos.
48 millimeter. How many do you think we need? Because
Let's go ahead and find a
we're probably
standoff
going to
that we
need
can
quite a
put
few
here.
because we're going
need
to
to
want them
start
like
building this
evenly
out.
spaced across a bar that goes this whole
Right
length,
here?
and then another one back here.
Yeah.
So
That's my fault.
I don't
No,
know.
it's fine. It's not very stable.
Um.
I think I'm gonna have one more thing that we need to order
Yeah.
before you head down.
Don't try
Oh,
screwing
wait,
this in.
no. Thank you.
Can you
our
like?
cable's got it.
Actually, no, I
Oh.
can't. Can you just hold it like this?
I guess
Yeah.
that makes some sense.
we can all. It's not that hard to move. So
1, 2, 3, 4, 5, 6. So I think that should be 160. Do we have 160 mil 2106 shafts? Sure, I bet not. No. What do we have? $144.
And we need
I need
126.
160.
160. Okay.
Kind of
It's
random.
yeah, it's that whole.
Perspective is the weirdest thing ever.
We could do 144 with a 14 mil spacer, which we would have. Yeah, let's do that. I'm gonna see if I have 144. I don't think I do. No. And 4.
Wait. There's gonna be a motor.
There's going to be a motor on this side.
There's gonna be a motor on the top here too.
We can lay that one down. That one
Yeah,
can be
we
in the
can-
channel.
Yeah.
We can do the vertical
We
ones
can
at the back.
we can figure the motors for the drivetrain. I think are going to be pretty easy to figure out. So we're going to get some
Pretty good.
Yeah.
shafts that can act as
Okay.
standoffs here
Okay.
and can guide the ends. And then the last thing I think we want is
Right.
Yeah.
to grab kind of the end
Or-
of this.
Actually, like those.
Yeah. Were you using the
Let's
nines?
see here.
I was using 8s. So
Okay,
I want to
where
work
were
on some
the
8s.
They're down here.
So we need 4 for this one. Cool.
So
I'll hold it for you, this one.
we're just making
One option here that would give us something that's really flexible is a beam or something that's wide here, and then we can tie down
Thank you.
to the end with like a threaded rod. Yeah, here's a bunch. How many gecko wheels do you want?
Kind of hard. We're going to want a lot if we're making a bar that goes all the way across and has them on it, and then another one too.
Yeah.
3, 4, 5, 6, 7, and 8.
Eight
Yeah.
sounds like it's probably a good number.
I think that's going to be plenty.
Yeah.
That was my guess. I don't know if I'm right.
I will try going on this corner first.
Okay, so then to do that, we would want a square beam probably that we can bolt to that, and then we can tie that square beam down to the frame.
How was the motor gonna be over here?
Basically, I think we're just going to do it the same way we do in the channel with the wheels with the
So
double
this
gears.
we can
but
screw
it's
to
gonna
this.
put
Or
Okay.
we could
and then
put
we can use like a threaded
PTO
rod,
the size
so you
of
pull
one,
that here, and then we can
one
control
whole
where that
U
ends up
channel
really precisely.
right here, and
Okay.
the drive motor.
So this is an 8 mil.
But then we'll.
that's a really bad idea. Don't do
1.5
that.
is about 10. We
And
need
also,
14
when you're
mil screws.
intaking, your robot will drive in
So we
circles.
want 14 mil screws.
No, since
Yeah.
it's a PTO, it would. Why am I even talking about that? It's a horrible idea.
Yeah.
Hey, like sometimes you have to get past the ideas that aren't the best to get to the ones that are.
Yeah.
And sometimes the crazy ideas end up being the best ones.
Yeah.
I was wrong. I need 16s. I didn't do that math
Oh.
right. Thank you.
Okay, is that good? That's a long shaft.
Yeah.
That's a really long shaft.
I think we have one that is the right length. I think we have a 264. It needs to be longer than that because that's your crossbar width. I sure think we do. Well, I'm sure we're gonna have to have John go get it. We have 288 mil. I don't know that I have a tape measure over here. Oh yeah, there's one.
Actually, whoa. I actually really love this so much.
Yeah.
And then this position doesn't matter a
Is this
ton.
centimeter tape measure? It sure looks like it. I
It
think
is a metric tape measure.
Okay, that's never seen one of those before. 26.
26, but we will want it a little bit longer.
Yeah, you'll have to catch, and then you'll probably have to catch. No, you can just do one bearing there. So
Probably
we have
28.
264. There might be a 264 in the bin there.
I think 264 is gonna be too short.
Okay, so we have a 288,
Yeah.
which would be fine.
That would actually be perfect.
Okay, I don't think we have one of those up here, so we'll have to have John go
And is
get it.
288 the longest?
We have a 312.
Yeah, I feel like that would be
Actually-
too long.
Yeah,
Nah, the bin's empty.
there's the one for the 8 Rex would be there.
Yeah, there's not any.
Okay, and it would have to be. I guess we're looking for a 288. So
Yeah.
I don't
And-
know if
And
John would
actually,
have-
I think
288.
this
Yeah.
channel
Thank
actually
you.
has to be rotated back so that the hole is facing the front.
It's kind of up to you.
That's cool.
Either of those options work.
Yeah.
You don't technically have to catch 2 bearings on that side. You can have 2 bearings total. That
Yeah.
is the technically correct way to do it, is to have 2 total bearings.
Yeah.
Here, you can fudge that rule because you have so much width. I love
Yeah.
that for showing the I like how grippy the mechanisms are now
That's
because
so
you can
cool.
show the dynamics of how it works
Yeah.
by rotating them.
I don't think I've ever played around with a drivetrain that doesn't have any motors in it.
Yeah.
Like this.
It's pretty fun. Do you just need one of those shafts?
Actually, I think we'll end up needing 2.
Okay. Perfect. I wonder what the chat
2?
is talking about.
Yeah, because we're going to have 2 rollers, one at the front and the one that pops it up at the back.
What's your guys' plan for autonomous? I don't know that we are necessarily looking at an autonomous right now. We're considering it for sure.
Let's move this.
But I don't know that that's going to be
what?
very in the
Turn
scope for
that.
this. Okay, and then
what?
the other thing
Yeah.
we need for this is just
Turn-
something to
talking
tie
about?
it
so
down.
that we can have it go through 2
to
holes since
the
we have
end.
time.
So that could be another
Wait.
beam,
Wait, it's the same number of screws.
or
What
it
am I
could be a
talking about? We
threaded
don't need to
rod
flip the
and
beam. We
linkages.
just
Let's see
flip
which
the
ones we
quad
have.
Well, we don't. Are you
What do
saying
we-
put a quad block on the other side?
No, I was talking about unscrewing these instead of.
Let's go with the
these,
beam.
but it's the same number of screws.
Well, it actually might
And
be
let's just
easier
guess.
though.
Okay.
Easier to
No,
do.
but you can't get the T handle in over here.
Okay, so
I actually love the colors of the game elements this year.
I do too. I think they're really fun.
Also, one of them is our team color.
That wouldn't have anything to do with it, right?
Also, I think, and someone in chat can correct me if I'm wrong, but I think that I'm pretty sure that over the years of FTC, yellow,
What are those parts called?
green,
Single blocks. We'll talk about it in a
purple,
sec.
and white are neutral colors.
Yellow, green, purple, and white.
Mm-hmm.
I can't think of anything else. I don't think we've ever had a black game element. I think John's gonna get this one. I think I don't know for sure.
Yeah.
He randomly gets the shaft.
Okay, we'll have to ask him when he gets back. I'm not convinced that all of this stuff is gonna end up on pattern. I think I'm just gonna kind of see if it lines up.
Yeah.
It should. It might. We'll say maybe. Okay, so you asked me about this block. This is a single block. We call it that, and we use a lot of these. We call them block mounts. Those 3 primary mounts in GoBuilda are different combinations of this part. So a quad block is 4 blocks with a piece of aluminum connecting them all. A dual block is 2 blocks and a piece of aluminum in between, and these are single blocks.
Wow.
So you can buy them in packs. So these come in a 4-pack, and they cost the same as a quad block. Or you can buy 2 dual blocks for one price of a quad block. So just all different sorts of ways to create the same joint. These are nice because we just don't need any more. I think that's going to be pretty good. I could see us making this something that's more sturdy. But for right now, at least, this is a pretty good idea to get a feel for the dimensions. I would be really tempted if this was a robot I was making for the season and we had more than 15 hours to CAD all this. The nice thing you can do in CAD is make a sketch that has the dimensions, and you can say like, okay, here's a ball of this size and the wheel of this size. Let's see what parts we should build around it.
I'm pretty sure after all of this is over, Sam's probably gonna try CADing in this entire robot.
If he wants to, we will have a CAD file for this whole robot. If you want to do it, you're more than welcome to. But yeah, we'll have a CAD file for this robot. I don't know exactly how long after the stream is over, but at some point we will publish it so that if people want to use it for inspiration, you can go ahead and do that. But yeah, working in CAD has some advantages, especially when you don't have every GoBuilda part downstairs. It's nice to CAD it and then know what parts you need before you have to buy them.
Yeah.
It's like Lego.
Yeah.
Okay, now we have it like that.
Yeah, that's the hope. The goal in designing GoBuilda is to say, can we make this basically big metal Lego?
Yeah.
When I explain what I do to people who don't know anything about robotics, I'm like, I work at a company that makes basically big metal Lego parts for making robots, and they're like, that's awesome. I'm like, it is. It's pretty fun, I will say.
Okay. Just flip the switch.
Yeah, they come.
Okay, and then this goes.
Okay.
So I'm in 3 14 mil holes, and I'm in over 1. So there. I don't know if this lines up or if everything is just flexing in the right ways that it does, but it looks like it's going pretty
Yay.
well. Okay. None of this is tight, so it can still flex a lot, and that's the thing that we're going to try to get rid of next, is like, ideally we want to be able to put some compression on the ball, but if this flexes, it's going to have kind of a crazy, wild trajectory, and it's just not going to be very
Do you
consistent.
mind if I borrow the scissors for a second?
Yeah, please.
Thank you.
So this is looking pretty good. I think this is about right. And now it'll be like, let's add some standoffs to tie this together to be kind of a backing. So we can put one here, and we can like zip tie the material to it, and that should keep it in place. So here's a couple, and I think we need a 16 millimeter spacer to make that width work out.
And what does the spacer look like? I forgot.
It'll be, I'll grab one here. Really, it's just that we don't have every increment of this.
Yeah.
So
Ooh, that is
it'll
short.
just be well, that's what we do. It's just a piece of aluminum with a 4 millimeter bore for the screw, and it's a 6 millimeter outer diameter. Then we'll get a longer screw because we have to go through the unthreaded material into the threads. So this ended up being a 30, I think, is going to be plenty. So we'll find a good place for this based on the compression. Maybe here. Yeah, I like that. And then we can go, I like to do the spacer end first because I think it's just easier to assemble this way. It's kind of hard. Whenever you're doing this where you have a standoff and a spacer as a combination, it's kind of tricky to get everything to line up right and to not cross-thread anything and all that stuff. Especially because we're doing it under tension here. Okay, so we've cut those threads. We'll go ahead and thread in this other side. One of the things that's not super intuitive about standoffs is that, like, and it's nice that they're hex. It's really tempting to like grab this with pliers to tighten it down, but a lot of times you can just alternate and like I can tighten this side until it starts to turn, and then like it's turning, I can't tighten it anymore. I'm gonna go back over to this side and tighten it. Is this?
Looks a little wonky.
It does look a little wonky. I wonder if our channels are not quite. Oh yeah, it looks like this one is one hole farther forward.
That's my fault then.
No, I think this side is the one that I like a little better. Let's
Okay.
go ahead and pull that apart quick. Honestly, like this is building robots is a lot of putting it together, trying it, taking it back apart. So this will be the next 3 days.
So move this one back, right?
Yep, back one hole,
Okay.
I think. Okay, let's see what the chat's looking at. CAD files provide great insight. They're definitely worth it.
Okay.
Oh, there were foam blocks that were black and gray in relic recovery.
Really?
Oh man, yep, that's right.
Yeah.
I competed in that game. I should have remembered that.
Now that I think about it,
I'm not sure this is gonna work. We might need the bigger gecko wheels because look.
Oh, did I do the math wrong? Oh, I bet we need more compression than 3 mil. I bet it catches where there's not holes,
Yep, right there.
and then it would not.
so maybe we could go down one hole. That's kind of too much.
yeah. So bigger gecko wheels probably.
I think that's a pretty good way to do it. You also could go down a hole, and then you could space those up. I like the idea of the 48 mil wheels. That feels like the right size to me.
Yeah.
Let's look at what would be a clean way. So okay, we said it was 76 mil off the ground. So
Actually, I bet if we cut these, it might work.
it might. I think it would be better to move the whole structure up a few. So is that right? We would say
Basically have maybe switch these to like 2 holes, but then stick spacers underneath
yeah,
it.
exactly. I think that's a pretty good option. I guess that could also be like that structure could get mounted on go rail, then it could slide up and down. I think spacers are a pretty reasonable solution here. We want to figure out how much. So I think we're at 3 millimeters of compression. Do you want to just put bearings in that and we can see how close it is when we spin it perfectly in the center there?
Yeah.
Yeah.
I think that'll give us a better picture of how much we need to adjust it by.
I also just realized that we put this channel on the wrong way, facing that way.
Oh yeah. Yep.
Is the number on the bearings the internal diameter?
Yes.
Okay.
And then if you flip this 180, that way the flat side is toward the
Oh
middle.
shoot! Yeah,
Nope. I'm glad I cut that quick.
I put that in the wrong hole too.
Oh, that's easy. I like to, and then yeah, if you go,
Over one. Right.
yes, that's correct.
There. Okay.
Yes, that's correct. I think that over time your brain like looks at the channel pattern and you can see more of this like specific places that you add screws, but it takes a while, and this is
Okay,
the
buddy.
first time building a robot, so it's an easy miss. So it should be.
This little screw.
It
keeps
looks like it's
falling
coming
out.
together
Yeah,
pretty
you got
well.
that.
It does.
That's
it does.
correct. Here, I can hold this in place.
Okay,
if
thank
you
you.
want to just put through the hole, and then just start turning it.
There we go. Thank
Yeah.
you.
Absolutely. There's lots of little techniques like that are just like, I was just doing this for a
If
while.
you had a solid wheel of these, I feel like
Actually, that's a good point. Ben just said when it's on the tiles, it would sink some.
Oh, that's true. Can I see how close that... Oh, yeah, I guess you're working on that.
Just a second.
Yeah.
I just realized that I need that bearing on the outside.
We're like scooting farther and farther away.
I'm really... let's see... Shooting games in robotics creates exciting dynamics. I'm really excited to have another shooting game. This is going to be so fun. They're just always fun.
Ever since I started robotics last season, I've been wanting a shooting game.
Yeah. I think that's... Because the last shooting game we had in FTC was 2020. Which is also a game that we didn't play a lot of because it was COVID. So a lot of seasons... That was actually like kind of the second season into COVID because it hit in January or so. In February in the US. So... We saw, I went to an event where we had just started talking about it and we like bumped elbows instead of doing the high five line. And then that was the last FTC event that season. So we played most of Skystone and then Ultimate Goal, a lot of regions played totally online.
Does that
So
work?
we missed some of it.
If you had a solid thing of them, I feel like it would pull them in, but it wouldn't pull them in like
Super
tightly.
well, yeah. I could
Like-
see some tile sync helping that. It's not ideal.
Yeah, and the plan I think was to kind of have a roller
Well,
back
also
here.
we are driving into them.
It's true.
Now, I guess the roller could be across here, the
Yeah.
second one.
Yeah.
And then whenever it,
And you
like,
like
maybe
that
through
can kind
that
of
hole.
rotate. Yep. That'd kick it up because we're gonna
Yeah.
need something that kicks it up anyway.
Yeah, and then
I
it could
can
just
see that being
it
okay.
could pull it through.
The other option, like ideally, this wheel is, say, okay, we have 3 mil of compression right now. I think in a perfect world, and that looks about right when there's no hole. But if it's sitting on a hole and the wheel is through a hole, it's pretty shy. So,
Also, do we want to make how solid do we want to make this roller? Because we don't.
yeah,
Like,
I think that it's even if we have. I think it would be best to have some space. At least that's
Yeah.
I don't want to show off this like roller that uses way more wheels than it needs to.
yeah.
I'd say like 4 more mil of compression would be awesome. That's a no, it's not. We have drop center plates. Drop center plates are a perfect solution to this problem
I've
because we
actually-
would drop it by 3 mil.
I've never heard of those.
Okay, so they're a part that comes in the FTC kit. I think they're on the other side here. I'm gonna walk into the camera. Sorry. I think there are a bunch of drop center plates on a peg right here. Is that true? Ideally, not the 3D printed ones. Yeah. They're all 3D printed. That's hilarious. Okay. Oh, okay. Thanks.
Yeah, drivetrain is.
So drop center
the
plates
outs-
are for, we include them in the starter kit, and they, you can install them on the center wheels if you build that as a 6-wheel drive, and that drops the middle wheels.
Ooh.
And in a 6-wheel drive, that's really handy because it plays with the dynamics of that drivetrain in a really clever and fun way. So the important thing for steering, there are 2 things that go into steering a 6-wheel drive. There is the turning circle, is what I call it, which is like the distance that the wheels both have to travel to make a full rotation. And a smaller turning circle means you spin faster because you have to travel less distance. Your motor's the same gear ratio, so it turns quick. The other thing that is a factor here is like how far off from tangent are the wheels? Like how the amount of scrub that you have depends on how far from tangent to the circle the wheels are pointed. And the thing that makes both of those better is having a chassis that is shorter and wider. A wide chassis that's short means you have not a lot of you have less scrub and you can go around that circle quicker. But if your chassis is really short, I guess talking this way on a robot, and really wide, you're probably going to fall over front and back. So with a 6-wheel drive, you can drop the center wheels, and that means that you're only on either the back 4 wheels, the middle and the back 2, or the front 4 wheels, the middle and the front 2, at any time. And so you can act like you have a short and wide chassis while actually having a long chassis that isn't going to make your robot fall over. So it's super fun. And we put those in the the starter kit so that you have the option to do that. Oh, here they are. But what these plates do is you bolt them on the channel and they drop the bearing hole by 3 millimeters or 2 millimeters. So we can bolt these in and they can move that shaft down by, I think it's 2 mil.
That's cool.
So that will help us a little bit.
Do those use nuts?
Yes.
Okay.
So you'll have a 10 mil screws and lock nuts.
So where are
for
the
those.
nuts at?
I have them right there.
Okay.
I have another question.
Yeah.
I don't think I'm doing this right because
Okay.
I tried screwing this in right here.
Yep.
And it just won't go in. And
Okay.
I don't quite understand why.
Let's. It might be that it's just not quite lined up right. So I think a thing that I always like to do is get this screw loose first. There's lots of tolerances that happen here. So it's nice to think about parts as like a dimension. Like this is a 48 millimeter channel, but really like this channel could be 37.95 millimeters.
Yeah.
And all of that stuff can stack up. So when we're assembling things, it's nice to leave one screw loose.
Okay.
Because when you tighten one screw, it may have tightened
It'll
it all the way
shift,
in the one
yeah.
direction. But I think that was your only problem there. Okay, sweet. And now we can go ahead and add our 16 mil spacer and our long screw. At this, it looks like we may have based the position of this off of the other orientation. Let's just screw it in and see.
Okay.
It's tempting to guess on a lot of stuff like this, but it is almost as quick to just like find out.
Okay. I
used too long of a screw.
I have a good point here. How are we separating them, the two colors of balls?
We can figure that out later. That's okay.
I mean, I'd say just which one you drive onto first.
That's true.
Yeah, you could say, hey, you always have to go. You always have to do green and then purple. If you get two purples in a row, it might feed both of the launchers. If that's where we go, if we feed both the launchers the same color, that is probably a reasonable ask of the driver. It's probably reasonable enough to say, hey, you have to collect one and then the other. Okay, so then this.
There's a lot of room to flex.
There is, but we kind of want. So we can add the zip tie here. That's not a ton of compression.
There's a wrench over there, by the way.
Okay, I'm trying to think what's going to make this a little bit easier.
Well, there is a
Let's
wrench.
let's add a couple zip ties. Let's keep going down the path and just see.
Are you using the wrench?
No, you can use it. So we can go ahead and zip tie this. I like using zip ties with polycarb grid plates a lot. They're quick and they're easy and they're like they match the amount they kind of feel appropriate for the strength of the grid plate itself. So we just are threading that through those holes. Perfect. That feels right. That might be a little less than I'd want. I think ideally we have a little bit more pressure on that.
Yeah.
So maybe let's go down 8 mil. If we move down a hole, I don't know. This does feel pretty good. Let's keep on this. I think that I don't think we need a ton of compression to make this work. And then here, let's go. It's this slot or it's this hole. Let's say this hole. I don't know. That's gonna ramp up the tension. Let's try the slot. The slot might be too far, but that's okay.
We can always
Move
it
adjust
later,
it.
yeah.
Exactly. And then I could see a world where we actually cut this grid plate shorter and we move all of that structure back closer here, just because right now we have a lot of unconstrained length. And the thing that we're kind of fighting is we don't want we don't want the total length of grid plate to be too short.
Yeah.
So that it has to pull some of the grid plate back and then from the front side. It's weird, but we're on the right path. Okay. I did the other way this time where I put this spacer end on second and it works fine. It's kind of both work. Neither are perfect. When you're screwing a single standoff into a slot like this and you care about which end of the slot it's in, you can kind of help yourself out by thinking about which side you tighten first. If you tighten this side first, the screw tightening is going to pull this toward the outside of the slot, which is what we want. So we'll tighten this, and as we tighten it, it'll pull it this way. As we tighten this one, the screw is going to want to pull that standoff away. So we'll hold on to it as we tighten it, even though then it still is,
Yeah, like
that force is stronger than me.
Oh, yeah.
So this backs out on the pressure. It's like you lose some tension at the end. I think that's okay. I don't think that's too bad. We'll go ahead and add a couple more zip ties. Just make sure this is nice and constrained. And then I guess we can try it. I think I want 2 wheels. I think that's going to look better. This feels like it's not enough width to really catch the ball and make sure that it isn't contacting not directly on one of the holes.
Yeah.
I think we'll be better that way.
Okay, there we go. That's good now.
I mean, we're already 2 hours in. We have 3
wow.
hours left tonight. That's crazy. Okay. I mean, we can sure try this. I don't know that it's going to be perfect, but we can sure give it a shot.
At least it doesn't have to be perfect at first.
Exactly. We're just kind of going to see what happens. It'll be fun to start making movement. So I'm going to loosen this. We can flip this over maybe? That might be easier.
On the side.
Yeah, perfect. And if you want to loosen the other pinch bolt on this hyper hood, you can do it probably from the bottom. That might be easier. But you're already there.
Oh. I am twisting. No.
You were right. Yep.
I am right.
And then you got it. You're perfect.
This way.
It's to the left.
Wait.
It might be kind of.
This is confusing.
It is. That just had some torque to it.
Right.
You were right. And then that's already loose, so we should be able to just. Oh, and then there are 2 pinch bolts on the coupler. There's this one and this one that we can loosen. It'll probably be about the same amount of torque.
Come on. I don't want to break it.
You got it. Yeah, perfect. And then you can leave that, about that loose will be plenty. And then that one.
All right,
Perfect.
that one was a little bit loose already.
It kind of ends up that way sometimes. Oh, I think one of these pinch bolts is still tight.
Oh.
We may have loosened the same one. And then the other one?
There it was.
Oh,
Looks
there.
better.
That looks
Perfect.
a lot better.
Pinch bolts are feel different. Like the amount of tension you have is different than other wheels. So this one we have this pattern spacer on. We need another
It's
pattern
like,
spacer, and that can
Yeah.
create the right width for this.
Oh, I see.
Yeah, I can still grip it when it's
yeah.
over a hole.
I don't know what I did with that pattern spacer I just had.
Yeah, that looks nice.
Yeah. Okay.
Mm-hmm.
So.
Now we're gonna want one like here-ish.
I said it somewhere.
Yeah.
Oh,
Do
here
you
it
want
is.
to put a few more rollers on this first, or just
Yeah, definitely. Like I would say
Okay.
like 4 is
So these
fine.
pattern spacers are kind of
Yeah,
cool
we
because
don't
they
have
have
to
4 threads and 4
put them
through
all
holes.
on in the beginning?
We use the 4 through holes to screw it into the wheel, and now we can use the 4 threads to screw the other wheel on.
Yeah.
So I know in total we have to make up 8 millimeters, so we'll do it this way. And then we can set this wheel on top, and we can go through the through holes on the wheel and through the through holes on the pattern spacer into the threaded holes on the other pattern spacer. An easy mix-up that happens a lot for when you first start building robots is trying to go through 2 threaded holes. It most of the time won't work.
Are you okay?
So
Yeah.
the thing that determines, if you imagine 2 like helixes that make up the threads,
Yeah.
the thing that determines where those start is kind of just where the tap that they use first catches. And so they're not necessarily, it hasn't already been decided. We don't have a great way, we don't normally control
You're bleeding.
where the threads start and stop. So you always want to go through 1 through hole into 1 threaded hole.
Okay.
It's easy to try to go through 2 threaded holes, and you just kind of end up with parts that don't quite work.
Is it?
Those are kind of those can be kind of a close fit sometimes, for sure.
Yeah, they're. It's nice because you don't have to worry about them moving around really.
Right. Yeah.
But they're. Like. It's also hard to get them on.
Which direction does this go on? Because it has a little jet out right there.
It doesn't super matter.
Okay.
Whichever one you prefer.
Just goes on like that, right?
Perfect. Hey, look at the drivetrain. Yes. Couldn't those flat beams bending the polycarb plate be threaded rods? Absolutely they could, yes. I just happened to have flat beams up here and didn't happen to have the right length of threaded rod. I think this is all going to get rebuilt, so I don't care too much. So I think that's right. You can kind of see how far the shaft is slid in through the slot in the coupler, and it looks like it's right. So you can tighten just these two.
I wonder why it's not going through. Good.
Perfect, and then you can tighten that second one. And then I like to do the collar next because that will constrain. Yep.
Okay.
That'll constrain the shaft and make sure everything stays in place.
Is that tight?
That sounds right. Yep, you're good. And then you have the. We'll just kind of center this by eye, and then you can tighten those two.
Oop.
And then you should feel it kind of like click in. Yeah.
Hey
There we
Sam,
go.
I bet that's good.
do you like putting gecko
One
wheels on shafts?
I don't know.
There we go.
Perfect. Okay. Here, let's take a look over here.
This one seems to be kind of stuck.
That's reasonable. They can be kind of tough sometimes. That one is pretty tight. Wow.
But like, I think the last one I put on it was that tight too.
Oh, that makes sense. Sometimes
This
the
one's
direction.
this is one that we haven't tried putting on yet.
Okay. Yeah, let's give that a shot here. Sometimes there can be a little bit of rubber that gets in that bore too.
Oh yeah.
Let's you give me a sec with these. I'm gonna move some material out of the way. We'll make them fit quick.
That looks nice.
Are those just all rubber?
They have a plastic core in the center too.
Oh, I see. Wow, they're squishy.
They are. I should have put a harder component on here first. Okay. I'm gonna do this a slightly different way.
So, what has been your favorite season so far?
I really think this might be it. I'm excited. I don't know. I am kind of holding back on saying for sure if this is going to be my favorite, but it's really has a lot of potential. Aside from this, it's tough. I really liked last year. Into the Deep was one of my favorites. I like Rover Ruckus a lot. A lot of that is because my team did really well in Rover Ruckus. So that helps. It's easier to love it when like the team I was affiliated with did pretty well. And I liked the dynamics of that game. It was very it had a lot of robot interaction and it had a lot of interesting strategy. Jeez. In the same way I really like Skystone. I like Skystone. I was gonna say Power Play. I like Power Play because it has a lot of strategy. The strategy heavy games, and specifically I really tend to like games where two robots on an alliance target different things and have different average scoring potentials. Like last year you had a specimen robot and a sample robot, and those two robots kind of scored a different number of points. And so their time was worth different amounts, and so it was sometimes worth it to play defense. If you were a sample robot and you could defend a specimen robot, sometimes that was worth it. Sometimes that was the best option, and I always think that's cool.
Yeah, because I might be a little bit biased because it was our only season so far that we've competed in.
Yeah.
But, I really liked the whole strategy last season of having two different tasks. And that could be some interesting strategy this season, though. Just like how you coordinate with your alliance partner since you're both scoring in the same goal.
Yeah, even though this doesn't necessarily have different scoring potentials between two robots, I think there's a lot of strategy in this game. And that's my favorite. Like, when you have more to the decision that you're making in the game than just, I want to score more point, I think it's cool.
Yeah.
When sometimes you can say, hey, the best thing for me to do is score a different point or do something else that would otherwise be suboptimal, I think it's really interesting.
Yeah.
The ranking point.
Jeez.
The ranking point thing also I feel is going to affect that because some teams like the whole park thing.
Yeah.
That's going to be difficult.
Because it may not really be worth it as a point when you think about the points, but when you think about that you can get another ranking point for it.
Yeah. That is where it gets really cool.
Yeah.
So someone had a question. Would it be possible to download the assembly drawing?
For this? We will have one when we are probably in a couple weeks.
I can't speak. I think that's either that's Korean. I think I can't speak Korean, so I have no clue how to pronounce that. But that is a good question.
We could probably Google Translate.
I really like the really small gecko wheels. They're so cool. I really wish we could have used them some way last season.
Yeah.
But
Like this year, I think they make a lot of sense.
because they're compact, and compact is a big part of this game.
Yep.
And compression with the artifacts.
Yeah.
Since they're spheres, something that's not grippy, something that can't compress, just like it'll just slide right off.
Yeah. I think that's going to be super neat. All right, we'll just go ahead and say 4 is a pretty good test.
Yeah.
Where do you suggest to get the DECODE game piece? Someone said.
Andy Mark? That'll be the right place to buy it for sure.
If you only want the game piece, you could also probably just search like 5-inch wiffle balls on Amazon or something if you only want the game pieces.
Although it could be slightly different in like firmness and stuff.
Yeah.
Thanks.
Or weight, which will be a big thing. Weight, and that's one possibility for why you might want to buy the official Andy Mark one instead of 3D printing it, because your 3D printer filament could weigh different.
Yeah,
That's
for sure.
true.
Or be a different firmness.
Just go up and politely take one.
All right. Since the bearings are on the inside on these, and the 8-Max is about as close to the 14mm hole as you can get, we have to have a collar on the inside there to constrain it. So I just pulled the E-clip off, so that'll let us add a collar really easy. Perfect. And these have been a little bit tight in GoBuilda for kind of a while. They won't be in the next production run, which I'm excited about.
Okay.
So they'll be a little bit better in a little while. Depends on how well they sell.
I feel like they'll probably be used a lot this season.
I think they're going to get used a lot this season. So we can add this collar, which can stop it from sliding on one of the sides, and then we can add the second collar. Yeah. Perfect. It is fun to have a drivetrain without the motors in it. It just rolls around.
I love it.
It's kind of worse sometimes
Yeah.
Like, it's harder to work with the robot a little bit, but it's fun.
Mm-hmm.
Okay. That one's pretty close to centered. And I'm just using this as like a thing I can like push on that'll touch the plastic core of the wheel instead of just trying to pull on the rubber.
Yeah.
Mhm.
It just is so much harder to push on the rubber.
It just deforms it.
Yeah. There we go.
I think
Okay.
it needs to move a little bit this way.
That's
No, it doesn't. I don't know. We probably might have more rollers on it at some point anyway, and
that looks pretty good.
Yeah.
It probably, in an ideal world, I think it could be a couple more mil of compression, but I think that's pretty good.
and
Yeah.
with like the sinking into the tiles, all's on top
And
of this.
driving into it.
Field setup this season is not going to be fun. It's actually not. Okay, field setup took a minute. Getting everything assembled on the field was a lot. It breaks down really well. So the back corner sections split from the ramp, and so you can just take, I think it's 4 bolts, they take those apart, and then you can transport the full corner section and the ramp separately. I think once you have it set up, it stays together really well.
Yeah.
Okay, I think this is pretty close. This can feed up through,
Maybe we should put.
and then it kind
You
of
think the,
loses compression a little bit, which I think is
Yeah.
exactly what we want.
Do you think the
Alright.
I think we might
angle of
scooch
that
this
depends
back
on
a couple holes. That
this,
should
or
give
does
us a little
this
bit more
depend on the
vertical
angle of
shot.
that?
Like,
Well, I
Okay.
think that
And then
what
that'll
we
work.
need is to just get it to a point
so
where
we'll just loosen this one.
where these will both be catching it and pulling it up through. So we're going to have this somewhere where the wheels are far enough away from it.
We need at least one on here.
Yeah.
How many holes?
Let's go to the center of this slot. So right here. So there's a slot on the side pan part. We can go to that hole.
Right here?
Yes.
Okay.
And it'll be easier to use the red handle driver because
Yeah.
the T handle part hits the channel wall. You can also use an L key here. Here you go.
Okay.
And that can go up.
Oh.
And this is a ball end, so it can kind of.
So I guess.
There we go.
Yeah, there you go. The ball end lets it means you can
Go in
screw
at
in
an
the screw at an
angle, right?
angle, but it
Yeah.
also means it's kind of wobbly.
Okay.
And then if you also just tighten
yeah.
I
this
think this
one.
needs to be lower.
Yes, we will have CAD. I don't think we'll have an assembly guide for this robot on the website. That'll be available as soon as Robot in 3 days is over, and we also, as soon as we are done CADing the robot. So once we finish, we'll put it in CAD and we can publish that step file.
Can you hold this and I'll hold that. And hold.
Oh,
I'll run
my
it
laptop's gonna die.
Oh.
I'm gonna plug that in.
in. Okay, this is kind of.
Okay, so this is a bad placement.
Yeah, but if we
It's
put it,
stuck.
if we put it
How is this gonna mount
all
on
the way
there?
back here,
That we can figure
here
out. later, I
it
think.
doesn't
Okay.
catch.
So the next thing I think it would be good to do, we can probably
You think
just
what I'm
feed this
thinking?
in,
Why?
Yeah.
but it would be nicer to have another piece of polycarb
Some of those.
that can kind of feed in the balls.
And use it to shift it forward.
Yeah.
How are we going to mount
could-
that on there?
Try that.
We might put.
Let's stick it in here again and look how
know.
much it needs to go.
We could either put the whole.
Since
We
it's
could
like
put this on the
5
robot,
inches.
but that kind of decreases the
I
number
feel
of
like
people
it's
we can
more
have
than
working on the
it's
robot.
more
at once.
than 2 millimeters or whatever it was.
3.
3 millimeters, but I feel like it's more than that.
Let's.
About you putting
Let's
it there
see
and
how
shifting it
close
back
these
one.
guys are.
We
All
could
right,
try.
you guys are working on an intake, right?
Yeah,
So-
right now the problem is this
Oh,
is a little
yeah.
bit tight, but
Yep.
if we move it back a whole hole,
Yep.
it doesn't catch at all.
So I'm thinking this, and then use one of these and move it back a little bit.
Sure. Can you put it back in that hole one further back?
Well,
And then, so this just doesn't contact both wheels. That might be about right. That looks about right to me, I think.
Yeah,
Once
it's
you get
just-
that in bearings.
but yeah, we just have to but when you turn it and don't push it in, it doesn't seem to want to lift it up. Now, I don't know if that might just be fixed by these rollers spinning really fast.
I could see that. Or if this roller can also rotate.
Yeah.
Let's put it here. It just means we have to move this channel back one. The other thing I want to try to do is mount the shooter to the chassis.
Yeah.
So let's scooch this back one hole so that we can put that counter.
I think that the placement of this depends on the placement of that.
Yes. And I think that this is not going to be very close to the final launcher we make. I bet we don't make the final launcher today.
Yeah.
I bet we just let's try to prototype it and see if we can get a launcher that'll work.
I bet that.
And then we can use the learnings to inform our direction tomorrow.
I think that the intake probably isn't going to look exactly like this in the end either.
No, I don't think it will.
What are those wheels called?
Gecko wheels is what we
Gecko
call
wheels.
them. A lot of our wheels have animal names, especially when we came out with those. They were kind of all animal named. We had rhino wheels. We have a couple of other ones that are escaping me. And geckos are kind of sticky as an animal. And I said, hey, that's a fun compliant wheel name. Okay, yeah, I think I think we should mount this to the robot next.
Okay.
And then we could add this piece of polycarbonate to add the front ramp. And we'd be able to feed the balls up in just as a test and see what happens. I'm trying to decide if we want to run that motor with just manual power.
Now
it probably will be
which hole
pretty
is
good
it in?
that way.
Let's check this first.
Yeah. I think that's too far. Move it one hole forward. This was the right one, wasn't it?
That looks right to me, yeah.
So, then this one, I guess. That one was the one, or wait, no, that's probably good. That hole.
Okay, I got it.
Oh, wait a second. Well, is it? Oh, I think we did need. I think this is where it was before. We have to move it one back.
Okay.
Imagine you put it
And
in
food
the
is here.
exact
If
same
you want to go
spot.
eat, I think that'll be great. And then when you're done, you can come back and we can get some more stuff mounted.
All right. Thank you.
Thank you. Yeah, you can just kind of leave your mic on this table up here and mute it, and you'll be good.
Yes, let's.
Sweet. And if it's already muted, if you mute it, perfect. You got it. You're pro. Can you use last year's kit to build this robot? So some of it depends a little bit on when last season you bought your starter kit. There will be very few parts that are different. Some of the parts that are for sure that you'll need are the polycarbonate grid plates. You'll also need some way to get a 6,000 RPM motor. So either by purchasing a full 6,000 RPM motor or by getting their lockout plate. I think those are going to be back in stock on Monday. That will let you convert one of your motors to a 6,000 RPM. The other things that might be different in your kit are the hogback wheels. You might have Rhino wheels. I think the Rhino wheels will still actually work, but the hogback wheels will get you exactly there. And the Omni wheels, if you might have older Omni wheels, that doesn't matter as much. You could use those in place of the new ones. Depending on how early in the season you bought those. Some of those changes, like moving to new Omni wheels and hogback wheels, happened last year. It happened in last year's kits, but not every one of last year's kits has those upgrades. So if you would like, shoot us an email just to tech@gobuilda.com and we can get you a list of the parts that are different. Especially if you tell us when you bought your starter kit, we could get you exactly, hey, here are the things that you need to build this robot. But very few things are new. Yeah, so we're just moving this crossbar.
Yeah.
We'll add that other roller, and then we're going to put the launcher on this robot just as a base to see what happens. We can spin it up and start playing with it. I think that's going to be pretty good. I think we're pretty close to having a launcher that would work. It's obviously a single flywheel. The other thing I think we're going to need at some point, before we can get really good reliability or accuracy testing out of this, is probably a way to actually feed it. So we'll have to have like some servos or a motor with some additional wheels. But like the challenge of this is going to be fitting all of this stuff. Like it's pretty easy to look at this intake and be like, hey, this intake could take up about all of the space we have. That'll be really interesting. Do you guys want to go ahead and get that mounted and I can go eat at that same time? It looks like you've got 10 minutes of work probably.
Yeah.
Okay, and then I can come back and we can get this mounted up to the robot. Yeah, if you want to get that second intake roller.
Yeah.
I don't know. I can't decide if that's going to be super important in the intaking process. I also could see us saying like, hey, that we're not going to power that counter rotating roller yet. We could focus on the launcher. Do you guys have a preference there? I think we could probably start by saying, is that intake going to work?
Yeah.
For what we need. Okay, let's do that. Let's say this is going to be the first step. We'll try that out and see. We can apply motor power to that, and then we can see how the shooter works.
Okay.
So if you guys want to go eat quick, I can get this mounted to the robot.
Yeah.
Okay, I like it. That sounds good.
Okay.
Sweet. If you'll just mute your mics, and then you can either leave them on or you can take them off on that table. But mute it before you take it off if you want to do that. Cool. We have our launcher. Whichever. We have our launcher. We have a chassis with an intake. We'll just gotta put them together. Man, it's so quick. Like this, you fill up the space so fast. I could see a world where we might actually have to have the intake 90 degrees from the launcher. That might buy us the space. But like, this is over 18. Like, it's crazy. It's not much over 18 inches tall. That was too loud, sorry. But it is over 18 inches tall right now. So I'm sure that's solvable. But it is kind of crazy to think, like, you don't add a whole lot to the robot and you get to the maximum height. Good. Okay. Okay, we'll have some 8mm screws. We'll bolt this all together. And then this is a 10-hole channel that we're bolting to, which means that we will have we won't be able to put it directly in the center. That's okay. So I think we're going to be offset by 8. No matter which way we go, we can go slots. Yeah, slots there. This is a cool practice in building robots, is trying to parallelize it as much as possible. It can be kind of a challenge sometimes, but it can really speed up stuff. We try to do it a lot in Robot in 3 days. It's going to be harder this year. A lot of times in Robot in 3 days we have an end game that is like a specific and separate mechanism that we can split off on. This year it's going to be a lot of like, we are all working together as 4 team members, which is fun. It's definitely a cool way to put together a robot. Okay. And then the last screw before we tighten these all up. Especially in a mechanism like this where the points of contact between the mechanism and the chassis are pretty big. Like there's a lot of space between them. There's some flex there. I definitely like to get all 4 of the screws started before I tighten any of them. That keeps the flexibility to make sure everything lines up. So that's all mounted now. And we have something that's like actually starting to look like a robot, which is pretty impressive for halfway through day 1. Now I'm going to zip tie this polycarb grid plate in place. Maybe here. Is that centered? Yeah. I didn't bring the zip ties over here. That's classic. Swap the center channel with low side channel. That'll give you some height. I think that's fair. I'm really interested to see if this is generally the robot architecture we end up with, where you have an intake that would probably feed into 2 distinct funnels. It'll be interesting. I could see a world where we end up with 2 intakes in the front, where one leads to the right side, one leads to the left side, and then we would just have 2 feeders, one that could push one color and the other color. All of that means we could, I think, make this a lot more efficient packaging-wise. But I like the idea that our intake could go pretty much right directly into the shooter. Like it could go right up in there, and then we just need something that'll carry it up the length to fire. For now, that can probably just be feeding it in by hand. At least to see if we're kind of close on the geometry. While this is not zip tied to the robot, I'm going to cut the bottom so that it can be fairly horizontal. Okay. Oops. I guess while it's only halfway zip tied to the robot, this is one of my favorite new parts we've had in a while. It makes working with custom plates on a robot really quick and easy. It's a really fun material. It's super strong and durable, and I think we're just going to see a lot of robots use this. It solves so many problems. So many times we have wished for a part like this. It's just fun to have that solution handy. And zip ties are just such a nice and easy way to interact with it. Okay. So that is zip tied in place. We have a ball that we can eventually kick up with a counter-rotating roller. It can feed into the shooter with some kind of feeding mechanism, and then the launcher can take it and go up and over. I like that. Like, that's slick. I think that's a great process. And I think it's going to be very possible to fit another width-wise in here. I actually think the 2 balls work. Yeah, 2 balls fit in the width of that chassis. Even if we had to say, I mean, a more out there option would be we could have 1 intake and then like a train switch, like a track switch that could funnel it either to one side or the other side. I think that's cool. The big thing is that you can't intake 2 purple ones in a row. So like there is, at some level, this is maybe less flexible than an option that could shoot 3 independently, or like a Spindexter or something like that. But I think this will fit. This is way more solid than I was expecting for 1 low side channel in the very center that holds it up. It's really pretty solid. I'm gonna go ahead and see if I can get the next sets of geckos installed. And then we can get an idea of that counter rotating. That'll be cool. And then I just need that piece of channel I was using. All right. Sweet. Okay. And our second one. I have to take the E-clip off of this too, but that's not a big deal. Especially the longer shafts, it can be kind of harder sometimes to actually get great use of the E-clip. It just takes a lot, it takes more planning, which can sometimes be a little tough. Okay. and 4. Sweet. I think that's pretty centered. That's centered enough. Okay, and then this was here? No. Here. Yeah, I think that's going to be slick. Just need a couple ball bearings. And it'll be interesting, now that we have this drop center plate that pushes this intake shaft off pattern, which will maybe throw a little bit of a wrench in our plan to use miter gears. Miter gears are definitely picky about where they are mounted on the pattern. So I could see a world where we need to adjust some plans there, but like I definitely think we could fit some chain and sprockets or a belt in that space and have it work perfect. Okay, so on this I have a 2106 shaft. It has an E-clip on this side, which is a great way to constrain one of the bearings. I'm going to add a collar and a bearing on the other side. So on this first side, I'm going to put the bearing with the flange toward the center. So both of the flanges will be on the gecko wheel sides of this, and then our collar will back up the other side. But we'll go ahead and load our collar and flange bearing with the flange toward the gecko wheels. You can put that and then put the flange bearing with the E-clip in the hole, and then we can slide the collar out, and then we can get all of that constrained. So these are all just free spinning right now, but that's okay. That should still give us a pretty good idea. I could see ideally we would just link both of these so they would counter rotate. Oh. Okay. I think that this first roller might still be too low. Yeah. I think it might still be too high. It could sometimes work, but it doesn't really want to grab. We need to be making contact with like this top roller needs to have enough friction with the ground that it can really push the ball into the second roller, which can counter rotate and scoop it up. But that's okay. That's solvable. We'll just need a good way to drop the top shaft down a little bit more. Because yeah, right now the ball can get behind the center of the wheel, which means it just doesn't have any compression before the counter-rotating roller can actually pick it up. Once they have it, that's the right spacing though. That's going to feel great. And then it can go roll into here. We can get it up into contact with this wheel and hopefully launch it. I think that's gonna work well. I don't know exactly what we're going to do to feed that in. I could see maybe another roller of geckos, honestly, here potentially. I could definitely see that being a good solution. So I really think the next thing we need to do is test this. Unless we have a good way to drop the first intake roller further. That 2 mil just wasn't quite enough. I was looking at this a second ago. I think you may have been onto this earlier, and I just didn't quite get it. Mm-hmm. So this can grab it and it pulls it in fine. Mm-hmm. But once it's in, it's past the apex of that first wheel. Yeah. And there's nothing that pushes it into the counter-rotating wheels. So we're kind of just we have it trapped here, but we can't pick it up at all. Okay. Once we have it, the two counter-rotating wheels just work great. That compression's pretty good. If anything, these are maybe too close together. Mm-hmm. But we need a little bit more compression between this roller and the ground. This just needs to go down, honestly, probably 3 or 4 more mil. We want a pretty good amount of compression.
So there. One hole.
So one hole. We're there. We're 2 holes down. Sorry, we're 2 mil down. So if we go down 1 hole, we're down 24 mil. Okay. Which I think is too close. I think that's dropping it too far. Yeah. But we could. I think what we should do is we should go down a hole and then we should space both of these up off of the channel.
What if we?
I think that's probably it.
Would it be more compression if we moved it up and used the bigger gecko wheels?
Yeah, that's another way we can do it. I think we're kind of in the same boat because the Gecko wheel sizes also increased by 24 mil. So we haven't really created any more granularity. Like if we go up by 24 and we increase the size, the distance to the ground is the same.
Yeah. What if we sort of add a little bit of a ramp so this follows the curve of the ramp and pushes it up?
That could work too. That could work too. Like, I think that we definitely don't need this to be a counter-rotating roller. This probably could just be a piece of channel.
So
that's a great point. I don't know.
Someone had a good idea.
Yeah.
They said, swap the center channel with a low-sided channel.
Yeah, because right now we're too tall. This robot doesn't fit in the box.
Yeah.
And that would work pretty well. I think we can probably get some information out of this robot first. I think we can get some information out of this robot before we go and change it a bunch. So I honestly think the next best is probably moving over to the field and doing some test shots of the launcher. I'm excited to see how that works. Right now I don't have a good way to feed it, which is kind of annoying. Feeding it would be a really great next step, like a thing that would make it a lot more consistent. If I just sit here and push the ball into contact, it's going to work, but I don't know if it's going to be the same every time. I think that's a good enough shot. I'm not very, like, if you hold the bottom of it and push it up into contact with the wheel, I don't think you're really in any danger. So I'm okay with that. I think that's a good solution. Let's try that. Let's see what information we can get and go from there. I think
So how are we going to power this?
Are we just going
to hook it up to a battery?
We can hook up to a battery with a controller because we're going to need a lot less velocity.
Oh yeah, like one of those
we have a
motor controller things?
manual motor controllers. I think that would work pretty well. I don't know that I have one handy. Will you find us a manual ESC? Thank you. Oh, I just forgot that I have part Santa.
SKH said, how compressible are those balls? The balls are, it's in itself,
pretty compressible.
Like, this is not much force at all.
Yeah, like they're not like rubber, but it's just how they're like
They're soft for a wiffle ball.
they're
They're
like,
softer than a wiffle ball that you would think of, I think.
it's kind of like compressing the side of a milk jug.
Yeah.
That's actually a perfect example.
Yeah.
Like
I peaked the audio. We were too loud with our yes.
like you can kind of like, it doesn't just compress by you holding it, but if you give a little bit of pressure, it just goes in.
So I like this idea that we're talking about. Like, we don't need a counter-rotating roller. So we're talking about this. We have another roller in here, and that's a really classic way to do an intake. The logo is hiding it. There's another roller right in here, and that's a very classic way to do an intake. It works really well to pick up an element into your robot. We have a ball, and the ball is a pretty forgiving way to do it because a forgiving elements to intake. We can have a bar here, and as long as that bar is below the center of the ball should just roll right up. So I think we could get by with not having that roller, which reduces the complexity of this robot a lot, because then we don't have to power this roller. And to power this roller, we either need a chain or a belt with a direction flip, or we would need a second motor, which is going to be kind of hard to package in this robot with where the drive motors have to go. So I say let's try it with no counter-rotating roller and just like a plate. Either like, honestly, a piece of low side. I bet a piece of 10-hole low side would work pretty well there. Yeah. Let's try that quick.
Or,
yeah. Eventually it's going to be more good plate, I think. Oh.
something like this.
That's kind of interesting. Okay.
And we mount it.
Yeah. Yeah, I mean, that's going to be really forgiving. That angle, that L bracket would definitely do
Or-
that.
just shift
or
that
even
forward.
just
Yeah.
another piece of this.
Yeah, I mean, that's going to work great. I think we need to start interacting with that here. So,
Like-
yeah, I mean, we could definitely do that.
Yeah.
It
Or
would be,
just another piece of it. Like we have a piece of low side, and we just have another piece of it extended out, and it just
Exactly.
connects to the end of the low side.
I think that's going to work well. I think we'd be able to get like
here.
I don't know that we actually really will need an angle. I think we could probably put this as far down in the robot as it'll go. It's, of course, everything is... This is another piece that is the same length as this, which means that we should have kind of a press fit here. So
Yeah.
we might end up.
And another thing we have
So
to
this could
consider
be here.
is if we're going to be putting this on low side to drop that to make it fit, this will affect how we make this. So.
Absolutely, yeah. I think this whole launcher is going to get redesigned. Like, pretty
Definitely.
soon after we land on having an idea of how it's going to work. I think this is going to work, though. I think this would give us a chance to test and see if this intake is going to work. So if you guys will try to find where the right place for this low side would be, if that's going to work. I still don't know. We still might need more compression to actually give this enough grip to pick it up. The tile's going to perform differently, but I could see where we would still need more compression with the floor. So let's get back to this. This needs more grip, but this needs more compression with no matter what we do. So we need a good way to drop this by like 6 mil from where it is right now. Right now, if we go down one hole, we go down 22 mil. So the whole thing needs to go back up like 18. I mean, we could go a 16 mil pattern spacer underneath the quad block. That's gonna work. So the 16 mil pattern spacer goes under this quad block, and then this goes down a hole. This could be a 2-hole channel.
Yeah.
The other thing we could do, no. The other thing we could do is, I'm thinking about a piece of mini low channel. Because what we need is more granularity. Like, only being able to adjust this by 24 is kind of hard. This would fit by this bearing. We could put 2 pieces of this here, like that. And then we could be able to adjust this by 8 mil.
Yeah.
It will be hard to power it with a motor, but we can solve that problem after we have a prototype that works.
Yeah.
Okay. Do you guys want to try that? Try to transfer this shaft over to 2 pieces of mini low?
Yeah.
That would be mounted to the front here.
Sure.
And then if you get more time, put a crossbar in to a platform for that wheel to roll into. Sweet. Okay, I'm gonna go eat quick.
Okay.
And I'll meet you guys back at it.
Great. You want to get started on that? I'm gonna do some shout outs.
Okay.
So, I saw in chat earlier, Midas Lead Builder. Shout out to Midas Automatons, as well as friends staying back in Oklahoma. Like, for instance, I think some of the BC Robocats 7242 watching, hopefully. Definitely, I definitely know that some of my personal family
Do you want me
members
to do this
are
side too?
watching,
Okay.
as well as some of our mentors. Shout out to who was it? Yeah. My mind's absolutely blanking right now.
Move this back.
I think it's a
Almost.
Oh yeah, shout out to Legend. They're a California team that we partnered with for finals at Run for the Robots, as well as last year's Robot in 3 Days team, Project Peacock. We
What do we want to do?
I think we're gonna have to put this back a little bit more because if
They
we put it
were our
here, then it
partners.
will-
For I just said the word finals, yeah, finals at Michiana premiere event. Shout out to Project Peacock. Shout out to 7172. That's technical difficulties.
I think it'll-
They actually
we can
won
pick apart
the
these
Cowtown Invitational with us
sides.
as our partners for finals.
Do we want to take apart this?
Yeah.
Okay.
Thanks, everyone.
It has a. No.
Last season was super fun playing with all of y'all. Loved it.
What?
Hola, senor.
Hi.
Yeah. So, right now, we're taking this apart just because I don't want to go to the trouble of getting more bearings.
Honestly, we would have to take that apart anyway.
Yeah.
There we go.
The best part about it is best part about this taking this apart is that whenever you take something apart, you're not just taking it apart for one thing. You get all
parts
the
back.
other parts that you put into that back from it. So that's helpful. Yeah. Shout out to all the American military veterans.
Oh, real?
That's great, yeah.
What about this?
Yeah. Might take that out too.
Okay.
So what we're doing now is since instead of using another roller on the bottom, we can just use this as like a with the top roller like here, just bumping it up like that to get it into the
flywheel thing.
yeah,
Yeah.
bumping it up here so rolls it in and just goes in there like that.
It'll make more sense when it's done.
It actually will. That's a good point.
What if it picks it up and the whole robot tips backwards
How
like
many-
this and launches it out like that?
How many years have you done FTC? This is our second season. Into the Deep was our rookie year. Yeah.
And yeah, Gage and I have been on the team since the beginning, but this is Ike's first season.
I just got here.
What grade are you guys all in?
What grade
I'm
are
a
you?
freshman.
I'm a sophomore.
I don't know. I guess I'm like in 10th grade or something.
Me and him are homeschooled, so it's like subjective.
Whichever one sounds cooler, I guess.
Whichever one sounds cooler. I feel like whichever one sounds cooler is a very homeschooler thing to say.
Yeah.
It's definitely like I forgot that this is a normal thing to always know about myself. What specific like high school grade I'm in. What do you guys think you're going to do after high school? Do you have any ideas of it yet?
I want to go to college at MIT.
Okay.
Get like
Yeah.
a mechanical engineering degree. Maybe. That's like probably what I'm gonna do. Might change though.
I want to go to film school at OCCC. Love that place.
Oh, that's cool.
It's a good college. They do a lot there.
Yeah. I think I'll probably try and get into either mechanical or electrical engineering, something along those lines. And but I have a backup plan of becoming an electrician.
Sam is really good at CAD. You could also do something with CAD.
Yeah, that's a possibility too.
So,
Which one did you? Okay. So this one.
that also makes the intake a little thinner though too. So we have to be more precise with the
does.
driving.
Yeah.
That might be interesting.
Probably going to end up moving this around, so I might just attach it with like 2 screws.
I mean, 2 screws is the minimum. It holds it in
Okay.
place and the correct rotation.
Yeah.
And it's great for prototyping. But
Just add more screws before you take it to competition.
screws
yeah,
did you use?
yeah.
These?
I guess the
Okay.
tins.
Gotcha.
Eventually, you'll get to the point where you can tell what length they are just by looking at them.
Yeah. Where'd you put it? Oh. It's on this hole, right?
Yeah, and I guess it's going to be back a little bit because if we put it where the other one was, it'll crash into.
Wow.
Where
Joseph's been coaching for a long time. Relic recovery, that's 2017, 2018. Pretty
Yeah.
long time.
How long ago was that? 2018?
Uh,
It was like 25, 24, 23, 22, 21, 20, 19, 18, 5, 7 years ago.
that's
That was 7 years ago.
a long time. Props to you for sticking with it that long. Pretty impressive.
Where's the thingy things? There it is.
Well,
You
not
might-
pretty
you
impressive.
might
That's
wanna
actually
put
really
them
impressive.
alternate corners.
Oh, it's a good idea. It's a better idea than what I had going.
All right, sweet.
Got that almost put on.
Sweet.
Almost. Oh, I'll do that one.
I think this. Oh yeah, I think that does clear. Just barely. That's perfect.
And I feel like this is going to get moved up and down.
I could definitely see that.
In fact, right now, is it any different than it was before?
It is too short right now, I think.
Like the top one
the
is?
top one is the same place as it was.
Okay, so that means
So
that
yeah, you should go down 8 mil, or you could go up 16.
down
Yeah.
8 would probably be easier.
Down 8's easy. Down 8 is at least easy for my brain to feel like we're doing the right thing. We're moving the needle in the right direction. I think that's gonna feel really solid.
All right. So which way?
Joseph said he's been coaching since Relic Recovery. That's awesome. That was a great one. I liked Relic Recovery. That was my senior year, so it was also just generally fun. I had a good time. That was the first year I competed at Worlds. That was fun.
What team were you on?
72-36 Recharged Green. We're a team from Pella, Iowa. We were a team from Pella, Iowa.
Oh, that's cool.
It was fun. It was a great time. Our producer Shane said, "I really like the one with the cones
Power
and
play?
the long yellow." Yep, that would be Power Play. I liked Power Play a lot. It was a fun one to watch. So like in my brain, there's this ranking of FTC games, and it's based on too many different things. But one of them is like how many different robots are good and competitive. That's one of the reasons I really like Into the Deep. Is like there were a lot of robots that looked basically nothing alike that were all pretty competitive. I think that Power Play would be up there for one of my favorite games if it had a little bit more variety in the robots. But like there was just so clearly one option that made a good robot, and that was just I don't know. That doesn't scratch all the itches for me. I think that I think that it'll be interesting to see how much variety there is in this game. I feel like for a launcher game, this is going to be a pretty wide variety in robots.
Oh yeah.
We're talking about like 3 different designs, which is cool. I think it's also interesting. We talked a lot about flywheel-based launchers previously. Like old FTC launchers also had a lot of we call them flickers. You have a classic example is a putty knife and a stop, and you put the putty knife on a slow rotating motor, and you just rotate around. It deflects the putty knife, and then the putty knife flips up, and that hits the ball. It's a super simple mechanism for launching. and it's just like it's very consistent, especially when you're in the putty knife. When you're talking about spring steel, when you're looking at like other flexible materials like that, it can be less consistent.
Yeah.
Okay, sweet. I like this. I think this is going to be good to see if we're closer to the right height. So I think we can set that kind of back up. And then, yeah, if you want to reinstall that intake ruler, we can see how close that looks. Or if you're 724, you can build a popper out of a Greek yogurt cup. Yeah, I love it. You bring your popper out of a Greek yogurt cup, and also are also like unquestionably the best team in the world. Like, what an iconic run.
It's crazy.
They were cool. Like it's Redneck is the Redneck Robotics one from Montana for sure. I don't know where. They were great. I kind of miss, like, in this era of FTC, it's really fun because I have no idea who's going to win on Worlds this year. Like, it is so tough to know for sure. Oh, did we do the math run?
That's a little compression.
That's a lot lower. Okay. Cool.
I feel like we might need to move it up like 16 from here.
Yeah, at least. I think so. Because we're at least, I bet we need to go up. Also, we had a 3-hole. Oh, yeah.
Okay, so
we just went down 8 from 24. We need to go up 24. Okay, that's fine. That's doable. That'll be pretty quick.
Someone said, I wonder how the artifact will reach the level to be put in place. I feel like it'll go down, not up. That's interesting.
Reach the level to be put in place. I'm not sure that I'm following. Oh, here we go. I'll grab another one.
If I'm interpreting it right, I think it's the gecko wheels pushing it down. If I'm interpreting that right.
Maybe it's from the launcher. We definitely might have the hood at the wrong angle.
Yeah,
I can do this side if you want to do that side.
It actually might go down.
It might. We might have that hood wrong. It's very possible. Do you have another 3mm hex key I could borrow?
This one, right?
Yes.
Okay.
Thanks.
What's everyone's favorite part of first?
I have a boring answer. If you guys have a fun answer, you should say yours, and then I'll say my boring answer.
My answer is I love how it like really opens people up, and I love the community aspect of it.
That's super fun.
yeah.
I don't know. I don't really have an answer.
That makes
Yeah,
sense. This is your first experience with it.
Yeah.
I always like, we've had a full like rookie on this show a couple of times, and I think this is a fun, very first experience with first. It's so wild. I think this is right. I say we try it quick and see.
Sam, what's your favorite part of first?
Like, yeah, just the whole, like, getting to meet teams from other places, and then, like, also just, like, the whole thing with the alliances.
Yeah.
Like, you could be, it helps you to help other teams.
Yeah, the cooperation aspect is so special, and it feels so unique to first. It's very cool.
Yeah.
I love the idea that, like, if I am excited to compete against the best version of my opponent, and, like, if that means I'm going to give them a charged battery when they don't have one, I'm pumped too. Like, I want to beat them at their best by being my best. I think that's really special.
Yeah.
Yeah.
I love that it is such an effective way to teach people. I think the fun part and the reason, and like a lot of the reason that I can do something like this, where like I can just jump in and host a live show like this, is first. It makes being a good communicator a competition, and I think that's so cool. Like there are absolutely other programs that do that, but like it is so cool that you have this mix of like being a good engineer is a competition, and if you do it better, you can win. And also, if you're a good communicator, you can do better and you can win and you can have this success. I think that's just such a special part of the program, and it teaches you so much.
Yeah, I think it's just like how it teaches you not only the engineering aspects, but just life skills, you know, getting along with other people and being able to communicate your ideas.
Okay, we're guessing checking, and that's okay. We're 16 down. I think we need to be 8 mil higher.
Okay.
One more time. We could have measured, I'm sure, and that would have made it easier.
Robert, what do you mean falling out of chairs?
What?
So there's one account on here that I know exactly who it is.
Let's try this one more time. So we just need to go up 8 mil real. 8 more mil.
That's a very vague comment.
What, okay, what's the question?
It's literally just the statement falling out of chairs.
Oh, that's his favorite part of at first.
Okay.
Yep.
Yeah. I don't know that I really added a whole lot of clarity there. That still doesn't make a lot of sense to me.
Yeah,
but
it's like,
hey,
it's kind of an inside joke around our team.
Yeah.
Okay.
One of our mentors really likes falling out of chairs.
One of them. I wonder which one.
Does this come about because this mentor sits in chairs weird? Like, is this like an artifact of their own creation, or like?
It's hard to tell.
Okay, that's valid. You know, because like I can always kind of get on board if somebody's like suffers the consequences of their own actions. So like, if you're falling out of chairs because you're sitting in chairs funny, okay, but
Yeah.
I don't know. If you're just falling out of chairs randomly, like, maybe that's not your fault exactly.
Yeah.
Okay, so that goes up by 8? I think that's right. Oops. Thank you.
Yep.
Okay, is this the correct height? It is finally the correct height. Thanks.
Oh shoot! Oh my gosh. Okay.
Hey, I
wow.
fell on my side this time, so it's fine.
That thing does not want to be held.
So this is this is gonna be a weird one. It's I think we actually need a longer piece of channel, unfortunately.
How long?
5 holes.
5 hole.
How long is that for?
Yeah.
Oh, yep.
How many? 2?
2. Because you can't get, this is the only, like, this is one of the downsides of mini low and how it works with full size channel is sometimes you can't quite get the patterns.
Does
to line
mini
up.
low like actually line up with regular hole
Yes,
pattern?
but in sometimes kind of funky and unique ways.
Mm-hmm.
Oh wait, can I just go over by 8? Oh, I could have just gone over by 8. It's fine. What's the better option? Let's keep it with the 4 holes, and then let's just center it on the 14 mil hole.
Here? Is that-
Yes. Yes. Correct. I lost one of the lock nuts. Can I steal another one? Sweet, thanks.
Does it fall on the floor?
I don't know.
see
I
it.
truly just feel like, oh.
Oh.
It was in the wrench.
Okay.
I was like, oh, this will be the perfect place to leave it. It won't go anywhere.
The wrench was hungry. He wanted it.
I was trying to, I was being too clever.
Thank you, Brianna. I'm glad the live stream is useful for you guys.
Yeah.
Thank you.
That's awesome. I think I'm always impressed that teams will just like sit and watch. I love it. It's so fun. Especially, I like it when teams ask questions and engage in the chat. It's also fun. It makes the whole thing more fun for me.
Yeah.
Yeah, and like I said, the community aspect of it.
Exactly. It's a great time.
It's also really useful for like just learning about first, even if
Exactly.
you're not going to compete.
Yeah, it'd be fun. I've had people who just watch it and they're like, oh, this is a fun way to learn about GoBuilder parts and to learn more about your company. I'm like, that's fun. I can't say that I would do that, but that's awesome.
FGC 5237.
5237. I don't
What
know.
team is that?
Oh yeah, that's it. That's perfect.
Yeah.
We're there. It only took like a lot of building and rebuilding to get there. Okay, now that's the right. Like that's enough. That's compression. That's gonna go and push that up.
Yeah.
So then we just need to mount that other piece of channel. Can I
5,
have that piece of low
3.
side?
Is it this one or
The next one. And then we just need to figure out where this one should be.
Guess we'll need some dual blocks.
Exactly. More dual blocks.
2.
I think if it's here, it's probably going to work pretty well. I think
Okay,
that'll
loose
kick it out.
screws.
Loose screws. From where?
Michigan.
Michigan.
Cool.
Awesome.
Shout out
that's
to
the
them.
one on the other block. What's 2 more, you know? I'm going to pass this down if somebody would like to install those.
Me too.
Yeah, sure.
I think that's looking pretty good. I don't like this is not going to work front to back. Like this won't be able to cycle, but
Like
it's
this?
definitely independently correct. This one's correct, yes. And then yep, that's it.
Okay.
Seemed like a robot.
Yeah.
From this way or this way?
I
The
like
sides?
from the face. It doesn't really matter.
Okay.
Kind of crazy.
What's the
The
axle height?
6,000 RPM motor. How it just
Of
like
that
turns freely.
shaft,
Yeah.
I will check.
Once we put a 3D printed fan blade on one of these, and it moves quite a bit of air.
I bet it would. Even these wheels will move quite a bit of air at 6,000 RPM.
Yeah.
We probably won't need to spin it at 6,000 RPM. Even like to shoot the full field, I bet we will be under.
Yeah.
But
I wonder if well, no, that wouldn't be possible. For some reason I was thinking that that it was in the rules that was limiting the motor power, but it's just the motor itself not being able to go over 100% power. So that was
Okay.
on
I'm gonna set up this real quick
My
and we can listen to it.
bad.
yeah.
Oh, there's still a problem how the
Whoa.
ball will get up. That's actually kind of a good point.
Yeah, we definitely haven't solved that part of the problem yet. It sounds kind of like
I know.
one of those screws might be loose.
The
I heard
vibrations
that.
might be just wiggling it loose.
It's possible. We'll
Like
check.
on airplanes, that's like one of the biggest things of failure. Just screws like actually just wiggling loose.
Yeah.
Yeah, that makes
I
sense.
have to like design jets in a way so it don't come undone.
Yeah.
Yeah, that's.
Oh, I bet it's the E-clip.
Oh yeah. That sounds like where it's coming from.
I could definitely see it just being the E-clip because that's not really like constrained in any way.
Yeah, that's another big factor of building robots, like the screws falling off and then you not knowing where they came from.
Yeah.
That's why it is sometimes good to use thread locker. Just don't use too much.
Yes.
Or you'll never get your screws out.
Correct.
Yeah,
There's also just a lot on this robot that could be vibrating and sounding like a loose screw.
and that might be a bigger thing in this season.
Oh, yep. I
If
hear something, but I don't hear that anymore.
Yeah. Okay.
Seems fine.
Seems fine.
It won't like explode or
I don't
anything.
think that this collier is balanced, and that honestly could be it too.
Yeah.
Do you think that while it's driving and this flywheel is spinning so fast, it might create some sort of gyroscopic thing where it drives weird?
I haven't noticed it with the starter bot, but it's possible. I mean,
because
I could see it.
Because
I might be making it up, but I
because-
could see it.
I feel like the
It would definitely be more evident with a heavier flywheel.
Yeah.
because like when you have a wheel like that, I'm pretty sure it like just makes it harder to turn, right?
Yes.
So
like
it could
that's
just-
how a fidget spinner works.
So it could just make it where if you're like tuning a pathing software or something, you just have to like give it more turning power or something.
Yeah.
Putting a motor in the middle between the two columns will help.
Where?
Okay. I think that'll make sense in a couple minutes when
Yeah.
I'm thinking about it more. I do like the idea that our motors could be here. This will be a nice place for them
Yes.
when we get to design the next version of this.
Yeah.
I think that seems pretty close.
I feel like we might just need something grippier here.
That is very possible.
What about?
Well,
Okay.
you try to
hear
spin
me
that
out. What
and see.
about
Yeah.
a shaft with the those rollers, those like rubber rollers that you just slide onto the
Oh, like the little.
like we
tiny-
used for our
yeah,
intake.
I know what you're talking about. They're just like a rubber or like sheath on the outside of the shaft. They're not actually a gecko wheel.
Oh, I see what you're saying. Yes,
Just having like a bar with those on it.
that might
held in
work
place.
really well. Yeah. Yeah, because it would I think it would work better if it doesn't spin. Do you have a couple of 8mm screws I could steal?
Here, I'm pretty sure.
I have some right here.
I think these are 8s too.
Yeah, that looks right. At least those two are. I think I'm just gonna do one, and we'll see.
I guess it could be hard to tell if they're 9s. Like
Oh, that's true.
the 2mm steps are big enough that they're easier to see, but when you start doing the 1mm steps in between them, then they can get harder.
This is an 8 because it didn't collide. Okay, that's at least fairly well in place. If we can do it at an angle like this, oh yeah. I mean, honestly,
Interesting.
Something grippy would help, like
Yeah.
the rubber. Wait, what if we wrap that channel in surgical tubing?
that's pretty good.
Yeah, or even just the tape.
I might just try tape quick. That
Yeah.
might help. But surgical tubing is a good idea because we could like split it down the length.
I don't know if you have any, but even maybe like a foam tape.
Do my comments
that
help
we do
you?
have
They're like a little vague.
Anything helps, really.
All right, gaff tape. Oh, close. Gaff tape kind of works.
The comments do help.
Let's try surgical tubing.
Yeah,
I
the
think I
comments
have
do
something
help.
over here.
Yeah, I feel
But like I said, little vague. Little vague.
Or I think we have those intake rollers. Yeah, I think this is a good idea. So I bet if we split the intake roller, we can slide it over the side of a piece of low side channel.
Are we going to?
Yes, thank you for the comments.
I don't know. I think that would definitely help long term. But if we like cut it in half, not in half, but if we cut like one of the sides open, I can't think of the best way to describe that. So that it's like a C. I wonder if it will like
Oh.
set. Oh yeah.
Whoa.
That's cool. That's funky. I think that would stick well enough.
Yeah.
I don't know what you would do. Like, I think there would be better. It'd be better if there was a more permanent way to install those. Maybe
Yeah.
it would be a zip tie.
Yeah, or you even just gluing them, but then you'd have to worry about them stuck to your channel if you ever ended up reusing your channel.
Or we could do a just even a like a 2. Instead of having the plate here like this, we could have we're still in the same holes, but shafts with those on them.
Yeah, I think that's a pretty good solution. Honestly, I think that's where we should probably end up.
You need a slope, and you need to reduce the slope at the top.
Yeah.
Yeah.
Yeah, I think getting the contacts closer to the ground would help us on this. For sure. Which we can do with a piece of polycarb. Like, okay, so that's pretty cool. That definitely does work. That's fun. Okay. So there is on the underside now intake rollers that were cut and they just set over the channel. I bet you could hold those on with zip ties. I think that the better solution is a shaft that's fixed that just has the intake rollers on it. But that works.
The way that this levers it, it feels like the ball is going to be trying to pull them off.
It does. Yeah, half of them are, or one of them's on there anymore. But we have the right idea. We have the place that needs to be, and I think what the next thing we should try to do is apply power to this with a motor and make sure that we actually can like go and intake a ball off the field.
Yeah.
I think that'll tell us like, will this intake height work? Will this kind of wheel work? And will this backdrop system, the distance work? And then we can rebuild it to be correct. Like this is very much just throw it together and make a prototype. So it would be awesome if we can power this with the motor somehow. The easy way is just a coupler with a motor on it and we can just hold it.
Yeah. What RPM are you thinking? Like,
I don't have any engineering answers for you, but vibes say 1120. Seems fine. Let's try it.
Great.
I don't know why I feel that, but
is that the next step after
Let's try it.
435?
yes, it's one step faster than 435.
It's interesting that the that it jumps from 435 to 1,000.
Yes.
Just because the gears, like, legitimately just physically can't do anything near 500.
Yeah,
That's
it's really
interesting.
hard to create that ratio with the planetary gearbox. So all of our gearbox stages are built with either a 3.7 to 1 stage or a 5.2 to 1 stage, and you build a combination, use a combination of those to create whatever ratio. So 19.2 to 1 is the 312 RPM, is a 3.7 to 1 and a 5.2 to 1, and a 435 is two 3.7s. So the 3.7 to 1 has about the 3.7 to 1 has about the smallest size planet gear we can fit on the shaft. There's a 4mm shaft that the planet gear spins on. If you make that smaller than 14 tooth by much, yeah, I think it's 14, then it interfere, like the gear just gets too small, the walls get too thin. And if you, on the 5.2 to 1 ratio, the pinion gear is an 11 tooth, and that's about as small as you can make it to fit on the 1/8 inch shaft from the motor. So you kind of run into a limitation either way. You're trying to make a ratio that's either a single stage that's more reduction than 5.2, or you need a 2 stage that's a lot less reduction than 3.7, and that just requires you switching, just pushing it in a direction that's hard.
Oh, wow.
Perfect.
That works pretty good.
That is
I
pretty
think
good.
that I just we need to put a screw in that side.
Yeah.
Oh, where? Oh, okay.
Yeah.
How long?
An 8mm.
Perfection.
And if you want a gear ratio in between, you can just use gears outside of the motor.
Yeah, it's annoying. It would be better if there was a ratio in between, but the specific sizes of all those gears make it hard. It's hard to make like a 2 to 1 in a planetary, or 2.5 to 1 or something like that. And it's hard to make a single stage like 8 to 1. I think that's what we would be looking for that like 600 RPM. It's been a sec since I looked at all those numbers. Okay, I think the next step is to move over to the field. We might test this just one more time. All right, so that's a pretty low speed for this.
That almost.
Whoa.
If the flywheel had been spinning, I bet it would have launched.
I bet it
Yeah,
would have.
would have.
I'm pretty happy with that. Nice.
That's gonna make it.
Well, and we'll test it on the tile. Like,
Yeah.
the tile makes more of a difference than I almost ever think. It's so like the specific ratio, like amount of grip that the game element has on the tile can change how intakes work sometimes. But this looks great. Nice. Okay. Yeah. Let's try it. This is also just generally a cursed way to mount this motor, just so everybody's on the same page. I only do this for like prototyping for 5 minutes because it's very wrong. Okay, do you want to grab this battery and we'll roll over there. I genuinely have no idea how far this is going to shoot or in what path or anything like that.
We'll find out.
But let's try the intake first. All right, you saw this battery. Sweet. And then if you'll scooch over on this side. Thanks.
This is so cool. I love this stuff so much.
This is the fun part. All right, let's try to drive the robot into one. That's another variable that's easy to miss when you're prototyping this stuff.
Yeah.
Oh yeah, that's great.
And it just
We
picks
could
it
all-
up the second it touches it.
Ooh, we could also have something like that goes like this. To keep it from going up how it's been doing and
Yeah.
going.
Because it would not be great
Yeah,
if the
yeah,
flywheel's
yeah.
spinning and it just hits the flywheel. Like,
Yeah.
nothing about that situation excites me. So
Also, this is looking right now like a single. It can only hold one.
it does. I think that's kind of an intentional thing. Like, I think we should redesign it.
What if we
and
have
make
our
it wider.
magazine go up here somehow?
I could definitely see that working. I could see us being able to fit 2 or 3 tall here and then be able to feed them back down in.
Or maybe even like too tall, and then like one off to the side. Like
Yeah.
maybe it goes into like a too wide at the top.
I was thinking about this while you
Yeah.
guys were eating. I could see I could see us making this wider, where this is 2 balls wide, and then we kind of have like a switch on a train track, where like there's a servo that diverts the ball into the left or the right side.
Oh.
And then the third one could maybe just sit there in the intake until we're ready
Yeah.
for it to go
Yeah.
up there into the feeder. I could see that working.
It could even be something like a fully mechanical thing,
That'd be cool.
like those marble run.
So cool.
things
Yeah.
Where once it goes through, it hits it and it switches
That
back
would be
the other
so
direction.
cool. Where it just like you have that switch and it's got like an L, and so the ball goes through and then it automatically pulls it this way, and the next
Yeah.
one goes and does that. That would be really slick. Okay, that's the intake. I like this intake a lot. I really don't think that's going to be the hardest part about this. I think the intake is going to be an easy part.
Yeah.
All right, I'm going to give you this. This is the flywheel speed.
Yeah.
There we go.
You probably want to go watch out. Try not to get hit in the head with the ball.
Yeah,
Exactly.
I'm gonna move just a little bit more this way.
Yeah,
That's
That
pretty
was pretty
far
low. That was.
Yeah, way far down. Okay. We can give it a little more. I mean, I like the rest of that. Just
Yeah.
that last part is not great.
Yeah.
Let's go ahead and try to change that real quick. I
Yeah.
think that's going to be easy enough that we can modify it on the field quick. Just
Yeah.
I just got that.
Probably just move this bar back.
Oh yeah, I didn't think about that. Is that? Oh, that's sturdy.
I'm pretty happy
This
with
looks
that.
flimsy to me.
It
That's
does.
actually really sturdy. Wow.
It's pretty good.
We might have to use some of these sometime. Those
Yeah,
are
I like
them.
cool.
We probably all we need to do really is just move this back.
I think so.
Those are really cool.
I guess I'll unplug the motor.
Yeah, I don't want it to start spinning while your hands in there.
Thankfully, it doesn't have a lot of torque, but like
Yeah.
touching the flywheel while it's spinning would hurt for sure.
Oh yeah.
Yeah, it's like that's the power of the flywheel. Like it has power because of its speed, and
Exactly.
not because of the torque.
Exactly.
It's just that kinetic energy from it spinning so much. I keep getting kinetic and whatever the other one is mixed up.
Potential energy?
Yeah. It's not. I know it's not potential. This one, but
I got
think
the
it's-
other screw.
Isn't it kinetic? I think it's
Kinetic
This
is
feels
when it's
kinetic to
moving.
me, yeah. Do you want? Let's see what happens when we don't have the
Oh,
bar
yeah.
there. Let's just try it.
Okay.
I don't know.
Yeah.
We can
might-
see.
Doesn't take
It
much
might-
time to try.
It might just actually fully work.
That would be so funny.
Wouldn't that be classic? We just over constrains the system.
Closer.
It is closer. Oh my gosh.
You almost made it. That's pretty consistent.
That's pretty consistent. Okay.
Okay, that one came out.
Yeah, that's just it had too much force and just bounced out.
Let's slide over so we're actually in the right zone. I didn't expect us to be like
That
making
close.
That's
shots.
actually crazy.
That's sweet.
Day one in making shots.
Hey, okay, to be fair, we probably should be making shots day one, given that we only have 3 days.
Yeah, that's true.
Yeah, I agree.
but making shots on this early of an iteration.
That's some backspin. It just came right back. Boom. Okay, we're using a lot of motor power right now. Is the other thing. So this is not optimal in some way. Do you want to grab another ball? I'm out. But I like this. I think this has some good potential. I'm adjusting the motor speed. Boom.
That one seemed like a good speed. Yeah, that seems pretty consistent.
Oh, that was me.
off.
That was me. I didn't feed it straight.
That one almost went over it.
It did almost go over. Okay.
That's another concern about launching it from this far.
Yeah.
Is that it has so much force it can bounce out.
Yeah. So something that FRC teams did in.
What about just
John,
launching
what am
it?
I thinking?
Sorry.
What's the FRC game where there's counter backspin? 2023. Rapid React. There we go. Teams would have another wheel up here that was counter rotating their flywheel to take some of the spin out of the wheel, out of the ball when they
That's
shot it.
interesting.
So it wouldn't bounce out. It was fascinating. I really don't think we'll have to do that. I think that we could get one consistent. This is pretty consistent for being something that's like half of this thing is fully unconstrained.
Well, okay, what if we,
Let's get some longer beams quick and try to constrain this and see if we can get it any more consistent.
Ooh, I have an idea. Okay, what if we shoot it from, if we're trying, I think that if someone was going to do it only from here and not over here, best option would probably be something that shot really, like, a really high angle.
Yeah.
That goes just straight down into it.
I could totally see that being the best bet.
The one concern with that, though, would be that when you're shooting at that high of an angle, like motor RPM and stuff would make more of a risk of like falling short or going too far.
Yes.
That's true. You kind of have a shallower target, honestly.
Yeah.
I'm interested to see. This is pretty interesting. Thankfully, motor RPM is pretty easy to control. Did we take a chunk out of this?
Oh, what?
We did take it.
We did.
Lily like shaved it a little bit.
How did that happen?
I don't know.
That's interesting.
It wasn't me.
It's probably something random here, like an interaction, like a seam or
maybe one of these.
Well,
Screwheads.
there's a sharp corner right there.
Oh, that would do it. Oh, I'm sure that's it.
Yeah.
Yeah.
I'm sure that's it. Okay, cool. Well, we'll replace this polycarb piece not to be the one I cut up for the video, and that'll help.
Okay.
That's one of the things about using parts from up in R&D is like they all have a history, you know?
Mm-hmm.
They have a story. And sometimes that story is that they were used in a video. Sometimes that story is that I lit an ESC on fire on top of that piece of channel, which we found that piece of channel earlier today. Ooh, I like this. I like that we have more option here.
Ooh, that's...
I also just generally like
I got some screws.
I like having more of an angle to this support.
That actually...
It looks nicer too.
It looks nicer.
Right
does.
here actually looks like a good angle to me.
Yeah. Do you want to install, I think Chris has got those screws.
So, yeah.
Yeah, if you want to install the first one. And then I have the longer beam.
Okay, where do you want it?
Okay.
Yeah.
I think right here. Yeah, this has...
Okay, well, I just dropped that one, but...
like Ethan said earlier, I think right here has some good vibes.
It's vibes. At this point, we're just prototyping, so it's vibes.
Yeah.
I think that this like part of the launcher is pretty far out of the way. I would be really interested to take a slow-mo and look at it and see. Slow-mo is one of my favorite tools for robotics, honestly. Like, it just gets you a better understanding of what's happening. It's kind of hard to catch everything that's happening in like an iPhone slow-mo.
Yeah.
But it
There we
helps. We are way outside of the 18 inches now.
Yeah.
Way too tall,
Shoot.
but that's okay.
There you go.
That's the implementation stuff. We're just figuring out ideas right now. What does the chat think?
Is chat happy with the design?
I don't know. They haven't really mentioned yet.
Chat, are you happy with the design?
Yeah, let us know. Give us your honest feedback. What do you think so far? I think we're on a cool track.
So the 6th hole.
Right.
Yes, that one.
there.
Perfect.
I'm liking this.
I
This
think you
is
need one of
so-
these screws.
This is so cool.
This is...
Oh, that is.
Right? Wait. Am I tweaking?
Is it long enough?
Hold on. Maybe I'm wrong.
No, it's correct.
Okay. 1, 2, 3, 4, 5, 6.
Yeah, that.
There we go.
Yeah. Right here? Yeah. Yeah. Yeah.
I think
Yeah.
I need to. Actually, never used one of these little blocks.
Yeah, those
before.
are actually so cool.
With our switch, our chain switch idea, that could technically be on a servo, and then you could have a color sensor on your intake, and you could say the left side's for green and the right side's for purple, and then it could just like automatically divert it to the right chute. That would be pretty fun.
That's so cool. Okay, right here.
Okay.
Yeah, that's right. That would be really slick. I think that's the way to go. That's
Yeah.
weird. I did not expect to end up with this, with that being the robot architecture for this game, but I think it's pretty interesting. I still don't know, like there's a lot that needs to shake out in the Q&A on the end game, on like what kinds of...
Also, in-game is only 20 seconds.
Endgame is shorter now. I think that's better. You
Does
don't
that-
need
Does that
30
mean longer
seconds.
auto?
No, I think auto is still 30 seconds.
That's in the wrong hole.
Shoot.
It's just, I guess, it's the restriction here is
What
that
do
you
they add
have
time
to.
to?
Huh?
What do they add time to?
Just I think teleop. I don't think they actually changed the duration of the driver controlled period. They just made it so that you can't start endgame until later. But really, the only thing that starts happening in endgame is that you can expand higher than 18 inches.
Yeah, and honestly, I don't think that it would even be worth going for it if you can't do it in that amount of time.
Yeah, your endgame needs to
Is that
be
the wrong
faster.
screw?
I think it might be.
That was the wrong screw.
Hey, that's okay.
I need to swap that one and that one.
Let me get you another 8mm screw.
Okay, thank you.
This is so cool.
It's so fun when it starts working. It's okay. The next step is going to be taking it all apart and making it work again different. So it'll be less fun here in a sec. Just in case you were worried it was too fun.
Man, this was too fun.
Man, this is just too good. Like, this needs to work worse, I think. You got it. Yeah, the ball end just makes that harder for sure.
It kind of does.
Yeah, so I think one of the things I like the most is I like lifting this up and then doing that, and then you can line up the threads.
I should have done that first.
That's okay. And then, yeah, if you keep pressure on that, and then just start spinning the screw. And then you can line that up. And then that just, the threads just catch and it goes right in.
There we go.
You got it. And then this one's a little
Nice.
loose now, but that should be easy.
Okay.
You just tighten this screw up too. All right, we'll try it
There we
again.
go.
I'm interested to see how this changes our trajectory. This kind of goes up
will be pretty
now.
interesting.
Yeah, I feel like we
might-
definitely want to probably just shorten this.
Yeah, I think that a lot of this is unnecessary. All right, do you want to try some more shots?
Yeah. That seems like a fairly good
Interesting.
trajectory.
That's nice, yeah.
Okay. Whoa.
Too far.
Not far
Definitely
enough.
going to have to be able to fine tune
enough?
it.
Yeah,
That one was
That
close.
was close.
that one's pretty good. So that'll be the nice thing when we go to the rev hub on this. Like, we can just say what's the velocity the motor needs to hold, and it'll just hold that velocity.
Instead of being motor power.
Yeah.
That's fairly consistent right now.
It is,
Yeah.
yeah.
That's the way, dude. Woohoo!
So I really
it's
like how
that
like
corner every
I
time.
really like how that the ball stair steps down the
Yeah.
other ones.
I know, it's really satisfying. All right. I mean, that's great. Like, so we have a consistent shooter. This is really pretty good. I think the next steps are really going to be specific to the implementation. Like, ideally, like this used to be way shorter because this is like
Yeah.
24 inches tall.
Honestly, I think that we could just take this all off
I
and
bet
cut it
we
right
could.
here and it would be the right angle.
Yeah.
I bet we could. Do you want to just try that quick?
We could.
I think
Okay.
that'll inform
I
more,
think
and we're
it'll
gonna
work.
throw this plate away anyway. So, or we're gonna recut it. We're gonna cut a new one. This tells us more, and so we're still getting information.
This is so cool. I love this so much.
This is it's fun.
It's fun when things work out like you want them to.
Yep. I think this is also like this looks like it's harder than it is a little bit. Like
Yeah.
this objective I don't think is as difficult as
Yeah.
it feels like it should be.
Chat, are you liking the design?
I should have checked chat when I went back over.
Can we just
Sure.
flip that board?
Sure. I like it.
It looks like a rangefinder from Star Wars.
It does.
Way more.
Whoa.
Okay.
Little too far. A little more.
Sweet.
Right
was pretty good.
there.
Sweet.
That seems to be good because it's doing what Gage is saying about it kind of falling in instead of hitting.
Oh, that one jumped right out.
Yeah. That may just be a trade-off to having this far launch. Not because
I think the far launch is the play.
I think it will be faster cycles. Let's see if we can get a close launch. Let's roll over there.
Yeah.
If we found 2 screws. I wonder where those came from.
And another thing is with how it was bouncing around in there more though. The that bouncing makes them take longer to go down the classifier ramp, which means you'll not be able to shoot them as close together when making
That's
your
true.
motifs.
That's true. That's a great point.
I think this feels good.
Yeah. So then the trick for this is you can slide it in and you can just put both of your hands fully under the ball and then feed it up.
It may be too low of an angle for. Oh, I guess not.
Okay. That's a crazy way to get there. Oh. Boom.
It does look like it works from
That's
here.
gonna work, I think.
So
I
it
think
looks
we
like
got
with this
it.
design, we can do close and far launch, which just by adjusting the speed,
That's
Yep.
crazy.
which
Yeah.
is what's going to be the best.
You
That's
think we
awesome.
can just measure this, see if it's compliant?
Yeah, I think we are now. I'm pretty sure.
So that means that if we took this bit off right now, like actually, and if we got this motor working,
Yeah.
this robot actually could probably technically be a legal robot that worked fully.
It's so cool.
The design is very human.
Oh yeah, this is no problem.
That's such a good. That's an amazing
44.
reference. I love that reference so much.
440 mil. We're like 430. Oh, we're barely under, but we're under. Right? Isn't it 450?
100 millimeters
I think it's
is 4
456.
inches.
Yeah. Let's just I don't 457.2. Oh yeah, we have like 25 mil. We're fine.
Wow, that's quite
So,
a bit.
We just have to make this work. Like we just have to then take this and then make it into a robot that works.
Yeah.
But the bones of this robot work. The concept is there. So I think it's turn this intake into an intake that makes sense. And then I really like this idea. Let's draw out a little bit more just to make sure at least that there's a little bit more. I'm going to use the blue one this time, I think, because I left the other marker over there.
Yeah, I
So-
mean this intake works. We want to have a feeding mechanism.
Okay. So this is our 2 wheels for our launcher, right?
Mm-hmm.
Kind of a top-down view. So we need to intake into these. So I think we could have one roller intake here with all of our roller.
Yeah.
And then I think we can have a servo with an arm on it. And I think that arm could either go this way and then divert whatever ball we pick up into this side, or it could go this way and divert whatever ball we pick up this way. And then we can say, like, this is the green side and this is the purple side. And then maybe a color sensor in like an actual production version of this robot could detect which one to send it through. I think that's really slick.
I like that.
I think
like
that's
that a lot.
doable. I
Yeah.
think this can fit in the box because we can like, I think this to hold 3, you'll probably will also always have to load these 2, which means you might have to always intake a purple and then a green, but you can still make this work. It's hard to say without like putting it all in CAD, which is kind of outside of the thing that we're trying to do right now, but I think we can make this happen.
Yeah.
I think that works. So for this robot to turn into this robot, with the understanding that we have about an hour and 15 minutes left tonight, we could start building the 2-wide version of this shooter.
Yeah.
I'm trying to think through, because we have these 2 options. We can either look at having 2 wheels, 2 motors that each power their own sets of launcher wheels, or we can have 2 motors that power one central shaft. The upside, okay, if we only have one, I'm trying to think of any upsides and downsides here. The upsides to 2 individual ones are maybe if we only have to launch 1 ball, we only have to spin up 1 set of wheels, which would use less energy from our battery. It's probably more complex.
Yeah.
Um,
Also, you might be able to, like, if you're alternating launchers, you might be able to shoot them closer together because you're
Yeah.
probably going to wait a tiny bit just to let that wheel spin back up to full speed.
Yeah, I think it's interesting, and because I think that's very intuitive. The maybe counterpoint is that if both of the wheels are on the same, you have the same total amount of rotational inertia. You might keep the velocity the same, shooting 2 in a row, even though you have them like. Okay, an upside. Here we go. Here's an upside. If they're connected, right, and you have 2 purples, and you need to shoot both of these in a row, you have more rotational inertia from a combined system.
Yeah.
So you can shoot these 2 faster, probably.
Yeah.
It's
Yeah,
a
that-
tiny benefit. Like I think that you really can't go wrong, because if you connect them, then you have twice the inertia and twice the motor driving that. So I really think that like your shot-to-shot speed between these 2 is going to be identical. But if you have to shoot these 2 in a row, it is probably faster. 2 motors and then 4 wheels.
It's also just simpler.
I also think it's simpler. I totally agree. It's that is a nice part about it. We can like just have a motor here and a motor here, and like maybe belt up to here. I think that would be really slick.
Yeah, because I don't think that we're going to be able to, like, bevel gears might have too much friction with
Yeah.
or with the 6,000 RPM motor.
Yeah.
Just like that system, or at least it wouldn't be the most
agree.
optimal.
I think so. It's interesting to think about. I like to consider in mechanical engineering the 2 kinds of losses or friction that we interact with a lot. We interact with efficiency, which is like I'm putting X amount of watts in from the output. I'm getting X amount of watts, and my power transmission is taking an amount of that power in friction in the belts, in friction of chain, or in just like general losses. The other side of this is you have kind of a load independent loss, where you have there is an amount of friction that it takes just to spin the belt. Even if you aren't producing any mechanical output, it's like if you're not shooting something and you have spun this up and you just have to spin the 2, like the power transmission, you have a load independent loss, which is just like, hey, it takes this many watts just to move this through. And so for 5,000, like for the 6,000 RPM motors, because we have so little torque, that load independent loss can become a pretty big part of the actual like efficiency of the friction that it takes. So we need a pretty light power transmission for the 6,000 RPM. So we have 2 mil pitch GT2. That's going to work really well.
Yeah.
Because those are really light, they bend easy, and we need basically no torque.
Yeah.
Like they have 28 ounce-inches of torque. It's nothing.
What about I think it's called V-belt.
V-belt could work too. V-belts, or we have round belts is what we call them. They tend to have more load-independent loss in my experience, because you have a pretty thick piece of rubber, and that rubber doesn't have anything that stops it from expanding in length. So on a timing belt, you have a cord of Kevlar, and then you have the actual teeth, which are molded onto that cord of Kevlar. And so you don't need a lot of tension in this to actually transmit torque, because generally the Kevlar can't expand in length. So your belt's pretty fixed. With an O-ring, or with a round belt, its natural state is round, and you need to apply kind of a lot of tension to get it to stretch, and then that can actually start to transfer torque. But that means you're stretching that out, and you have a lot of friction inside the rubber and getting it to turn.
Yeah.
Yeah,
I think those from my experience, timing belts are pretty low friction.
I think that's going to be our best bet. I could see, honestly, like plastic chain would probably work, but it's just not I think it's not my favorite option for something so fast.
Yeah. Plus,
Yeah.
chain just isn't as smooth as belt.
Yeah, belts are nice. They're quiet. So I think that's a good option. I also could see gears working out, but when you're going so fast and you want to minimize load independent loss, you really want to add a lubricant to those gears. And in FTC, stuff gets dirty. And if you have a lubricant that's dirty, it's worse than not having anything. So ideally, I think we'd have like a 3D printed enclosure for a set of gears that's running this fast. So for this, I say let's look at belts. Let's use belts as our way to put motors elsewhere, because I think we're going to need to in order to get them out of the way when we make this twice as wide. We can't just have 2 motors sticking out the sides. It's not going to work. Okay. I think we probably will need a channel that goes down the middle of this. So I think that can be like another piece of polycarb probably.
Yeah.
Yeah. I think that's going to work. I think that for another hour and 10, we can either tear this. I think that we can take this off of this robot. We should take some pictures and then be able to reference what we made. And then I think we start recreating this, but a double wide version.
Yeah.
I think that's it. I like the superstructure. I was not like I thought this was not going to be as sturdy as it is left like front and back, but like there's very little flex there. This is way stronger than I thought it was going to be.
I mean, it just looks fairly nice.
I think it looks nice. Okay, awesome. I love it. This shoots from the places we need. We don't need like an adjustable hood or anything.
Yeah.
I do think that like a really high if you're thinking about this as a team who might try to win worlds, you are probably thinking about a turret to resist defense, but I think that just adds way more complexity here.
Yeah.
I think it's probably too much. Even like you could put the whole mechanism on a turret probably, but it adds a lot of complexity for the 11 more hours we have of building.
Yeah.
Okay, let's do it. Let's start tearing stuff apart.
Great.
I like it. Will you grab the parts we left in the scissors? Sweet. That was a incredibly successful prototype.
Yeah.
That's way slick.
Can you hear the battery, Sam? Okay, let's see how chat likes it.
Oh, sorry. Good catch. I brought the other marker over here. I'll have to use another color the next time.
Currently, we can only store 1 before shooting, but the next design will be... Yeah, 3.
Yeah.
Why am I thinking so hard about that?
It's okay. It's like that. It's not intuitive how the toll this takes on your brain.
Yeah.
Okay. First, let's take some pictures because we're gonna forget. I'm gonna forget. You guys might be able to remember that.
Yeah, they need to have a AI program where you can 3D scan your robot, but it recognizes Go Build a Part, so it makes the actual CAD with the real
cool.
Go Build a Parts in the CAD.
That would be so cool.
And you just like rotate your phone around the robot.
All right, now we have a good opportunity. Oh, I'm doing the thing.
Hi, Eldon. How are you doing?
Let's take this opportunity to organize our workspace quick because we kind of have parts all over, and we have a break, so I think this will be a good opportunity. These channels, I think, can go back, and if somebody wants to take that dual block off. I was doing the thing where I accidentally was charging the PlayStation controller from my driver hub. It's classic. Yeah, that goes up on that wall. And I'm just going to move this driver hub because we don't need it right now. We're not going to need it tonight.
I never would have thought that the Go Build a Motor power thing, what's it called?
Manual, or we call it a motor commander.
Yeah, I never would have thought that would be so useful.
They're really nice.
But like I saw them before we came here. I saw them at the start of the season, last season actually. At the start of the season last year, I was like just for fun looking at the Go Build a website. Just
I'm glad your idea of fun is the same as mine.
Yeah. When I saw those, like, I thought those are the coolest thing ever. But like,
but am I going to use them? Yeah.
Yeah.
Exactly. They're nice. I think the only thing is that
they're so amazing for prototyping.
They're nice for prototyping. They're kind of expensive for FTC.
Yeah.
But they are slick. They can just do a lot more than an FTC motor needs, and that's part of it. Like they're a 30 amp motor controller.
Really?
So they can push a lot of current.
That's quite a bit.
So they're really nice. I've heard from quite a few FTC teams that have picked them up, and it's nice.
What was this motor? Is this a 6000?
It is, yes.
Yeah.
6,000.
Yes, loose screws. It is a 6000.
And I think that's where most teams are going to end up. I could see a world where some teams might overdrive a 6000, might gear it a
How do
little
you
faster.
do that?
You would have a bigger pulley on the motor than the driven shaft.
Okay, that makes sense. Also, I think a like a thumper design, like you were talking
Yeah.
about, would be pretty
I think it could totally work.
good because like it seems like it would do in certain scenarios it'd be faster than a flywheel,
I could see it. Yes,
but
I could see
I'm
it.
not sure. I'm not sure how you would even control the force of it though.
So it's hard to make it dynamic.
Yeah.
It's really hard to change it, but you can. The way you would do it kind of statically is you could just take, if you're going to do it with polycarb, you could take layers of polycarbonate and bolt it together and like laminate it, and then just change the number of laminations you have.
Yeah.
The other variable you have to control is it's how close to the pivots, to the axle your
yeah.
stopper is.
Yeah.
So the stopper, the piece of polycarb has to flex past, and then it like flicks. That's the other. You can make this closer or further, and that requires it to deflect more or less. The other like civil machines is wrong. The other kind of like non-flywheel way to launch stuff is a puncher, where you have like a spring that pulls something back, and then a mechanism that just does that repeatedly.
Oh yeah.
A really neat way to do that is you have a linear slide that your puncher is on, and then you have a gear rack, and you have a gear on the puncher, and you cut some of the teeth off the gear. And so it drives down the gear rack, and then you rotate the motor to the point where it doesn't have teeth on that pinion gear, and it goes, it slides
that's so
past.
cool.
It's super slick. I can't remember if that's. I don't think that one's specific to competition robotics. I think that's on like some paintball guns.
Really?
But you can just run that. The nice part is you can just run that
interesting.
motor continuously, because it's always going to pick up at the same point at the end of the gear rack, and it's always going to let go at the same point at the beginning. And that's just a linear slide and some springs.
Yeah.
There's lots of cool ways to do it, aside from like the siege engine style. Like, all right.
Yeah. Sam was joking about doing a small trebuchet.
I think that's the least practical option for the siege weapon style.
Yeah.
It would be cool. I love a trebuchet. Don't get me wrong.
You could make, and another thing is that these aren't exactly that heavy.
No.
So you might be able to just have like a little catapult that's actuated by a servo or something that flicks it up.
Yeah, Andy Mark's starter bot is a catapult.
Yeah.
It's
Yeah.
pretty. It's a cool. It's a cool option. I like that it feels like there just aren't that many variables to it. Like,
Yeah.
you can control the spring, and the spring is probably going to be about the same amount of force through most of your season. And so, like, you have the variables, and the variables that you tune are just very visceral. They're very real world. Like, you can you change the spring, or you change how far you pull the spring back, and that's just so easy to control. It makes so much sense compared to, like, okay, on a flywheel, I have exit angle, I have like the compression through the throw, I have rotational inertia, I have velocity. I have so many levers to throw, and when it isn't consistent, it's hard to find out why it isn't.
Yeah.
Okay, sweet.
Okay. Now the next thing to do is like take it apart, right?
I think so. It's either take it apart or make a copy of it that does what we need. I think it would be better to try to copy the superstructure real quick, because we can use that as a reference. I think we have a right amount of time.
Yeah.
Let's take the extra bit of polycarb off that.
This?
Yeah.
Yes. And then let's start looking at the parts of that we want. So I like the height. I think the dimensions of this from a 2D perspective, from the side view, are correct.
Yes.
So I think we still need that number of channel
Can't
up.
quite get that one.
I think we just make this twice as wide.
Yeah.
Maybe not twice as wide, but we make it wider.
Yeah.
Wide enough to hold 2 balls, because we have a lot
Oh,
more.
I'm stupid. I can just
It's
go-
pretty close now.
Yeah.
I think that's the right way to make this superstructure. I don't know that I would make it differently.
Except just that basically this channel is longer.
Yeah. I mean, honestly, at that point, let's just change it. Let's just change this. That's going to be faster. Let's just take those 2 pieces of channel off, unbolt it from the drivetrain, and put it back together.
Yeah.
We can leave the polycarb in place, at least the hood.
We'll need a different length of axle too.
Yep, we'll need a different length of axle. The other option is we could make this narrower, and we could build we could build on top of it. I like the idea that we would have some channel right down the middle. Like, I think that makes a lot of I think that makes a lot of structural sense.
Yeah, there is quite a bit of room.
We could make it a lot narrower. We could make it a whole narrower easily,
That's interesting.
and then we could slide it to the left a bunch.
That's cool.
So this is you found the little screw holding feature on those hex keys. It's cool. It's a tiny ball bearing, and there's a tiny spring behind it, and it just like pushes out. And so when you here's a screw. When you push the screw on all the way, you'll have to like push it. It like holds on, and then you can like shake it, and it won't come off.
Oh, that's so cool.
The only thing, and I love it. I like these T-handles a lot. They break a lot right there. If you don't quite put the screw in all the way, and you're just at right at the edge of the ball, you can just shear that whole thing off.
Yeah.
And like it just takes once, and then it's gone. So if there are a lot of
And then you have a regular Allen wrench.
yes, correct. You chop it off with a Dremel, and you have a stronger tool. It totally works the same. It's just like I wish I could convince them to change that one thing.
Yeah.
But whereas they're big and we're small fish for them. Okay, let's go ahead and there's a few more parts here. Let's at least put them aside so we have some more space. And then let's start looking at this.
These?
Yeah, let's just set them over here. I think that's fine.
I'm going to go to like kind of an effort to like sort them kind of.
Perfect. All right.
Where did these come from?
Those are way to the right there.
Oh.
There's like a set of them down and to the left from where you are right now.
There it is.
Yeah, and then there's if you want, there's a measuring tool along the top of that whole plastic piece, and you can set it all the way up against the left, and it should tell you how long it is.
Oh, okay.
Okay, so I think let's work on the launcher first, and then I think we're going to learn more about the shooter, or about the intake. So I like the idea of just making this whole thing narrower and scooching it over. And then we build another set of structure on the right side.
Yeah.
We probably just use longer channels, and we do the whole length. Really, the question is, do we duplicate this? I think we should. We don't need to. But I like the idea, when this axle gets so long, I kind of like the idea of a bearing right in the middle.
Yeah. Like support it.
Yeah, it's over constraining it, but I think that we're fine. Let's... Okay, I like this geometry. I don't want to change this part, but we probably have to.
So the autonomous depends on the final design of this robot.
For sure, yeah. I'm interested to see kind of where we'll end up. We might have I think there will be 2 autonomouses this season, like you've had a lot of years where you have, because one robot will probably start in the far launch zone, one robot will start in the close launch zone, and then they'll probably shoot. I don't know how preloads work this year with 2 robots. You have 3 to preload, right? You don't have 6?
I think you do have 6.
Okay. Then that's cool then. Okay. Let's start moving. Okay, I'm having analysis paralysis. Let's start moving and shaking. Let's cut these 2 zip ties, and then we can pull this bottom piece off. This bottom piece is not geometry-wise
These?
very important. Yep. And then these 2 as well. And then we can free that piece of polycarb. You have 6. Awesome. Okay, that's sweet. I wonder, I guess those 3 are probably from your human player station. The extra 3 that I was thinking of. It's hard to read and fully grok the competition manual in one day. Okay, and then let's just go ahead and unbolt these 4 that hold it down and scooch this over all the way. Before we go and redo all of this, should we think about our drivetrain dimensions a little bit more?
Maybe thinning it.
That's where I would be. If we're doing anything, it should be narrower.
Yeah.
Being 1 hole narrower is nice because it at least gives us a center. We could be 9 hole crossbar instead of a 10 hole crossbar. That gives us a defined middle point in our chassis, which is just kind of nice.
Yeah.
If we were way shorter, we could have a better intake. If our intake could be out in front of the wheels, it's just kind of better. I think we could get there.
Yeah. And one consideration is with the end game, the double arc thing, being narrower would be better.
Yeah.
The question is that feasible to make this even narrow enough to do that?
I don't know. Probably not, because the other thing we're fighting with narrow is this is going to get a lot wider.
Yeah.
So we kind of have a chicken and an egg here, where like we should probably make the launcher and then decide our drivetrain dimensions.
Yeah.
Okay, I keep doing this. I keep psyching myself out. Let's just start changing things. Let's go ahead and I'm going to take 2 more pictures of this hood to make sure we can replicate it. I'm like, we have the hood that works. I don't want to throw it away. Okay.
You can either preload 3 or put 3 in the loading zone.
That makes sense.
That's interesting.
That makes sense.
Honestly, putting 3 in the loading zone might be the play, because unless you know unless you somehow perfectly guess what motif you have before they randomize it, you should always go and pick them up.
Well, if we have our robot architecture, we could put 2 purples on one side and 1 green on the other side, and then you could make whichever one.
Yeah.
You could do.
But then you'd still have to scan it probably.
Yes, you do definitely still have to scan it. Thankfully, I think that's going to be pretty easy. Okay. Well,
or for autonomous, we just shoot them in.
These?
Yeah.
And score a little
then-
bit, and then have the and then either you have the
One of
motif or you
the
don't.
nut drivers too. The wrenches. Sweet. Thanks.
Is there a motif that starts with green?
Yeah.
Green, purple, purple.
Every
So
combination.
there's green, purple, 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 green, and
Purple, green, purple.
purple, green, purple. Okay.
Yeah. Correct.
Okay.
I guess there's every combination, right?
Yeah, there's every combination that you can have with
1 green.
2 purples and 1 green.
Yeah.
Okay, that makes sense.
Place the plastic sheet at the beginning to make the slope steeper.
I agree. The plastic sheet
Yeah.
should start here, and then I think it can like go like whoa, like
Yeah.
up and then down and then up
Yeah.
again.
Yeah.
And then the other thing that we'll have to figure out is we need a feeder to get it from the intake section up and through. I could see that being a few things. I could see that being like a 96 mil gecko that could potentially make contact with it like here.
Yeah.
I could see that working. I like the idea that, so like our starter bot has side rollers to feed it.
Yeah.
I don't like it that doesn't control the vertical angle of the wheel or of the ball. I think that it'd be better if we were able to make it vertical and pushing, the feeder should push down against the polycarb.
That also might be able to make it be easier to make it fit skinnier.
I think it will be. Yeah, I think that's going to be something that we should figure out after we have the rest of the geometry. Okay, so then the next thing, will you guys take out these 2 and then these 2 screws, and then we'll make this whole thing narrower. You can put a crossbar above the intake, that way you can remove the center channel. I like that. We don't necessarily need to, but we definitely could make this taller, and then we could run a crossbar across.
Yeah,
here.
that's interesting.
That's a cool way to do that. I mean, in a perfect world, this superstructure probably gets tied to the chassis here. Because then it's like going to be ridiculously strong. We can get rid of a whole crossbar. Not that we need to, but I guess it makes it lighter. There's kind of lots of options here.
I wonder, do you think a light robot or a heavy robot would be better?
I don't know.
It seems like it doesn't really matter that much unless you're shooting and you don't want to get pushed around.
Yeah, that would be really the biggest thing, is like its defense implications. I think that generally, if you're going to have weight, it should be low. That's a smart idea.
Upper Creek last season in Into the Deep really showed that a heavy robot with torquey motors, they used 1/17s for their drive motors.
Wow, that's crazy.
And
But they pushed.
no one can move them. They're
Yep.
so incredibly heavy, and they can push back so
worked.
hard.
Yeah. And I could see that being a strategy here in this game. It depends on which of the cycles you're going for. I think that, so a thing about FTC being 2v2, just really, 2v2 discourages defense, I think. Because ideally, I think that you should think about strategy from the perspective of if you're the first alliance a lot of the time. When you're talking about designing your robot, I think your goal should be, we're alliance number 1. What are the right strategies that we should target? In those cases, you almost always have the 2 highest scoring robots, and so it's probably smarter for you to play offense the whole time. Where like in FRC, where it's 3v3, you have a second pick, and that second pick probably has a lower scoring potential than the other alliance's first 2 robots, and so they should go play defense if they can do that.
Is there a weight limit?
No, I don't think so. Lots of robot contact when they're shooting from across the field, so heavy is probably better. Yeah, it's totally just like, do you prioritize driving quickly and getting out of people's way and being mobile over being where you are when you're shooting? It's going to be interesting. I could definitely see teams preferring fewer ball cycles because you would be maybe less susceptible to defense. If you're grabbing one and shooting one, like it is not worth it to go and defend that team because you have one shot to mess up potentially. Or if you're shooting 3, it's a lot more worth it to go and smack somebody and try to mess up their second 2 shots. Okay, I think the next step is let's just go ahead and take these 4 screws out that hold the superstructure on and then scooch it all the way over to the left. And then we can build onto that to the right. And we're going to guess wrong about exactly where that should be, and that's fine. Because like I think where it's better to guess wrong and move. Here, I can hold on to this side. You might need one of the T-handles. I definitely did give those a little bit of torque.
Yeah. Hold on. Try this one.
Sorry, didn't mean to elbow you.
You're good.
This is the struggle when it's like, okay, we have one robot to work on between all of us. It's like, there's definitely not a lot of stuff that can happen parallel.
Yeah, that's... As much as I love FTC, that's one of the good things about FRC.
And you could definitely run your FTC team like an FRC program. You could CAD it all, and you could have a manufacturing team that makes the part, and you could have an assembly team, and you could separate all those people out. But like, kind of the beauty of FTC is like you get to do all of the steps that you want.
Yeah.
Like if you want to CAD it, you can learn how to CAD it. Okay, and then I might need help like aligning this, but I think that's where we should put this, like on the very last hole up there.
Yeah.
And then we can build on to the rest of this.
That kind of is the only place.
You can use those same screws if you guys want to screw that in.
Okay. So where?
It should line up the top 2 holes there.
Okay.
They'd be on the 32 millimeter pattern is how I would describe it, but it's kind of requires some context.
Okay, go to the left. There it is.
Perfect.
I think that's going in. Yeah.
How many FTC members does it take to screw in 4 screws? 4, I guess.
Apparently 4, yeah.
Okay, I did not get the other one tight, so let me
That's
go
okay.
back
That's
to that
perfect.
one.
And I think you can get both of those tight because we have some wiggle here in the bottom.
Okay,
one.
that's tight. Down a little bit, right there.
Sweet. I guess we're probably going to unscrew that one. Just do one screw on that one because we're going to take that out again.
Oh, that's good.
Sweet. So then we can narrow this one. Oh, this looks silly. This looks so silly. We can narrow this up. So we could...
Is there a...
Let's unscrew these 4.
How much room do we have in this?
At 1 hole?
Yeah.
1 hole is very safe. We can go 2 holes.
Yeah, okay. I'm just worried about it being like too thin if we have 2, but it looks fine.
What looks like it would fit.
I think 1 hole is going to work. So where's this? How are we centered here? The center of this channel is this.
I keep elbowing people.
Yeah.
1 hole is going to be perfect.
So
that's
1
gonna
hole
put
will give us
this-
room for 2 of them, basically.
Yes. 1 hole is the right call. So let's unscrew these 4, or these 8 screws, so the hold that hold these on, and then we'll get one that's the full length. So 2, 3, 4, 5, 6, 7. We need 14, I guess. No, we would need a 13 because each of those is going to be narrower. We're just gonna say it's 13. We're gonna try it.
Yeah.
We're gonna see. It might be wrong. Jeez. Okay. And then we will replace that with one that's the full length, I think. But this needs to go in, this one needs to go that way by one hole. By 4 of the pattern.
It's kind of hard eyeballing these things. I don't know which screws are the same length.
I think they're 8.
It is not a big deal if you don't know. We can just put them aside and get new ones.
I think they're 8.
Is there enough
Yeah.
space to put motors in the center? I don't know where the launcher motors are going to go. We're going to find out. I bet they're going to go forward of the wheels, but if they can go under the wheels, that would be awesome.
Weren't we saying that this could be powered by the flywheel?
Probably, that one should be its own motor because it's going to be a very different ratio.
Yeah.
And we'll probably want independent control of the velocity. Okay, so then the
Yeah.
next step is we need to undo this screw and scooch this all in.
You got it?
Yeah, so we are on the, okay, I got it.
Okay.
If you'll do the screw, I figured out in my head where it needs to go. It needs to be one shy of the slot. Okay, and then it needs to go, you got it. Oh, sorry, I missed it. There you go.
I can see it taking shape.
I think this is going to be it. I don't know. I'm interested. I think there's a world where this double wide just doesn't work and we have to pivot, but I think this is a good idea. All right, does this fit a ball comfortably?
Ball.
I think it does. I could see where we might have to move it toward the center. I don't think it's
Which
going to
way?
be trivial to get the
Okay.
balls to always go in one side or the other.
Yeah.
But I think that's going to work.
Yeah.
That's cool. So there'll be another set here, and the ball will either go left, womp, or right, womp.
Interesting.
I think that's cool. That's weird. This is a weird robot, guys. Okay. Let's go ahead and duplicate this structure. Let's put the long crossbars on. Is that the right length? I don't remember. No, this is not the right length.
Nope.
Oh, it should be...
How long?
That's such a good question.
So we just kind of want it
Can
to
I have a
span the whole width
screwdriver?
of the robot, right?
I'm not sure.
What, this one?
Not the screwdriver, the
Oh.
tape measure.
Because if
Tape
we want
measure.
this to be symmetric, this is all the way to the outside. So
I think we might end up moving this in. I think we should make this the right width for the scoring mechanism, and then we might revamp the dimensions of the drivetrain.
yeah.
So this should be, what is that? I'm going to 10, 156.
I preferred Michiana Premier Event. I'm not sure what Sam preferred.
Out of the two premier events.
Yes.
Yeah, I'd say Michiana too.
Michiana was so cool.
I
That was a
really liked
lovely
it.
venue.
Yeah.
It could have had a little bit more seating in the
Yeah.
competition field side.
yeah.
But otherwise, it was lovely.
Yeah,
It was
like
cool.
the whole parents and mentors.
Yeah, it's better if there's more space. But like back when Worlds was in St. Louis Union Station, there was not enough space for all of the team for people to watch there either. So like, it's worse for Worlds to not have space than for Michiana to not have space. But
Yeah.
okay, so this should be 152, 152 mil.
Mm-hmm.
So we need two. Is it 304? Yeah, 304. 312, which is how many? Or not 312. 312. It's a 12 hole. I think this is double, if I'm thinking about this correctly. I believe that's right. I think that's it. Let's try it.
Okay.
We might be wrong, but worst things have happened.
Here you go.
And then we need another 2, 3, 4, 5, 6, 7, 8. No. 14. 5, 10. I need another 13 hole
13.
and another 6 hole.
I can grab the 6.
Here you go.
Okay, here's another 6.
Perfect. And then this is a 14 hole if you put it back.
Okay.
And then this we need another dual block. Here you go. And then you could use the 12 mil screws and go in from the sides on that one.
Okay.
And then this needs 2 dual blocks. Do we have any more dual blocks over here? Or did we use them all? We have one more.
Here,
over here.
let me give you a stop to make it not roll as much. Is that better?
Where did you say to go in from with the 12 mil screws?
Into the face.
Sam,
of
is
the
that better?
channel.
What?
Is that better?
This?
Mm-hmm.
And then I have 2 more.
Keep
For
from
ya.
rolling as much.
Thank
Yeah.
Yeah, thank you. It's funky. I like it. I like this robot. We can go ahead. We have to take out the shaft and everything, so we might as well start on that.
Yeah.
We just have to disassemble all this. It's probably going to be pretty torqued, so here's a T-handle for you.
Yeah, I don't want to
I
strip
might
it.
be stripping it.
You might just be, sometimes on those, the round ones, you can just turn the key inside the handle.
Yeah, getting screws out that are stripped like that can be a nightmare.
No fun.
Especially in that hub, I don't even know how you do it because like a lot of times when we get them stripped, we just like Dremel out the head so it's like a flat head.
Mm-hmm.
But like since those are inset,
Mm-hmm. I think okay, so from the chat, I think having 2 places to throw the artifact is unnecessary. It 100% is. The thing that we're going for with that is a robot that builds mosaics. No, what is it?
motifs.
Motifs, better.
It sounds like
There have
such
been
a-
so many
it's-
names for patterns in FGC.
It's such a fancy word. It feels wrong.
It literally just means pattern.
I've never
Yeah, but it's the
I've
fancy
never
word for
heard that
pattern.
word until a few days ago.
But
I
it's
do
the
like
fancy
it.
word
It's
for
fun.
pattern, though.
Yeah, it's a fancy word for pattern.
I think most critically, it isn't the word for pattern that we've used 2 other times. And that's the only reason I get it confused. Because in Center Stage, we had mosaics, which did fit Center Stage very well. I liked that. And then in Relic Recovery, we had ciphers.
That's pretty cool.
Right? Yeah, ciphers.
Cypher
Yeah.
sounds more decode-ish, but
Yeah.
It does.
It
And
does.
Relic Recovery was a very similar theme. It was like
Yeah.
deserty and...
this whole season kind of feels like Relic Recovery meets Velocity Vortex.
Oh, it
Yeah,
totally is.
Yeah.
Which is probably why I like it, because those are 2 games I played.
Okay, I got these now.
I do kind of miss, like, I don't know. The theme is cool. I kind of miss when the themes were just kind of wild. Like, Rescue was like, okay, guys, you're on a mountain, and there are dudes ziplining down the mountain, and you can save them, and also you have to stop the avalanche, and you have to put the avalanche back on the mountain, and that's the theme.
I noticed.
It's so fun.
I noticed that the climbers from Rescue
Yep.
are really small and really long-legged relics.
Yes, 100%. That was super fun. I lied. I guess we need 1 more dual block on this one. Is this the same width?
No, I don't know.
It doesn't look like it, which wouldn't surprise me. So that's like 144? Nope, not.
Do we need one more hole?
Yeah, we need 1 more hole.
Oh,
Sorry,
that's good.
What hole?
not bad. 15? Hold on, I'm gonna double check before I tell you to get a different one.
I think you have a 15 on there.
I have a 12.
So 13?
Yeah. Which
Didn't you
makes
ask to
more
get a
sense.
13?
I don't know. Wait. I have a 13. I put the wrong one on.
Oh,
My bad. I have it. We're good.
so confusing.
Next time. It's okay. Thankfully, it's a 35-second swap.
He don't care. He's a happy robot.
Too specific. I'm pretty happy. This is a classic day one robot in 3 days because we have a thing that works and we have an idea of what it needs to look like in the end, and we just have to we have to tear the robot apart again, and at the end of the day one we never have a robot that looks like a robot. And that's okay.
I'm, of course, biased, but I honestly think that Into the Deep, what is top 3 games?
Yeah, it is. It is 100%.
Yeah.
There are lots of games that could have been. I think that Freight Frenzy could have been one of my favorites. It wasn't because of like implementation stuff. The rules just weren't quite there
I've
for
heard
me.
that it was like the game design was okay.
Yeah.
It's just that how it was done was like it makes it top 10 worst.
I think that it
I've
was still
heard that,
pretty
but, like,
good.
I don't know. I really want to go back and watch like
Yeah.
all of the old
should.
game reveals.
They're fun. It's fun to go through.
I
and
actually
watch.
watched Velocity Vortex. That was
Yeah, I've seen
kind
that
of
one, too.
interesting.
It's like 150, 152 center to center, and then we need 152 center to center again. Is this one 3 in from the outside? All right, and then that one should also be about ready to go.
At Worlds, at Center Stage, to me, all of the that was technically when I started robotics.
I was gonna say I didn't realize you went
but-
to Worlds and Center Stage.
Well, I went as
That's
a
cool.
spectator.
Yeah, that's great.
Because that's actually when I was getting into robotics. But then we
screens
just
are too long.
started, and then I got like wishy-washy, and then I didn't start till October after the game had revealed for Into the Deep. But I saw World's Center Stage. To me, they all looked the same. Every single robot at Worlds in finals looked the same.
Yeah,
But
I hear that.
they were all like cubes with finger wheels.
I hear that. Yes.
But
Will the episode be shown again because it's late in my country due to the time difference? Yes. This will all go on YouTube, and you can go watch the recording whenever you'd like. And so that should be on the slot, I think.
Okay.
To make it so that the channels are the same width. We might have to remount this on the chassis so that it's in a different place, but that'll make the superstructure pretty close to the same width.
this is honestly such an insane
Thank
robot
you.
design.
I agree. This is bonkers. It's cool. Cool
Yeah.
bonkers.
Does this actually? Oh my gosh, that's kind of close.
It's kind of close. I absolutely accept that.
You just gotta have faith. It'll fit. Where'd it go?
These tables need like a really small lip on them.
That would
Just
be
a
cool.
really
That would
small
be
one.
cool.
Yeah.
Honestly, you could probably just take the top off of these tables and put in a CNC and just
Yeah.
instead of raising the edge up, just lowering the middle.
Yeah. Absolutely.
Or having like a little ridge, like how some school desks have a ridge for like pens.
Mm-hmm. Okay.
The one on this side looks slightly wider.
It should be because the center channel is not, the low side channel is not centered on the hole. So there's less space on this side than this side. So I guess if anything, this side should be narrower. So we might have to go one hole further in. I think you're right. So this is center to center is 153. It looks the same. 140, 145. This side is slightly wider, and it should be because this channel is further to the left.
Yeah.
Okay. So then we can center this all up, but the ball should fit in this side comfortably.
Also,
We could make this whole thing. Let's just make this whole thing wider. Let's just go. This can go out 2, and this one can go over 1 hole, and then that centers everything. That keeps it centered, and it makes each of the channels 8 mil wider, which doesn't hurt. So if this just goes over 2, this one goes over 1. I think that's better.
Yeah.
I like it.
Let me hold that for you, so it's not like wildly rolling all over the table.
Yeah, that's the only thing about the unpowered wheel.
Yeah. Are the are dyeable grip force wheels ever going to be a thing?
No. So I really loved those. The problem is that they got dirty pretty quick.
Yeah.
So they just like didn't look very great on robots when people built with them. So it was not my favorite option.
yeah, I can see how I've seen like grip force wheels turn from black to more of a brown gray.
Yeah. And like when they were white or like a light color, it was way worse. So
Yeah.
it sucked because I loved all the colors of them, but yeah, this was it. The black rollers are the way to go.
Yeah.
And then that goes over 1 hole. This one should end up in the slots, and then it should be centered.
Okay.
Which makes sense because it's a 13. That means that like we very easily could make this 1 hole narrower, this whole chassis, because then this would be on the outside. I kind of want. I'm really thinking about maybe we should make this more narrow, like
How much more narrow?
We could keep. In theory, this could be the width of our wheels as well.
Yeah.
So this could come in a pretty good amount without really any downsides.
I see what you're saying.
But then how would we
if we can get it a lot shorter, we could
Yeah.
also get our intake out front, and it could be like the full width. That would be very
yeah.
cool.
Yeah.
I think that would be the ideal.
Yeah.
Let's keep building, and we can make that change down the road a little bit. We can keep building our superstructure. We can make sure our superstructure works, and then we can just easily transfer it to another chassis. Here, I can hold this all up for you.
Do you want me to undo these two?
Nope, that one can stay where it's at.
Okay.
We'll just build this off center a little bit because we're making the mechanism the right width, and the
Yeah.
chassis can kind of change later.
Okay.
And then if you just want to slide that screw over, yeah.
Slide to the left.
Slide to the right. Crisscross.
And then if you might loosen that one back up because it'll be a little off center right now. It's going to be hard to get that next one in.
Yeah.
Perfect. I'm really interested to see how close to the regular robot design this is. Like how
Yeah.
close to the robot that's going to win Worlds will this be? Probably not all that close.
Yeah.
But
We
it's interesting.
No one ever thought that an autoclip would win Worlds last
Honestly,
season.
also true. Great point. If you also, while we're down here, just install these two.
I was surprised that I Forgot changed their entire robot design
Did they change it for Worlds or for MTA?
They changed it
for Worlds.
Wow. Okay.
Yeah, that's why they didn't do as good at Worlds, I think.
That's a classic. Like, it is absolutely a classic thing. Like FCC teams do this a lot, where it's like,
Yeah.
oh hey, let's rebuild real quick, and you you have a better design, but like it's less refined or it's less practiced,
Yeah.
and that can do it.
Yeah, less practiced is definitely something that could happen.
There have been a lot of years where a team has rebuilt to our design, and everybody is like, oh, that is the robot to beat, and then it shows up and it's like, hey, like there's not enough time in implementation
Yeah,
for
and
that
then,
to be the robot.
And then you're like, you have a finished robot design, and then you spent too much time on the design.
Yeah.
And then you didn't think about like
Yeah.
Programming.
Yep.
drive practice.
Yeah.
Might have a good design.
Yeah.
It may be the worst thing in the world to maintenance.
Yeah, absolutely. All right, then we just need one more 13-hole channel here. And then I guess we need another 5-hole channel with a dual block. 1,000 dual blocks.
There's
please.
no more in the 13s.
There are no more 13s?
Darn.
Okay, that's fine. There probably is one over a couple build bays.
2, 4, 6,
Yeah. I think that's 12.
This one's a 12.
Okay. We need another 5-hole and another dual block,
5.
which I have.
If
Because then
we-
we'll be the last one of this. Huh? Yes. Here you go.
Thank you.
Yeah, thank you. Okay, and then we need the shaft that goes the whole length.
And how long would that one be?
Like, probably longer than we have.
Don't you have a 3 something?
This should be if we have a 336, I think we do sell a 336.
Probably don't have it here.
Probably not. We sell a 624.
Wow.
Which we could cut. Or we could do 2 shorter ones and a coupler. I mean, the coupler is going to work fine.
Unless we want the
Unless we want them independent,
yeah.
which would work.
Or
Thank you.
well, also
So we're gonna get a new one.
a downside of cutting them would be you don't have the thread on the end.
Mm-hmm. For sure.
So
It would be fine. We don't need it. Unless the only thing would be that we have to cut it, which is just
Yeah.
kind of a pain. It would probably be easier just to throw a coupler on it. It's totally going to work.
yeah.
Sweet. Do you want to roll this one? Let me get you the 8mm screws bucket. That's just going to be easier.
I wonder what the high scores are gonna be.
Oh, I have no idea.
Cause like no one thought it would be like 500 and into the deep.
Oh, no.
But like
Yeah, I remember when we saw it, it was like when it got over 300.
it was crazy
we
when
were
it was
surprised.
300.
It
And
was
then-
crazy when it was 300.
And then 500.
Yeah.
That's 200 whole points, and 200 points was like 200 points was insane.
Yeah.
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 And it was really cool later in the season. I think we did compete in a match where us and our alliance partner got a
Wasn't it like
little over
4?
400.
Yeah.
Like 415 or 425 or something.
For 35?
I don't know. Something around.
Get it? Like
Yeah.
like the motor.
Yeah. But yeah. But it's really cool to like start out your rookie season like less than a year earlier, having that moment where you're like all cheering because you got your robot to move 6 inches.
Yeah.
And then later that season, be in a match that scores like 425 points.
And yeah, and also winning a premier event. Or almost, no, sorry, not a premier event.
Invitational.
Invitational.
Yeah.
Still, not an easy invitational. Like,
Yeah.
that's awesome. You guys did well at state too, right?
Kinda.
We did it fairly well at state. Our robot was definitely a lot more competitive, like after.
Yeah.
It was
the
weird
premier
because
events.
at state, so our robot after state was so much better than our state robot. But our state OPR was the highest it's ever been.
OPR's weird. OPR is super weird. Absolutely, because it depends a lot on how your alliance partner does.
Yeah.
100%. Like, OPR is just weird. I wouldn't put a lot of stock in that, just because it's a funky measurement.
You could have bad matches and have
didn't put that right.
a
Okay.
world's winning robot.
It's so OPR works if you score the same amount of points every single time, and also everyone else scores the same number of points every single time. That's kind of what OPR boils you down to.
Yeah.
It works in the way
It's like-
if you were exactly
Yeah.
consistent, but like it almost never is, and that's how you see teams like negative OPRs. Where
Yeah,
like,
there was a one at Worlds that had like a negative 12 OPR, but they weren't even that bad of a team.
No, it totally is just like, okay, well, if it happened to be that the alliance partners you played with didn't perform super well with you, it's just like, do you score? And it doesn't work with all robot games, too. Like, games where it is progressively harder to score more and more points, OPR struggles. Because if you have 2 really good robots, it kind of is expecting you to score the sum of both of your individual like the amount that each of you adds individually. But that doesn't scale crazy well for like an FTC game where 100 points might be an autonomous. And like, especially we saw this kind of a lot in Skystone. Skystone, you had an autonomous that one robot basically did completely. And then it's like, that messes with OPR because only one of those robots can do it.
Yeah.
So every time you get paired with another robot with a good autonomous, only one of you is running one, and so your OPR goes down because you aren't adding those 2 autonomouses together.
Yeah.
Yeah.
It's it's flawed.
That
Like,
could happen this season too.
I don't know
Yes.
where I put that.
With the only having one goal.
Yes.
I'll get it in a minute.
It's just like in scores, I don't think are going to be incredibly consistent this year. That's one of the reason. Yeah. It's. I think it's just a. It's not. It's a very flawed measurement. The annoying thing is getting good data is an incredible amount of man hours. Like we've done pen and paper scouting. Teams I've been on have done it at Worlds, and it's an incredible amount of data. It's great, but it's so hard.
Yeah, because I feel like we've gone to a couple events where we had a whole bunch of alliance partners that broke down. We helped them fix their robot, but they were like it still wasn't working great in our match, and they got fixed right after the match, so they scored less in our match. Mm-hmm. So then, like,
and then that hurts your OPR.
Yeah.
Because the OPR says this team scores this many points on average, and if they didn't score it with you, it doesn't know if it's because you didn't perform well or if it's because they didn't perform well. So it's flawed. It absolutely is. And that's how it is. Yeah. So
I think you dropped some.
so that's going to we'll have some kind of funnel, I think, that can divert it left and right. I think that's going to work.
yeah, that sounds
I think that's
probably
going to work.
feasible. Like,
So that can sit here.
you could literally just have a servo block,
Yeah.
like screwed on there, and just have a little arm on it.
So
or
yeah,
something like
if,
that on
the
it.
if it pulls in this, there's a bar here, and that just says nope, go this way.
Yeah.
And then if the other way, you get nope, go that way.
Yeah.
And we might use like one of the popular thing for intakes with where you need that is we might use Omni wheels. We have 32 and 48 mil Omnis. That would, as a roller right here, that would allow that ball to go left or right.
Yeah.
Where like a gecko is going to be pretty solid. But like I absolutely could still see where this will be able to feed right up into this left or the right one. I like this. I think this is really, I think we're on the right path. Let's keep working on, let's keep working on the launcher. I think the next thing that we need is the shaft overall. We need 312, or we need 336, which is 168 and 168. But ideally, we'd have one longer and one shorter, I think. Minus 144. Yeah, do we have a 192 right here? Perfect. I think this would work. Okay. So then that's the total shaft length that we would need. And then the motors can be here. It's kind of high in the robot for the motors to be, but it's definitely the best place for them. Let's just mount them there and we can play with it. So we'll mount that motor and then the other one there, like here and here probably. Yeah. The nicest place for the belts would then be on the outside. We can just mount them on quad blocks though.
Yeah.
Let's mount them on quad blocks inset, and then the belts can run inside this structure.
Yeah, because
That's gonna be slick.
that will make it'll look nicer,
yeah.
be less susceptible to other robots bashing into it and like messing up our belts.
Yeah.
And it will make the robot skinnier, possibly.
Yeah, exactly. The only downside about quad blocks is they're an inside part. So these will work well. One hole channels here and here. So let's bolts here. I'll give you this one, and then the other 6,000 RPM motor is right there. And then we'll bolt this one. So we'll just put these on the face, and then we can go there, and then we can go belts down the length. I like that a lot.
Yeah.
So whatever length, 8s will work. 10 mil screws will also work pretty well there. We've also got about 15 minutes, so I think we'll be pretty close to calling it. I think we'll be a pretty good stopping point. Let's see if we can get this working too. So if we have this Okay, Chris, on the top of that box, there will be bearings that have a hex bore. The box to the left. There will be some of those bearings that have a hex bore. Will you get me 2 of the ones that do have a hex in the center?
So, okay.
Which ones?
What are we talking about?
Just a couple of the Rex bore bearings. So, like, this is one of them. So it's got the hex in the center.
Oh, I
and then the
see.
flange. So I think there's 2 of them.
Can you also use the smooth bore ones?
You absolutely can, yep. With the smooth bore, you can hear a ticking sound sometimes.
Really?
It depends a lot on the application, but that's just from like the diameter of the hex is not perfect, like of the Rex is not perfectly 8 mil.
Yeah.
So sometimes with like, especially a belt that has some tension, you'll hear it like click over to the next point that it's making contact with. That's really the biggest thing. That's the reason that we made the Rex bore bearings, is we first started getting exactly. It sounds really unfortunate. These are also better at heavy duty stuff.
Yeah.
Yeah, because although as far as like bearings to have a whole bunch of extra, I'd say that the smooth bore ones are the best, just because you can use them in a few other applications too.
Yeah,
So, but it is good to have a few of the Rex ones.
I think it is. Okay, and then how much of this do we have? I think if we run like a spacer, like we can run like a short spacer there. I'd say like a 2 mil. That'll be nice because we can constrain that bearing and also have the coupler in the right place. So,
Sam, you think that the parking is actually worth it?
I don't. Well, the ranking.
it's working for the ranking point.
Yeah.
Right.
And it's interesting at qualifications, at qualifiers and league meets. Oh, it's super worth it because all you have to do is move both robots off the line in auto, and park one robot fully in endgame. It's so easy. But even at state championship events, I think you still you only have to have one robot partially park, one robot fully park, and both robots move off the line.
Yeah,
which is also very easy. You just have to have one robot that fits in the box and the other one that goes like.
Yeah, and so does that mean that they could possibly have they released what it's going to be at Worlds?
No.
So it's probably going to be high enough that you're going to have to get like that double-decker park to get it.
I think that my guess is it's going to depend on how many teams get it.
Yeah.
I think if a lot of teams are getting it all the time, then absolutely make it a requirement for the RP. But if it's pretty rare to see the double height park, then I bet they say what we had at regional champs is good enough. It depends a lot. Like, I think there's going to be a lot of learning about what the right number of ranking points is going to be. How hard should it be to earn ranking points is going to depend a lot on a lot of specifics. Cool. Okay, that flange needs to be on the inside. Sorry. Oh. I guess this makes sense. This is going to work. And then I need a collar, which is right here. Let's go ahead and at least, can you throw me that stack of wheels with the hub on it? Thanks. We can at least install one of these right now so we can kind of look at it and see how it's shaken out.
That's pretty cool.
I think this is going to be it.
I like how it looks.
I like it. This
like
is
it
a
too.
silly robot.
Yeah.
It's actually so goofy looking, but
It's going to be so
the idea
goofy.
of it
This is gonna be the
sounds like
goofiest
it'll
looking
be
robot
amazing.
there is. It's going to be so cool. Dude, that's it. That's so cool. These are my favorite ideas. The ones that are kind of crazy are my favorite because it's always like, oh, what? Okay, yeah. The 4-bar odometry pod was this. Like, you wanted to make it a 4-bar? Okay, yeah. Let's do it. Okay. It's 21 points at state. I don't remember. I think that's two off the line, one full park, one partial park.
Yeah.
I think it has to be. It's hard to make it a
That's
different
interesting.
ratio than that. So a full is 20 points. Oh, wait. That's also interesting. No, a full is 20 points because it's a 10 and a bonus 10. So I think it's actually just one full. Maybe the 10 bonus points don't count toward the RP. Oh no, the bonus points are for having both robots parked there. That's my problem. Okay. Yeah, the 10 bonus points are for having both robots there. That's,
Okay.
It's our 4 3/4. Okay, let's mount these 2 motors. That feels like good progress, those 2. And they just need to
So those 2 motors are going to mount where?
here and here. And those will power our shooter.
Like, oh wait, that way.
Yeah. That way the belt can drive here.
Yeah.
And it can be kind of inside the channel. I think that's going to feel
Shouldn't
nice.
it be only 1 motor because of if they get off sync?
It will be... we can solve that problem a few different ways. The easiest way is we could use a Y harness for the power, and we can just run 1 control loop.
Doesn't one have to be backwards though?
Yes, we can flip
Yeah.
them at the bullet connectors.
Yeah, we definitely.
I think we can run
Yeah.
just... the other option is we can just implement our own PID loop. The nice part about that is we can just run... like, we can pull the encoder value from 1, and we can apply the same power to both of them. Like, that is probably what I like the most.
Yeah.
It's not quite as awesome as just set velocity, because set velocity is just easy.
Yeah.
But we can run a PID loop.
I've actually
It'll-
never used set velocity. I kind of want... It's an interesting concept.
So, like, specifically the one in the SDK, or just generally you
Just
haven't used one?
generally.
Yeah, it's fun. It's totally the same as like a position PID loop. You just are applying that to the velocity of the motor.
Baron said, "Where's the hub placement gonna be?"
That's a great question.
Yeah,
I
that
had
is
not
actually
thought
a
of
really good question.
that. I don't know.
I don't know. Underneath it,
How are we going to get the
Sure.
other wheel on?
We'll take it all apart.
on the side, maybe.
I can see on the side. I can see on the front here.
Yeah.
I'm not sure. That's
Sitting right here on top.
That's a problem for tomorrow evening.
I feel like the hub placement, it's a lot easier to find a place for that than it is to design everything else, although it is good to consider a little bit earlier.
It is.
We just drag it behind us.
I'm gonna post on the subreddit. Hey guys, my robot will not stop disconnecting. Do you think that it's because of static? And then I post a picture of the robot dragging the rev hubs behind it on the ground. Can you get that round driver?
This?
Yeah,
Oh.
and then I can, if you want to screw in those 2, I can hold the wrench here. Yep. That's the kind of, I feel like that's the kind of stuff that frequents the subreddit.
Yeah. Also, what's it called? What were they? Was it
Perfect, I think that's
spare
good.
batteries?
Batteries not
Smoking-
included.
Yeah, batteries not included. When they do last season they do either a level 3 or a level 2 hang, and their robot,
Perfect.
their battery literally flips out of the robot when they hang.
Every time? On purpose?
I'm not sure.
Okay.
It's such a great coincidence that their name is Batteries Not Included and that happened.
Yeah,
that
it's funny.
it could be on purpose.
I would
But
assume not. That's a pretty...
yeah.
I think that sometimes...
How are we gonna get the spools on there?
Take them back off.
take it back off.
Okay.
But that's tomorrow's probably.
Someone in
Yeah.
chat said we should put the hub under the ramp.
Okay, that actually might be a
Oh,
good
yeah,
point.
they should be back here.
Yeah.
Yeah, for sure, yes.
Yeah.
Oh yeah.
Yeah, the whole
All
open
the
side of it.
electronics could be
Yeah,
back there.
that'll
Yeah,
work perfect.
yeah.
Although you also have
Here
to
you go.
think,
These 2 are ready for you.
battery placement can depend on the weight distribution of the robot, though.
Yeah.
That's a big thing. Weight. Well, it's a combination of weight distribution and like how easy you want your battery to be to access to change.
Yeah,
Because
that's good.
I feel like there's some way that you could stick the battery inside the central channel
Oh, yeah, that'd be sweet.
and hold it in from the bottom.
Yeah, just a
The
piece of
Go Build
Velcro
the
that
batteries can.
works. Yeah.
Yeah.
We also have a battery mount that I do like a lot using.
Yeah.
Like, it's very slick.
I love the official Go Build a Velcro strap.
I do too. We have those individually on the way, so we'll just sell
Really?
those. Yeah.
That's funny.
I think they're also going to be super cheap, so you'll just be able to buy a bunch. I'm excited about those. I probably am not supposed to talk about that, but darn. Cool. Okay, we have motors mounted for our flywheels.
Nice.
We have the actual structure. We need to put together 2 more wheels and then add the power transmission for those. We need to add the polycarb ramps for each individual shooter. I think it's going to be really interesting. I really hope that we won't have to have a different angle of the robot for the different tracks for the full court.
Yeah.
That's looking cool. This has
That
kind
is
of
looking
a
pretty cool.
So cool.
This has kind of an like a I can't figure out what it looks like. It has a funny look with like the two tiers of robot.
It also
It's like a double-decker bus.
Yeah.
Yeah, it is.
it's also just like so cube.
Yeah, yeah. It's funny because like in my brain that's the default FTC robot, but that hasn't been the default FTC robot for a while.
Yeah.
A cube.
Yeah. But this will be the year of cubes because
Yeah.
you have to fit so much in
Because
your robot.
it's the size limit is a cube.
Yeah, and you're encouraged to just fit so much space in there.
Yeah.
All right, we'll do a quick recap of what we did today. We put together a lot of prototyping and we learned a lot about the game. So I think we learned some pretty good things about an intake. We like this ramp. We like friction material here that's going to be more than the scaff tape that we have. We really liked our flywheel-based launcher. It was 6,000 RPM, and it seemed very consistent, even with just like hand feeding it into the ramp. It was landing the full court shots.
And that's the most inconsistent part of it.
Yeah,
the hand
exactly.
feeding.
I think that's why, because like I didn't center it perfectly every time.
Yeah.
I think that's going to be really great. So we took that and we said, let's make this better by being really adaptable to make the different motifs. So we have a 2-sided launcher. That way we can have a servo which can feed specific colors into specific sides. So we can have a green side and a purple side, which means we can create different motifs even though we've intaked the elements in different orders. We have to implement a feeder. We have to create the rest of the actual. We have to put more components on this. We need to put belts. We need to add the backdrops. But I think we're on a really great path. This is a great day one. Do you guys have any closing thoughts? Anything that really stood out from today?
I like where we went with the robot.
I like
Yeah.
this. This is weird. This is a funky looking robot,
Oh,
but I'm
yeah.
excited about it. I think this is going to be really cool.
Yeah.
Yeah, I actually think that this might be the one of the best first designs I've seen.
Yeah. There could be quite a few. If this turns out good in the end, there could be quite a few robots out there that have a similar base design to this.
That's kind of the where the robot in 3 days goes. Depending on how good it is. Also, a lot of robot in 3 days end up being just like the easiest way to solve the problem.
Yeah.
But I don't think this is the easiest way to solve this problem. I think this is a pretty neat one. So I'm interested. I think that the 2-sided launcher is a really neat way to solve this problem.
Yeah.
With the space that we have available. Yeah, I think the big question I'm going to have is like how consistent we can get both sides. I'm really interested to see if like if we shoot the left one, does it need to be at the same angle as the right one? Can we just shoot right and left willy-nilly from the same far zone? It seems like you've got kind of a lot of width that you can play with. You don't have to aim it perfectly, but it'll be interesting to see how that shakes out.
Yeah.
I think that tomorrow our big goals are obviously to get the launcher side working. I think it would also be nice to be able to shrink our chassis a little bit. I'd like it for our chassis to get a lot shorter, for us to make an intake that sticks out past the front of the wheels. And I'd like for our robot to get narrower. I think that it's going to be very possible for the drivetrain to get narrower than the superstructure, where our mechanical wheels could be inset. At least from the back, I think we might run into some struggle with the intake. But it would be awesome if the intake was wider than the mecanums.
I think we're at a good day one point.
I like this a lot.
Yeah.
I think we're at a great day one place. I think that's about all we have for you guys today. We've got a couple more minutes, but we're at a good stopping point, and we're excited to get back at this. Join us tomorrow at the same time, same channel. We've got 4 p.m. Central Time. We'll be back at making another awesome robot. Do you have any final words, guys?
Thanks for joining.
Thank you, guys. We'll see you.
See you next time.